Looks like it's streaming us.
Base behavior now.
Right.
No, not on this. Not on
How's
this
my makeup?
conference.
Let me get the slideshow up at least. There we go.
Well, technically, I haven't started the webinar yet, so I don't know what it's like. I'll find out.
Let's see. Oh, Andrew is not there. I guess is he kicking it off or are we kicking it off?
Yeah, I'll do the intro if you want. But I'm literally going to go, hey, hello everyone, and welcome to 8KB. I'm here with,
Yeah, you
You're
got to
doing
do
it
the
right
David
now, man.
Attenborough.
It's actually live streaming.
Yeah, whoever's speaking is on focus on YouTube.
is it showing the slides now? Cool. Yeah, we've got 2 minutes to go.
I'm gonna hit start here to let people in.
I'm gonna go put bourbon in my coffee.
Do you want to all God, come on, should we just start it and we can
Yeah.
Have we ever done this before?
Casual. All right, I'm hitting start. Let's get this started.
Like an Olive Garden casual? What?
No. No breadsticks here.
Okie dokie. So we have started the webinar, but we will actually be kicking off in just under 1 minute, just to let everyone get ready. So hold your horses. We'll be back with you.
Actually, just let my horses out. So I'm not holding them anymore.
I can't actually see anything because there we are. I have 77 people in already. Okay, it is that time. It is 1 p.m. UTC, and we are back. We are 8KB August 2022 edition. Welcome, everyone. We're really excited for you to be here. I am here with my co-hosts, Anthony Nocentino and Mark Wilkinson. Hello, chaps. How are we doing? All audio
Good.
working? All video good?
Yeah, my audio is a little weird, but luckily I'm not presenting.
No worries. Yes. We are your hosts, but we also have a whole load of volunteers who basically allow us to do things in the background. And so they'll be moderating all the sessions. We have Matt, we have Ree, we have John, we have Bob, and we have Rob, all helping you out doing the Q&A. If you are going to be asking questions, please use the Q&A panel in Zoom. We have a Slack channel as well, just for general chat, and we'll post a link for that if you haven't signed up for that already. So what are we doing today? Well, we have 5 awesome sessions for you. Kicking off in about 15 minutes, we have Angela with SQL Server partitioning, the good, the bad, and obviously, when it comes to partitioning, the ugly. Hi, Angela. How are you doing?
Andrew, I'm good. Good, thank you. Yourself?
Can't complain. Can't complain. Well, I can, but nobody listens. And then at 14:30, remember, all these times are in UTC because I don't know if you're like me or Anthony in particular, we can't do time zones, so we keep it all in UTC. So at 2:30, we have Thomas with SQL Server Storage Options Deep Dive going. This is our only 8192 session. So when we say deep dive, we really mean deep dive. Then at 4 o'clock UTC, we have Edward with Advanced OLAP Optimization with Column Store Indexes. After him, at 5:30, we have Taran, Andy, Aaron, all from Stack Overflow with Availability Groups at Scale, Lessons Learned at Stack Overflow. And then last but by no means least, we have Kate from Microsoft talking about intelligent query processing in SQL Server 2022. So we have 5 absolutely in-depth, mind-melty technical sessions for you today, all kicking off with Angela in about, 30 13 minutes. But we're going to go through some slides here, just a little bit of admin before we get started. So we have a load of resources for you. So the first one there, we have our GitHub account. So we ask all the speakers to upload their content to our GitHub account to make it available to you, so you can grab all their resources after the event. So you can go through all their stuff. If they're doing any demos, you can grab their code and play around yourselves. Then we have YouTube. We are actually streaming live on YouTube. So if you would jump out of the Zoom session at any point today, you can go and view this session on YouTube afterwards. And of course, we will be uploading all the sessions to YouTube once we complete this. The main live stream, I think, Mark, will go up pretty much immediately. And then when we get a chance, we'll pull it down. We are recording in Zoom as well, so we'll pull that down. We'll chop the sessions up, and we'll put the individual sessions up on Zoom as well. We have our website there.
The YouTube live stream is usually ready. It's usually ready to view the whole thing, probably within maybe 10 or 15 minutes after we get done.
Absolutely. So if you miss anything today, that's pretty much up immediately after the session ends. So you can go back and you can go through that at your heart's content. Then we have Twitter at 8kb.com for #8kb. We keep getting in trouble with Twitter for using the #8kb. We keep violating their rules for some reason. That's why we couldn't retweet any of our stuff last time. But at 8kbconf is our Twitter account. Our email, if you want to get in contact with any of us, we have info@8kb.online. If you want to send us an email, just if you want to have feedback from the session, you want to get in contact with us directly, you can do that, no problem as well. And then we have the SQL community Slack. As I mentioned a minute ago, we don't have chat in Zoom. We have chat over in the Slack SQL account. So if you want to go and sign up for that, and I'll post a link to that in just a second. And then finally, we have the event feedback. So we have the feedback for all the sessions and the event itself at 8kb.online/feedback. It'll take you some feedback forms. It's only 4 questions and a comment section for each session. Please do leave feedback for the event and for the speakers. We'll pass it on to them. We always want to get feedback from you. What did you like? What didn't you like? Because we can then improve this event. I'll come back to this slide in a minute because I do want to talk about this community Slack. If you're not in the community Slack, here is a link for you, aka.ms/SQL Slack. That will allow you to sign up and you can join in the conversations happening in the channel there. We have over 500 people in that channel. We'll be talking all day. Please do join us there. Want to talk about, we also run a monthly podcast called Mixed Extents, where we get previous speakers or just experts from the community come and join and talk about little bits of topics within SQL, or we're usually focused around the database engine, and we go off topic sometimes as well. If you want to check that out, you are more than welcome at 8kb.online/mixedextents. Okay, and I haven't mentioned this yet, but we have got absolutely no sponsors for this event. It's purely community funded, and we fund that through basically selling t-shirts. If you want to support us and allow us to keep putting on these events, you can go to bonfire.com/store/8kb and you can buy a incredibly nice t-shirt. So as I mentioned, coming up at 1:15, we have Angela with SQL Server Partitioning, the good, the bad, and the ugly. And that's coming up in, yes, about 10 minutes time. But what I'm going to do is just come back to our online resources here, and I will leave that up for a bit so you can all get access to our GitHub, our YouTube, our web, our Twitter, our email, our SQL community Slack, and obviously the event feedback link. Awesome. So we have 10 minutes. Go get a coffee, get yourself sorted, and we will be seeing you in about 10 minutes. We're just going to have a chat here whilst we all get sorted, ready for the first session, which is Angela with her partitioning session. I actually really looking forward to this, Angela. The first session I ever did, speaking wise, was on partitioning, because I just went through a big project in where I was working at the time, and it's one of those topics that if you don't do regularly, I find the knowledge just goes straight out of my head. I don't know if anyone else is like that, but partition in particular, because there's so many gotchas.
Yeah, and I've listed a few. If I've missed one, out. But yeah, it's one of those topics you can go as high a level or as deep as you want, and you can never run out of things to say.
I just keep going down the partitioning well, as far as, yeah, absolutely.
Yeah, rabbit hole for sure.
Okay, we're all getting a lot of chat in the in the SQL community Slack already. Shane's burritos every single time. What is this fajita nonsense? So, yep, the link for the SQL community Slack. There we go. Please do join us if you're not already in there.
I didn't even notice burritos or fajitas. I thought it was burritos or tacos because fajitas doesn't even really get on the radar.
And burritos are way better than fajitas.
Yeah.
I've just had lunch and I'm hungry again. Burritos, yeah, that'll do.
Is Rob joining us from his car?
We don't know where Rob is.
Where
Looks
in the
like
world
it.
is Rob?
Hello.
He travels.
Are
He
you
goes
in
here,
your
he goes
car?
there.
You are in your car.
Might be. Here I am in my car.
Wait,
Love the
really is?
dedication, Rob. Love the dedication.
Well, I'm getting to go and watch Not Cricket with Chris Taylor and Jess Pomfret and Mikey Bronowski. So,
Are you going to the 100?
yeah, I had to do a bit of both.
I love the 100. I was against it at first. I was like, we got 2020. We don't need the 100. And then I started watching it. It was like, oh, I kind of like this. It even got Ursula into cricket as well. So I can't complain.
Yeah, as long as they'd be,
No, we just lost Rob.
as long as they'd be cool at cricket, I'm fine.
Oh, we're seeing people ask for the shirts. Where's the link for the shirt? There we go.
Hopefully people in Slack aren't getting confused and trying to order Rob's beard.
Okay, we'll give it another 3 minutes, Andrew, and I'll take these slides down and you can bring yours up for the start of your session.
Yeah, all good.
No, don't do that. Mark, this you did kick the recording off, yeah? Just saying.
Yes, it is recording and streaming. I did my jobs.
I'll get the link to the streaming out on Twitter once Angela's session starts. So if people want to just jump in there, they're more than welcome. Cycle through some of these. Go. There we go.
Awkward silence.
Yeah, so we always give it 15 minutes, but I think probably 5 or maybe 10 next time.
Yeah.
The only problem then
Yeah,
is
maybe.
trying to work out the sessions throughout the day becomes a bit more of a challenge, because I don't know about you, but I can't add up. The second someone says, oh, it's 75 minutes long, no.
Does not compute.
Yeah, pretty much. You're like, oh no, that should be 4:30, but we need to put the break, and just no. Right, okay, so we got about 2 minutes to go, everyone, to Angela's session. So what I'm going to do is take this down. I'm going to stop my share. And Angela, if you want to grab.
Yeah. There we go.
There we go, excellent. Yes, can see your first slide. So we'll give it 2 minutes and I'll introduce you and then we can kick off.
Cool.
Okay. Okay, and that is 1:15. Welcome everyone, and this is our first session of 8KB August 2022 with Angela and Partitioning, the good, the bad, and the ugly. Take it away, Angela.
Thanks, Andrew. So yeah, my name is Angela. For those of you who haven't heard my very infrequent presentations before now, I'm a DBA by trade, but I used to belong to the dark side, aka DB developer. Sorry, guys. I work in SQL Server, so this presentation will be from a SQL Server standpoint. So please don't ask questions about Postgres or any of that, because I don't think I can answer. I'll be going into a very high level of SQL Server partitioning, go through some of the concepts and of course the gotchas, because yeah, there's good, there's bad, and there's ugly. So we'll start with a high level view of partitioning. Like, what is partitioning? I'm sure some of you are very familiar with SQL Server partitioning, but for some, this may be a new concept. So I'll try and have something for everybody. I apologize if I do put anyone to sleep, but I hope this does prove to be an informative session for most of you anyway. So what is partitioning? Basically, as the name suggests, SQL Server partitioning is where you break a very big table down into smaller parts or partitions. That's sort of what as simple as the explanation can be. You have different types of partitioning. What I'm going to be talking about here is horizontal partitioning, where you're breaking it down, you're dividing it by row. You do have a concept of vertical partitioning, where you divide by column, but out of scope for this session, but it does exist. Horizontal partitions, any examples I reference will basically be using dates, since it's the most commonly used, I guess, use case for horizontal partitioning. But you can partition by anything that you need to. Most data types will work. Just a note on the vertical, if you are doing vertical partitioning, you do need a link between your tables or your columns. Just make sure all the data stays tied together. But here we'll focus on horizontal only. It's the most widely used. So yeah, let's get into it. So we'll start with the good. What are some of the benefits of partitioning large tables? Because there are many benefits when used properly. There's gotchas, of course. We'll cover those as well. Nothing has only one side. So one of the key benefits that everyone talks about when talking about partitioning is speed. You can load data very quickly. There's a concept called partition switching, which I will go into later in this presentation, commonly used to load new data into large tables. You can also unload data. This will be used for archiving of old data, or if you don't have an archive, if you simply want to delete old data, you can use partitioning and partition switching to do that very quickly. And in today's world, especially in the EU, where you have the concepts of GDPR and data retention, this is a very useful tool. Another reason for partitioning, which I should mention is more an added bonus and should not be your primary reason for implementing partition, it can improve query performance significantly. Note, can. It can have an adverse effect as well if used incorrectly, but when used properly, you can actually leverage some pretty good performance benefits from partitioning of large tables. Large tables being the key. It's generally not recommended to partition a small table. A static table, you're going to get no benefit. Large tables, transactional data, these are the kinds that are generally candidates for partitioning. And hopefully I'll cover some of the reasons why as we go through this, make it a little clearer or more muddy. I don't know, hopefully the former. So sticking with the benefits of partitioning large tables, in addition to what I mentioned previously, you can perform index maintenance on individual partitions. And when your table is huge, we're talking multiple 100 gigabytes into the terabytes, this can be invaluable. You don't want to be doing a rebuild or a reorg on an entire index spanning the entire table. It could take hours. It's going to absolutely kill your memory, kill your CPU. But when you can target individual partitions, you can break down your maintenance into more manageable chunks. You can also apply different data compression to different partitions. Now, there'll be use cases where you may or may not want to use this, but the option is there. You can control this at a per partition level. And data can also physically reside in different folders or even different disks, different volumes on your server. Now, there's many different designs you can use for this, many different reasons you may want to move your data around. For example, you may want to put your active, your current data on your fastest but more expensive disks, and the old data that people very infrequently access, you can stick it on the old cheap slow drives. So loads and loads of benefits when you are using partitioning, but no single one of these should be the driving force. It should be a combination of factors. Partitioning should be a carefully considered and thought out strategy. Don't use it just because, hey, I've got a big table and someone said partitioning is good. Now, we've mentioned some of the benefits here, but of course, with anything, there are gotchas. There are rules, there are pitfalls, and you need to be aware of all of them in order to implement a good, robust, efficient partitioning strategy. So we'll look at some of the gotchas. So first thing to keep in mind is there are lots of rules around implementing a good partitioning strategy, specifically when you want to leverage partition switching to load or unload data into your tables. And by lots of rules, I do mean lots and lots of rules. I've included some links at the end of the slide, and I will upload the slide to the GitHub repo after the session. And these rules are, there's a couple of different blogs as well as a Microsoft site which lists out the various rules which need to be met in order to do partition switching. Partition switching or partitioning can have a negative impact on performance if your queries are not written properly, which is why I mentioned that partitioning should be implemented not just for a single reason, and definitely not just for, hey, partitioning improves performance. It can, but this should be sort of a bonus of using partitioning. You have to write your queries in order to leverage the partitioning correctly to reap the benefits of the performance. If you don't, you're going to feel some pain. And if you are implementing multiple different partition strategies on different tables in your database, it can add complexity to any automatic maintenance that you do have. If you're using different data types, different ranges, all of this, any sort of automation has to take into account every strategy. So the more you have, the more complex it becomes, as with anything in life, I guess. So sort of, yeah, that's okay so far. If anyone has any questions so far, please fire them away. Otherwise, I will just plow ahead. This isn't going to be a super deep dive, but I'm kind of going to touch on some of the concepts of partitioning. And hopefully these are at least slightly familiar to many of you. So some of the concepts that you will hear whenever you're talking about or researching partitioning: the partition function. This is one of the core objects in partitioning a table in your database. The function is what defines the partition structure, the number of partitions, how the rules kind of split the data. Does it go, is it an equal to, or is it an inequality? Links to the boundaries. All of that is driven by the partition function. And this keeps a hold of all of the partition ranges for your various tables. Building on top of your partition function is what is called a partition scheme. The partition scheme is kind of a link that maps the partitions to the file groups and the indexes. The function can be a shared object, but obviously each index in each table is going to be storing its data individually, and you can leverage files and file groups in your individual table, and your scheme is kind of in between, keeping everything linked together. In an index, every partition within that index can only have one file group, which can have multiple files, but you can have multiple different partitions in that index, and each of those partitions can have a different file group. And this is where you can start physically splitting your data across disks, across folders, and distributing the load, dividing it based on usage. You may also want to consider using different partition schemes for your data, your clustered index versus your non-clustered, different access patterns, and also just keeps things nice and clean and nice and neat. So you can have multiple partition schemes referencing the function, and your table can reference multiple different partition schemes. So it can get as simple or as complex as you want to make it, basically. When you're talking about partitioning, you're going to hear the word or the term partition column or partitioning key thrown around a lot. This is the column on your table that is used to partition the rows in that table. One of the most common ones as I mentioned before, it's date, because it's used in most transactional data, whether you're referencing sales, financials, anything that happens on a timeline, anything that has a date. The date column is usually a good logical candidate to partition the data on. It makes sense. You group it by year, you group it by month, but you don't have to use the date. You can use any column that fits your particular scenario. Most data types can be used in your partition key column. Another thing that's going to come up a lot when you're looking at partitioning is aligned versus misaligned indexes. Some of the links that I've included will have more details on what are aligned indexes and why they are good. The short version is indexes must be aligned in order to enable partition switching. If they're not aligned, your switch is going to fail. So what are aligned indexes? This is basically when your index is built on the same partition function, and therefore all of your partitions for your different indexes for this table have your partitions in line. So they've got the first partition has the same boundaries, the second partition has the same boundaries, etc., 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 all nice and neatly in a line. You can also have, it's not recommended, but it's possible. It works when you have two different partition functions or multiple different partition functions, one for each index on a table. But you need to be more careful and more dedicated into keeping the partitions in line of the various functions, or you're going to run into problems when you are switching. So your number of partitions has to be the same, your boundary values, your data types has to be the same in order to do a successful partition switch. Rules, lots of rules. I'll go through some of those as we go along. So when we're talking about partitioning, partition elimination is what I mentioned earlier when you're looking to leverage the performance aspect of partitioning. So you've got a very large table, you have multiple partitions. Say it contains transactions that are split by date. You're going back over 5 years and you split it monthly. So you've got 60 partitions with data. Partition elimination is when you write your query in such a way that the optimizer can target one or very few specific partitions and essentially eliminate the rest from the search when you're trying to find the data for your query, for the data in your predicate, hence partition elimination. If you're targeting a single row, you want to hit one partition, not scan through all 60. The less data to search through, the quicker the search will take, and this is where the performance benefits come in. And when you do not provide the partitioning key in your query, the optimizer isn't able to do this partition elimination, and it's got to scan through the entire table. And when your data is split across different files, potentially across different folders, potentially disks with better and poorer performance, your overall query can suffer if you are not using partition elimination. Therefore, always write your queries in such a way to include your partitioning key. This is why the design is super important. You can't just slap a partitioning strategy onto a table. It has to be thought through. How are people going to be using this table? How is it going to be queried? Is the candidate for the partition key something that can actually be used in most, if not all, queries on this table? Does it make sense to partition on this column? So lots of consideration goes into the design. Partition elimination should be at the forefront of your mind because of the impact on performance of your queries. So more to consider when you are designing and implementing your partitioning strategy is the type of partition function to use. Partition functions use ranges of values, so values between x and y, and you have a concept of a range left and a range right. And what this does is it determines on which side of the boundary a record will fall if your partition key is equal to one of the boundary values. So I'll just use some numbers here just to make it easier to read, make it simpler. And I've compared a range left and a range right. So we've got 3 boundaries in this case. We have 0, 10, 20. It's cool, it's nice and simple. So in both cases, if you have a number, if you have a key that is less than 0, where's it going to fall? Well, it's going to fall in your very, very first partition on the left-hand side of the 0, because in your range left, less than or equal to 0 will fall into partition 1. In your right range, less than 0, so -5, easy, partition 1. If we're looking at +5, well, it's between 0 and 10, so partition 2, dead easy. But where does 10 fit in? This is where left and right is going to make a difference. The number 10 is the boundary value in this case. It's the second boundary value over here. When you have a left range, the rule says this value, anything greater than my left boundary and anything less than equal to my right boundary will fall into this partition. Since we don't want number 10 falling into both partitions, it's, especially if you have physically different files, it's not possible. It's got to belong somewhere. So with the left range, the number 10 would fall into partition 2 because it is less than or equal to 10. But in a right range, the boundary says, well, it's got to be greater than equal to 0, but less than 10, and therefore the number 10 will reside in our third partition. When it comes to using dates, most people will use a right range for simplicity. If you think of monthly partitions for your sales, you have the 1st of January, the 1st of February, 1st of March, etc., etc., etc. Depending on your actual date strategy, whether you're using the datetime 2, datetime 3 with a 0 scale, with a 0 precision, or with a 7 precision, trying to do a less than equal to can be fairly difficult to ensure that you capture everything. Whereas if you are saying, well, all of my dates greater than the 1st of February and equal to, and all of my dates less than the 1st of March go into the February partition, well, now you're catching the whole of February. Greater than or equal to Feb 1st at 0000 midnight, less than or equal to 1st of March at midnight. Super simple. Like you could use a range left, but for dates specifically, range right, it's cleaner and it's just a lot easier to get your head around. But this one's definitely a big pitfall, and it does confuse a lot of people. And even I've got to stop and think from time to time, like, the left, is it going to fall there? Is it going to fall there? Where is it going to fall? Lefts and rights, they're important, and they do make a difference as to where your data is going to physically reside. So that's sort of the design of your partition. Where, how, what. Now you've got this partitioning, everything's in place, it's cool. So now we want to use it for something awesome. And the most awesome part of partition switching, sorry, yes, I'm a geek, or partitioning, is partition switching. Partition switching is a very, very powerful tool if you use it to the full extent of its capabilities. Partition switching can move, and by move, I do not mean physically. it can logically move very large amounts of data very, very quickly. Think trying to archive off the whole of 2016 because it's now expired its data retention policy. If you're trying to delete an entire year's worth of data, that could take a long time, depending on the volume of your data. It can take a very long time. It can cause massive lock-in, block-in, whereas partition switch operations are near instant. This is because they are metadata operations. They don't physically move the data. They are basically just repointing the data. So while there is a very brief transaction and a very brief lock, it's so quick that us human beings don't even notice it's happening. But because it's a metadata operation, there are a lot of rules and restrictions put in place to ensure that it can happen. If the data is physically residing elsewhere, obviously you can't do a metadata switch. You're going to involve data movement, and your partition switching is not going to work. There's loads and loads of, well, loads and loads. There's a couple of different types of partition switch you can do. And one of the links at the end of this table, at the end of the slide, is actually by Catherine Wilhelmsen. Probably messed up her surname. But yeah, she's got a lovely blog on partitioning, partition switching, and various types of switching. I've just kind of grabbed the high level. So you can switch from an unpartitioned table into a partitions table. And this is commonly used when loading data from a staging table into your main data as part of an ETL process. Can be used in a data warehouse situation, or even just a very large transactional database. You can load your staging table using whichever tools you want, SSIS, T-SQL, load them, do any transformations you want. No one's going to be accessing the staging table yet. Once that staging data is ready, the switch to load the staging table into your main table, if everything is done right and follows the rules, it's near instant. 1, 2, 3, boom, you've got your new month's data in your table. Magic. No, rules. We'll go through how some of that works later, but that's one of the, I'd say, more common usages for partition switching. Another very common use would be unloading your data. So you're going from a partitioned table into an unpartitioned table, like staging table. And this is commonly used for archiving. So in the same way as you've loaded in an instant an entire partition, an entire month into your main table, you can now switch that whole month out of your table into a staging table, which can then be used to copy the data, take in its sweet time into an archiving system, or if you don't archive, if the data just gets deleted when it's no longer needed, truncate or drop your staging table, and the bulk of the heavy lifting gets done on the staging table, and your main table can go about its business with no performance impacts from that maintenance operation. You can also switch between two unpartitioned tables. That's, of course, not partition switching. That's just plain old switching. But yeah, it can be done. I won't spend any time focusing on that here because we're looking at partitions, right? So.
Hey, Angela.
Yeah.
Real quick, we had a question come in from the Slack channel.
Yeah.
Mark asks, how the heck do you switch data from unpartitioned tables when there is no metadata to utilize?
But there is metadata, and this is where the rules come in. So I do have a section there. There are a couple of additional requirements when going from an unpartitioned table to a partitioned table, but in and out, a lot of the same rules do apply. The metadata we're talking about is things like the file groups it resides on, which obviously is linked to the physical location of the data. The tables have to be identical. There's a lot of very, very specific rules that make this a metadata operation. But yeah, I'd say the key here is that they have to reside in the same place, on the same file group. And this is where SQL Server can then do a pointer from the partition to the table, or from the table to the partition, when it's saying, here, this is where your data is. And that's what the switch operation is. So if you've created your staging table on your primary file group, and your partition table lives on a dedicated file group, it's not going to switch because your file group metadata is different. So I do have a section where I kind of detail that a little bit more. So if we want to come back to that question once we get to the partition switching rules, if it's maybe still not clear at that point, we can dive a little deeper into that. But I hope that kind of just high level makes things less murky for now.
Sounds good. Thanks.
I see there's a couple of replies there. Cool. Yeah. So I've got the Slack on the background here as well. Multitasking. So we're going to stick with partition switching. Well, we're going to get back to the switching in a little bit. Like I say, I've got all the rules. I'm going to have all the rules listed out, and there's a couple of slides just with these. Right now, I'll just finish up on the different concepts in partition switching, or in partitioning. Sorry, I'm obsessed with partition switching for some reason. So when we're looking at partitions, we generally talk about the partition ranges, the individual partitions, their boundaries. And obviously, as you go along, you want to create new ranges. You want to remove old ranges that are no longer needed. And if you look at the date scenario, it makes it a lot clearer. As you move forward in time waits for no man or woman or person. As you move forward, as your data progresses onto new dates, you want to create new ranges to cater for the new data. And this is called splitting. Splitting is essentially going to take generally your rightmost, your newest partition, your range, and it's going to create a new boundary in it and split it into two, thereby creating a new partition. So you've now got whatever your partition count was plus one. Dropping a partition is called merging. It doesn't actually, there's no object to drop. It just removes the boundary date and merges two partitions into one. Both of these, if the partition you are splitting or merging already contains data, and if that data would fit into the new partition range you're splitting out, or would have been in the one you're merging from, it can result in movement, like physical movement, if you have different files split across your server. Data movement is slow. Data movement can cause lock-in and block-in. So when you're doing splits and merges, it's recommended that the partition you're splitting or merging be empty, because then it's near instant. But your splits and merges are the way you're going to manage your different partition ranges, your number of partitions, and create new boundary values. And when we're talking about splitting and merging, we have a concept here, the last concept, I promise. We will move into the fun bit next, partition switching. There's a concept called a partition sliding window. And essentially, using the dates sort of example again, you want to maintain, ideally, a fixed number of partitions over time. So using the 5-year example, you want to keep these 60 partitions, the 5 years going. And as time moves on, you want to merge off older partitions and split newer partitions, but maintain that 60 partition window. So this is going to be a sliding window. It's going to keep moving forward into the future. It's going to slide. slits and merges, slits and merges. This is easy, very easy to automate. There are loads and loads of blogs and tutorials out there on the internet to guide you through automation of partition maintenance. It's done every day by loads and loads of people, and it's a good thing to have. It keeps your data nice and neat. You don't end up with 1,000 old partitions. You keep your required window in place. Definitely don't recommend that you do this manually on an annual basis or whatever. Automate it wherever possible. And the sliding window, automation it's very, very doable. When we're using a more complex partitioning strategy like different file groups, that can obviously add complexity to maintaining that sliding window using automation. Doesn't make it impossible. It just requires a little extra coding, a little extra thought. If you're using an incremental file group 1, 2, 3, 4, 5, and into infinity, or more commonly a round robin file group. There's 12 months in a year. If you only have a year's retention, do you really need 500 files? We can just reuse those same 12 files. File 1, we use for January, file 2 for February, so on, so on, so on. Once you get to December, you're writing to file 12. The next January, you roll over into file 1 again, and you just keep reusing them, and it keeps your disks neat, it keeps your storage neat. You don't have to worry about shrinking or dropping unused empty files. Reuse, recycle. Doesn't just apply to real life, it applies to SQL Server as well. And there's loads of different ways in which you can implement the file groups, but whatever you're using, keep that in mind when you are automating your partition maintenance. The more complex your implementation, the more complex your maintenance. So yeah, that's kind of the high level what is. Now we get to the fun part. Switching. So I mentioned there are rules. And there's a few slides of rules, because while partition switching is a very powerful tool, it also requires things to be just right. It's easy to make it not work. And especially when we're talking about metadata, these rules are in place to ensure that everything is where it should be before SQL Server will allow the switch to take place. So what are some of the rules that we need in order to switch? And this is going to apply whether we're going partition to partition, a staging table to a partition table, or a partition table to a staging table. These rules, most of these rules apply to any switching scenario. So first and foremost, your source and your target object have to exist. Partition switching does not create objects. You've got to first create your table before you can switch into it. So that one, I think, is kind of straightforward and self-explanatory. Very important one, wherever you're switching into, whether it is a table or a partition, it has to be empty. If you have even one record in your target or receiving partition or table, the switch is going to fail. It has to be empty because of the pointer. It's not moving the data, it's simply repointing. Your source and your target have to be identical, asterisk, 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 because obviously partition table is not the same as an unpartitioned table, but by identical, I mean your columns have to be the same. Your data types have to be the same. Your column order has to be the same. The nullability has to be the same. If you are moving from one partitions table to another, your partitioning key has to be the same. Physically, it must reside on the same data file. So therefore, your file group must be the same. So if you are going from a partition table into a non-partition staging table, that staging table must reside on the same file group as what that partition is using. So even if your table is using 24 different file groups to cover 2 years, whichever staging table you're using to switch in or out of has to be on the same file group as the partition that you are switching in or out of. So you'll find that a lot of automation will create your staging table dynamically so that it can read the file group from your metadata or your sister file group's metadata in SQL Server and create it in the correct location. It's probably one of the more robust ways of handling that. And this is where I was talking about the metadata operation. All of this is metadata, your table structure, your file group, all of this metadata has to match. And if you have any indexes, your source and your target have to maintain the same indexes, clustered indexes, non-clustered indexes, constraints, defaults. Obviously, if you're going to or from an unpartitioned table, the index won't be partitioned. But other than that, it has to be identical. Your key columns have to be the same. Your included columns have to be the same. So basically, whatever you're going to or from has to be as identical as possible in order for SQL Server to repoint where the data is coming from. But those aren't the only rules. It would be too easy if it were. 4 rules. So when you're switching to or from a partition, if you're switching to a partition from a staging table, the data in your staging table has to match the boundaries of the partition you're switching into. It has to fit within those boundaries. So this is where the left and the right range is going to kind of come into play when you're automating this, which is greater than equal to, which is less than equal to, greater than, less than. Your source data has to fall within that target partition. It cannot be greater than the boundaries and hit 2 or more partitions, or it's going to fail. So you switch into a partition at a time. You don't switch into a range of partitions in one operation. If you are switching from a staging table unpartitioned into a partitioned table, then you have to have check constraints on your source staging table, which will basically tell SQL Server that, yeah, okay, I can confirm that my source data is going to fit into this single partition range. The switch is going to be possible. If you have any foreign key and check constraints, both source and target need to have the same constraints. And here's a concept that it's mentioned on the Microsoft documentation, but I don't think it's given maybe enough of an importance, like bold, keep this in mind. Your indexes have to be aligned in order for partition switching to take place. Now, what does aligned really mean? It means that if you have a table with multiple indexes and you decide you want to partition this table, all indexes must be partitioned. You can't have your clustered partitioned and your non-clustered unpartitioned, or have that one unpartitioned. Every index has to be partitioned, and every partition has to be in line with regards to the number of partitions and the boundary values for every partition. The easiest way of doing this, and the way that I would recommend myself, is using a single partition function for the table. So any indexes on the table, whether you have 1 index or 20 index, you should reuse that partition function for that table. You can reuse a partition function for multiple tables. That has its own sort of considerations and gotchas, but it is possible. But at minimum, have one partition function for one table and have all the indexes on that table use that. Then you will never have to worry about your partitions becoming misaligned. If they're misaligned, your partition switching will fail because now you're not moving it like for like, especially if you're going to an unpartitioned staging table. Sorry, get some water there. And if you're using foreign keys, the table that you're switching out of cannot be the primary key for the foreign key relationship. It can't be the master key, because if you suddenly switch this data out of the table, your parent-child relationship is broken, whichever tables are referenced in the foreign key no longer have the parent key because it's just been switched out. So therefore, it can't be a parent in a foreign key relation. Obviously, it can contain foreign keys pointing to others, but it itself can't be the parent key. Lots of rules, and we're not done yet. But I hope this is becoming clearer rather than murkier. It gets as simple or as complex as you decide to make it. So this first one over here is something that I've never actually tried myself. Replication and I don't tend to get along in general. I just never seem to have much luck with it, and I've definitely never tried it on a partition table. Microsoft's documentation states that replication is by default disabled on partition tables. However, it can be enabled. And there is a link in the slide to the Microsoft article on this. There are a lot of additional rules and gotchas when working on replicated partitioned tables. It technically is possible. I've never tried it. I don't want to try it. Replication scares me, to be honest. But yeah, there are ways and means. When you're partition switching, because it's a metadata operation, insert, update, and delete triggers are not fired. So if you have anything relying on these triggers, keep that in mind when performing partition switching. Microsoft states that you can't have full text or XML indexes on your source or targets tables when doing a partition switch. Never tried these myself, never had any use case to actually use full text or XML indexes, but Microsoft says so, and I think I believe them. And permissions, when it comes to switching, whoever or whatever, if it's an automated process, SQL agent job, whatever it is, it does require an alter table permission, because the partition switch literally is an alter table statement. Now you can have DDL triggers on your database, and these will capture the partition switch because it is an alter table operation. And we actually have these in place, and I have seen these triggers fired with my own eyes. So it really does work. So these aren't all the rules, but they're kind of the ones that you'd most need to be aware of. Read up on the Microsoft blog for a fully comprehensive list of the fun. So now we've gone through all the rules of how to make this work. We just kind of go through a few gotchas. I mean, this is the good and the bad, and some of these can be kind of ugly if not done right. Yes, I know there is some repetition in here, but some of these definitely need to be stressed. So keeping in mind when you are doing any sort of partition strategy for any sort of reason, it's a metadata operation. And I hope that kind of fully answered the question from earlier. It's fast. It does create a transaction, and it does create a very brief lock during the switch, but the key is brief. The merge or split of a partition range can result in data movement if there is data in the ranges being merged or split. So keep this in mind. Data movement, if it's 1 or 2 records, it'll be quick. If it's a couple of million records, it can take a while. It can put load on your server. It can cause significant lock-in and block-in, and this can have an impact on anyone trying to consume this data. If there is no boundary range for a specific record, for example, my partition table has been defined up until the 1st of August, and it's a range right. Therefore, it's less than the 1st of August in that range. Anything greater than or equal to the 1st of August is going to go into the rightmost partition, which has a null rightmost boundary, and some folks call this the null partition. And this is where the above point can come into play. If you don't realize that you've run out of partition ranges, you're going to keep writing into this rightmost null partition. At some point, you're going to realize this, and you're going to have to split off ranges to properly allocate the data. And this can result in data movement and lots of pain, and probably a fair amount of swearing. But there's ways to get around it, maybe switch out the data into a staging table before splitting the partitions and switching it in. But if you get into a situation where you have run out of ranges and you're in a runaway partition scenario, it can get quite ugly and kind of complicated to fix. So try not to get into that situation. In an ideal world, your final partition should always be empty. If there's no right boundary, that partition, it's best to keep it empty. Cleaner and neater. More considerations. Nulls. Nulls and partitioning are generally not recommended. I have actually seen the scenario, and it caused some head scratching for a while. If your partitioned column is null, if the value on this record is null, the data is going to go into partition number 1 on the leftmost side, because null is smaller than whatever your minimum boundary is. And if you're using partitioning for like a data retention archiving strategy, this can complicate things, because what's going to be contained in your oldest partition, it's going to be your oldest data, the data you want to archive. But now if you're using a date column, for example, and this date isn't populated because it's still active, the data is new, it's fresh, that's going to go into the same first partition. And if your maintenance is going to go and happily switch out partition number 1 and archive it off goes your fresh data as well. So not necessarily a situation you want to find yourself in. There's a but here as well. So you can specify a boundary value of null. So you have a null boundary and then you have a value boundary. In this case, if you have a record with a null partition column, that record is going to go into partition 2. And the first partition with a null boundary is always going to be empty, which is kind of pointless. So a recommendation I'd say for most architects and DBAs out there would be, don't make your partition key null. Don't even make it nullable. Force it to have a value so that it has a place, because everyone and everything wants to belong somewhere, right? Even data. So, more things to keep in mind. This list never ends. The more partitions you have, the longer your overall maintenance can be. And this is especially true if you're doing partition level maintenance, because now you have more partitions to maintain, reorg, rebuild. More partitions means more operations, means more time. It's makes sense. More partitions you have, the longer also can be DBCC operations like checkDB and checktable. Conversely, if you do have more smaller partitions, your maintenance can be limited to individual partitions, and this can be particularly powerful where you have current data that is changeable, but where old data is essentially never modified again. It's never updated, never edited. So in essence, your old data is read-only. So why do we need to do reorgs and rebuilds on data that's not changing? Ignore those and only do index maintenance on the few partitions that need it. Speeds up your maintenance. Again, depending how you are writing your index maintenance, and keeping this in mind to leverage the power. Also depends on the SQL Server version. Keep in mind as to whether or not your partition level operations are possible and whether they can be online or offline. So keep that in mind if you're using maybe older versions of SQL Server like 2012 or 2008. There are different rules for older versions. Now, this one over here has a little star against it because I haven't tested this out myself. I'm taking Microsoft's word for it. But Microsoft says that non-aligned indexes can require more memory when you are doing maintenance on them. And they have some examples there about a non-aligned versus an aligned, and it was something like 100 times more memory needed for a non-aligned index. So take their word for it. That sounds bad. I don't want to try that. And also, as mentioned, if indexes on a table are not aligned, it can cause trouble for partition switching because rules. Okay, keep an eye on the time here. We've got 6 minutes to go. Yay, not running over. That's good. More gotchas. Oh my god, they never end. Okay. Partition elimination. It's been mentioned before and it has to be mentioned again. It can improve or degrade performance on your queries depending on whether you use it or ignore it. If your table is partitioned, you should always use partition elimination wherever possible. If you need to tweak your query, get your developers to tweak your queries to leverage partition elimination, do it. If at all possible, do it. You're going to reap the performance benefits of it. Not using it can have an adverse effect, and no one wants slow queries. And even when you're joining to partition tables, try to use the partition key, because any index, clustered or non-clustered, is going to include that partition key, whether you have specifically defined it as a key column or not. It's gonna be in your index, so use it. And when you have a very, very, very large table, which are the ones most commonly targeted for partitioning, stats sampling may not scan the full table. It may not scan all your partitions. So keep that in mind if you are having some performance issues. Check your histogram. It may not be entirely accurate, but you're going to have a similar problem if you have an unpartitioned large table as well. Default sampling is not a full scan on very large tables. And we're nearly there, I promise. When we're looking at newer versions of SQL Server, they introduced this really, really awesome concept of partition level truncation. This is really useful when looking to clear out old data, but notice here that the syntax is a truncate table syntax with a with partitions clause. If you accidentally forget the with partitions, especially if you're building this dynamically as part of an automated maintenance, you're not going to truncate your oldest 5 partitions or oldest 6 partitions. You're going to truncate your table. That's not good. So be careful, treat it with respect. There are definitely scenarios where you want to use a truncate partition. I've used it myself, but you definitely want to be careful about it, is my advice. Check, double check, triple check, and check again for good measure. And last but not least, when you're using partitioning, when it comes to old data that is accessed infrequently, you can put this data on read-only file groups, but when you're doing any sort of maintenance, those file groups are not updatable. So this includes things like rebuilding and reorging indexes. By default, if you don't specify anything, a file group is read-write. So yeah, that is kind of the biggest what is partitioning. I've just kind of included a few DMVs.
Hey, Angela.
Yeah.
Real quick, sorry, we had a question. Does the partition, this comes from Mark, asked the previous question. Does the partition column need to be part of the primary key?
It does, I believe.
Yes.
It does, I believe.
Okay, thank you.
Primary key if the primary key is clustered, definitely yes. I always get the two confused whether it's going to be part of the primary key or the clustered index, but definitely if your primary key is clustered, yeah, you have to explicitly specify it. For all other indexes, it gets included implicitly if you don't specify it specifically. Generally,
Okay.
a good idea just keep it there for visibility anyway.
Okay, and do we have time for one more quick question?
Yeah, if there's anything there.
Okay, we have one more that just came in, and this is from A.S. Kaufman. Have you found partitioning successful in OLTP versus OLAP DB models? Do you have a general rule of table size before you will consider partitioning?
Okay, the OLTP, I don't really deal much with the OLAP side of things. With OLTP, yes, we actually use partitioning on transactional tables in our primary database, in our OLTP system. It works very well if used correctly. Get a lot of performance benefits from it. Also, that makes the maintenance nice and light. And so, what was the second part of that one?
Do you have a general rule of table size before you consider implementing partitioning?
That one's a hard one. There's no, I'd say, rule of thumb. It's very much going to depend on your system's capabilities, the performance of it, your data load, how the data is used. Like, I wouldn't use partitioning on a small table of 1,000 records. I would definitely consider it on a very large table of terabytes. But size should be one of the factors and not the factor. You should look at other aspects such as maintenance as being more important than size, because a good indexing strategy can give benefits over just partitioning. So it's a combination of factors, but I'd say maintenance should weigh in maybe more than just sheer volume.
Okay, excellent. Thank you. We did real quick. We had a follow-up question back from Mark. The rule about, so is the rule that the partition column needs to be part of the clustered index, but not necessarily the primary key?
I will need to verify that one. I don't want to give you incorrect information. I'm confusing myself now, overthinking this. Definitely clustered index, yeah. Primary key, I will pop back onto Slack and verify that before I get myself into too much of a muddle here.
Yeah, that question came from the Slack channel. So afterwards, if you want to check the channel, you can reach out to Mark directly.
Yes, I can see it over here. Cool.
Thank you. Carry on.
Right. Anything else? I've gone 2 minutes over time here.
I think that's it. So I would carry on.
Cool. Yeah. So I'm done here. I've just listed a few objects here, which I'll upload the slides.
You have another 13 minutes till the next session, Angela. So you got loads of time.
Yeah. No pressure to fill the gaps. No pressure to fill the gaps. So all I've kind of put on here is just some useful objects to use when looking through your partitioning strategy in your database. Partition functions just list the functions you have in your database. Partition parameters will tell you which data type that function supports. Range values actually gives you your boundary values, and both of these tables have a one-on-one link to your, or one-on-one for parameters and one-to-many for range to your function. Partition schemes, you can have multiple schemes to your function listed in partition schemes. Sister partitions is your actual table partitions rather than the general storage object. Destination databases, or data spaces, is just a table that links your partition scheme to your index and your file group. Partition scheme. It links your index to your file groups. So it will say, okay, well, in this index, partition 1 is on this file group, partition 2 is on this file group, etc., etc. Destination data spaces. When joining, always have the partition number joined, or you're going to get a bit of a Cartesian product. Sister file groups, obviously your file groups, which links to your physical files. Partition stats just kind of gives you some detail on the page counts, your rows, etc. in your partition. And then you've got the dynamic function for partition physical stats, or index physical stats, but it actually contains partition level detail. And that'll give you your number of pages and also your fragmentation. And this is used by maintenance solutions such as Ola Hallengren's uses this DMF to determine which indexes and partitions are eligible for rebuild or reorg during partition maintenance. So this would be where it comes from. So it's a good one to be aware of. So just a quick credit to an ex-colleague of mine, Colin, for going through this and just validating this when I first created this slide like 3 years ago. And also giving me some ideas just for the theme. And of course, no one would be anywhere without all the amazing blogs and online resources. So I've listed a few that I've found particularly useful. And Andrew, you've made the cut. Your blogs are pretty awesome. They're super easy to follow and definitely worth bookmarking for people. So yeah.
Cue smug face over here. Thank you.
Good information. Deserves a shout out.
That was an excellent session, Angela. Thank you very much.
It's my pleasure.
Okay, so we have about 9 minutes till the next session. So if you have any questions for Angela, please drop them into the Q&A here or on Slack. John will pick them up and we'll relay them over. The next session we have is Thomas with SQL Server storage options and a deep dive. This is our 8192 session. So we're talking a real deep dive here. So hopefully you're geared up for that. And Angela hasn't melted your brains quite so much. I am going to grab the screen. So please, please, please do leave feedback for all the sessions you're going to see today and the overall event. We have the link there, 8kb.online/feedback. You'll see a link to Angela's session there. Click on that. It's only 4 questions in a comments box. So please leave your feedback and we will pass that on to the speakers, because speakers, as a speaker myself, we all love feedback. We want to know what you liked, what you didn't like, so that we can make our sessions better. How we doing, chaps? We all there? Hi, Thomas. We've got you there.
Hello.
Drop it in at the last minute just to make us nervous.
I needed the time to finish the slide deck. There we go.
Are you
I'm
pulling
not
a Joey?
joking.
I
2
no,
days
I have
ago.
literally rocked up to an event with my laptop on my knees in a car, going right. I've just finished the slides up. So yeah,
No,
no.
2 days ago, Intel announced that they're going to discontinue a technology I was talking about. So I had to remove it from most places.
You can feel your pain. I've done a few sessions on Kubernetes, and a new release has come out that has changed things completely. And like everything that's in my slide deck is now not. I need to go change that now immediately.
Yeah. So,
Yes,
yeah,
absolutely.
yeah.
So how's everyone doing? I hope you're all doing all right out there. I hope your minds aren't melted too much with I always say we're going to start off with the easy session, then we just throw partitioning at you, and you're going, oh right, hang on now. So take a break. Everyone go get a cup of coffee, and we'll be kicking off in just over 7 minutes for Thomas's session.
Yeah, I'm ready.
Thomas is good to go. We got Anthony there. We got Bob. We got John. John, thank you so much for helping out with the questions there. Fantastic job. Dual purpose there with both the Q&A and the Slack channel.
Always happy to help.
There we go. So up next in 7 minutes, we have Thomas with SQL Server storage options deep dive.
I gotta say, I knew there was a lot of rules around partitioning. I had no idea there were that many.
Thing.
It's the gotchas. It's the gotchas that'll get you.
Yeah.
It's like that with many of SQL technologies. You can just use them and they work. But if you really want them to work, you need to understand what's going on.
Yeah.
Column store is one of the candidates, definitely partitioning, even simple things like backups. Yeah, they just work, but will they work in any circumstance? Then you need to understand. Yeah. Or, as we will see, giving a little preview of the next hour, adding a second file to a database can change things to a non-working state.
Hey, TG, I am your moderator. How would you like to handle questions?
I would say there's some natural points where we'll stop and then just ask for questions.
Okay,
I think
that's fine.
That gives the best flow.
That works fine for me. I'll be monitoring Slack and the Q&A stuff here. So when you reach that point, shout out for some questions, and I'll let you know.
Exactly. Yeah. No, it's like there's like 3 or 4 times a very good place where a chapter is closed, and then we just gonna open up a little bit. I have no idea how long this talk's gonna take. I mean, I tried to keep it under the proposed length, but it's the first time.
You have 75 minutes, and we have a 75 minute, and we have a 15-minute runoff as well. Yeah. So you're all good. No worries at all.
It makes me nervous that he's calling the time limit a proposed time limit.
I know.
I think last time we had John.
We had last.
No, I also have a point at the end where I can stop basically before the whole thing is over. It's like, and then don't give you the post-credit scenes.
No worries. So what we'll do is I'll stop sharing, and you can grab the screen. So you've got 4 minutes.
Okay, let's see.
And we'll go from there.
Zoom is going to reboot my machine or something. I think the best thing is to directly share PowerPoint. Let's see if that works. You should now see.
Yes, we have your first slide up there now.
Good. So, and let's see where I have to put my mouse so that I can actually advance the slides. Here we go.
You just tortured everyone's bandwidth for the.
Okay, that's fine. That will happen.
Bye.
Yeah.
My rural DSL connection just set on fire.
Yeah. It's
serves you right for moving to the sticks.
Nah. Yeah, I got lucky here in Chicago. I could get 2 carriers that give me a gigabit, so that
lucky.
Yep.
Wait, knowing you, did you actually get
jealous.
gig from 2 different companies into your house?
No, that was part of the requirement for the real estate company to find me a place that can do that. Other people have like demands on school districts and parking space and stuff like this. I came with a very different list. Needless to say, that real estate agent never wants to work with me again. So mission accomplished. But it works. And you don't want to see how the cable gets into the house, but stressful day.
Yes, you're on a flight later, aren't you?
Yeah, I have an actual incentive to finish on time. So it should be fine. It's just I have.
I'm going on holiday tomorrow, so I'm literally doing this, going to sleep and then getting up at 2 o'clock in the morning to jet off on holiday. Whilst there's also chaos happening around me here as we sort out the house before we go off.
Yeah, I have a gigantic sign at my door, empty trash can. At the current temperature after 2 weeks, I don't want to come back if I forget that.
Okay, so we got about a minute to go.
Yeah.
So I think we're pretty good to start. So I just want to say thank you, Thomas. Everyone, this is our 8192 session, Thomas, with scaling SQL Server beyond one disk. Take it away, Thomas.
Okay. Hello, everybody. Welcome to this virtual conference. I'm looking forward to talking to you for the next couple of minutes. And today we're talking about storage. This is the part 2. I did a talk on 8KB, the last one, about scaling SQL Server beyond one core. And that one scratched only on I/O. And this time we're gonna take part 2. So it will be helpful if you've seen the other one, but it's not a 100% requirement. So after killing everybody's bandwidth one more time, a little bit about me and my relationship with SQL Server. So my name is Thomas Grosser. I'm old. I'm doing this for a very long time. I started working with SQL Server in 1994. MVP for a couple of years, helped writing some books, and my main job is to yell at Microsoft and tell them what to do better. So what do we expect from storage? I mean, it's very clear that the database, especially SQL Server, needs a good, robust storage system. So I came up with the 4 Ps. Persistence. So whatever we send to the storage, we want the storage to keep. Performance, of course, it should be fast. It should preserve whatever we send to it and not give us back something else. And it would be nice if it would protect our data from being stolen. So we don't want to lose the data. We want to be able to read it fast and slow. And we want to get back the data we actually stored and not something else. And we make sure that nobody can just take it and use it somewhere else. So that's the main requirements. And it sounds very simple, but if you really care about all 4 of them, it gets really tricky. Before I start going into details, I recently got to test a new system. And I remember in the year 2008, I filed a bug with the Windows team that Perfmon was not displaying my table scan results correctly. And looks like I have to dig out that bug and file it again. So back then I did a table scan with 40 gigabytes per second, and that broke Perfmon because Perfmon couldn't display the number anymore. So this year I have the exact same problem, because what they did was the fix, they just made it 1 digit longer. And now when you have an 11 digit as your bytes per second, you break again and Perfmon can't show it. So I made a table scan with 89.69 gigabytes per second directly from disk. Nothing was in memory. Yeah, so that's a really good speed. And if you see Perfmon showing you mathematical notation instead of actual numbers, you know that you're faster than average, especially if it happens in the average column. Yeah, so that's a little bit for warm up and to give you an idea where we're going to go today. We're going to look at systems that can go all this way. The big problem with storage is it's a three-dimensional puzzle. You have size, capacity, how many terabytes, gigabytes, petabytes you need to store your data. And that's something you need to scale. You have the throughput. This is how much data per minute, per second, per hour can I read or write to the storage. And the third one is latency. How fast can I do a single IO? How fast can I write one portion of data and how fast can I read it? And the only way to scale storage correctly is to scale all three at the same time, which means when we increase capacity, we also have to increase throughput. Because honestly, if you just double the size of your storage, but don't double the speed with which you can access it, you basically just double the size, but at the same moment, you cut your performance in half because it's going to take you twice as long to read it unless you also increase the throughput at the same time. And the same goes for latency. The more IOs you have to perform, the faster each individual has to go to do that. So while you're scaling up size and throughput, you have to make sure latency shrinks at the same time. And this is the really hard one. So how much data can you store? How many gigabytes per second can you read or write? And how long does a single IO take? Size is easy. You just buy more capacity. And so unless you run into some limit, how many hard drives or how big your storage system can be, this is the easy one. Yeah, this one literally just requires money to be fixed. Throughput is also kind of easy. If one disk is not fast enough, you buy two, and if two are not fast enough, you buy 3, 4, 5. Yeah, so kind of capacity, simple. The problem with that is if your interfaces that you're connecting them to are not growing at the same time, at some point you might reach a maximum speed. And we'll talk about this in detail. Latency, that's the hard one, because you have to find a new technology with lower latency if you go up a certain size. Yeah. For a while, you can help yourself by buying better quality or like the more expensive hard drives or SSDs. But at some point, you have to move beyond the technology to get something that is faster again. So let's look how SQL Server actually performs I/O. And that would be a 3-hour talk just by itself. So I'm cutting it to the 3 basics. The 3 basics is you have a database and needs data file or multiple data files. And you have I/O. The database is in memory, you run, and it does I/Os to the data files. These IOs can be on multiple files and they can happen in parallel. There's basically very little limits how many there can happen. And SQL can really, really push it. I always have these nice discussions with the storage people that they always like, oh, how much are you going to use? I'm like, whatever you give me. If you give me twice as much, SQL is going to do twice as many IOs. It's very simple. I don't have a speed limit inside of SQL Server. Yeah? The faster the storage is, SQL will find a way to use it. Yeah? The second part is the transaction log file, which usually there should only be one. We'll talk about cases where you need more than one. But IO to the transaction log file is predominantly sequential. And it's predominantly single-threaded. That means you can't help the transaction log file by putting there multiple of them. You can't make it faster by putting it on multiple disks because SQL will always communicate with one of them at a time. And the third one we're going to talk about today is backup files. Yeah, you need to make backups from both your transaction log and your data files. And luckily for us, that can happen in parallel again, and you can have multiple threads pulling out the data in parallel, and therefore it's very easy to increase the throughput. So to summarize this, the transaction log file and how fast you can write to it is purely dependent on the latency of how fast you can write a single IO. Yeah, doesn't matter. I've never got into any throughput issues on a transaction log file. In most cases, a single hard drive, spinning hard drive, is probably fast enough from a throughput perspective, but from a latency perspective, not at all. Yeah. Data files, they both need throughput and latency. Latency is important when you do random reads. You need an index lookup or something. You want that answer quickly, so low latency helps you there. Or you do a table scan, then you need as much throughput as you can get. Yeah? So data files have a mix of requirements, both throughput and latency. The good thing about data files is writes to data files are, as I call it, harmless. They are deferred to the next checkpoint. So whenever you create actual data or so, it doesn't have to go to the data file immediately. So an insert will log it in the transaction log file and made the change on the page in the buffer pool, but not immediately persisted to the data file. So this is deferred to a later point in time, and that helps you a lot. That allows you to have lower latency, more throughput on the data files for the writing part. Backups, all they need is throughput. Latency is, yeah, theoretically it makes it a little bit faster, but in the end, as long as you can pump gigabytes per second, your backups will be fine. Individual IO's speed doesn't matter because you're doing very, very large IOs. So one more summary. Log writes are sequential, somewhere between 512 bytes and 60 kilobytes. Checkpoints are random and can be up to 256 kilobytes at a time. It's also writes. Index seeks are reads and are random, 8 kilobytes and when your buffer pool is full, or 64 kilobytes when your buffer pool is empty, because SQL understands that a 64K full extent read is the same amount of work than just reading 8K from an IO perspective. And therefore, as long as there is enough memory, they just pull in whatever they get their hands on. Table scan, range scans are sequential IO if your data is laid out sequentially on the disk. And that's somewhere between 64K, so one extend at a time, up to 512K. If you get into read ahead mode in Enterprise Edition and the data is laid out correctly on the disks, and we have a whole section on that later. Bulk loads, again, 64 to 256 kilobytes. They are writes and sequential, but as I said before, they write into the buffer pool. The actual persistence happens a little bit later. Backup operations, you could theoretically make it go down to 64 kilobytes. The default is now luckily 1 megabyte. I would always recommend to change it to the maximum of 4 megabytes per IO. There's no point in doing smaller ones unless you have some compelling reason from your storage to not do large ones. And my favorite one, Hackathon non-durable tables, they don't have any IO at all. So that makes them really go fast, even if your storage is slow. So are there any questions so far?
Had a comment. Probably the best comment is we have I'm very sad about Intel Optane SSDs going away. That is from Glenn.
Yes, I will come to that.
Okay. And when you mention throughput,
yeah.
That is for a certain size.
We get
number of IOs. Okay, we'll get to that. Cool. All right.
Well, I have a whole slide on the word IOs.
Awesome. All right, that is it.
Yeah. Okay. So why do we need fast data reads? Yeah, it's kind of a mute question, but let's do it. Yeah. So SQL, I already said, can do a lot of IO, and every time SQL needs to pull something from the disk, we want to go it as fast as possible. Yeah. I really like to be memory my new bottleneck and not the disks anymore. It's it doesn't matter if it's a backup, if it's a large query or something else. The faster we can read from disk, the faster SQL is going to give us an answer. I mean, that's kind of a no-brainer. The question is, do you reach a certain speed at a certain amount of budget where you can say, this is good enough for what my business needs? Yeah? The bigger problem that I'm seeing, and that is really hard to get into the heads of CTOs, is that data doesn't shrink. Data only grows. I've never seen a company that over time has less data. Yeah, that just doesn't happen. It's getting more and more and more data. And most companies I've observed grow somewhere between, they double their size somewhere between 1 and 3 years. So every 1 to 3 years to double their size. There's extremes in every direction. Don't get me wrong. Yeah? But most of them double their size in about 18 months on average. Yeah? That means that 18 months from now, you need to handle twice as much data. So if your backup already takes 6 hours today, it's going to take 12 hours in a year and a half from now, unless you do something about it. Yeah? And I'm not worried about the backup. I mean, it's also not a good thing that it takes that long. But if you actually ever have to restore something, that might take 12 hours as well then. And that might not be healthy for the business you're in. So that's why we need to keep up with storage. And we got super lucky a couple of years ago when they invented SSDs and flash storage, because the 50 years before, hard drives didn't involve much. Yeah, so I get to that. Throughput is needed when it comes to table scan, and low latency is needed for random IO. That's just the problem why you need both and all three of them, all three dimensions: size, throughput, and latency. Why do we need fast backups? I just said backups can take a long time, but the problem is that during a backup, your database is actually in a very vulnerable state. Right? So, and the reason for that is there's certain operations you can't perform or are not possible while you're doing a backup. First one of them is the log cannot be truncated. So if you create, let's say, 1 gigabyte a minute of log, you can easily take backups and so on. But if your full backup takes now an hour, you need a transaction log of 60 gigs because you can't clear it out before you need it. And if your backup suddenly takes 10 hours, you need 600 gigs of log space. Yeah? And keep that in mind. If 2 years from now you doubled, you need 1.2 terabytes of log space if your backup is not getting any faster in that period of time. Yeah? So that could become a danger. Just imagine your backup for any reason takes longer than normal. Yeah? If you don't have the capacity, I guess, yeah. So sometimes investing in the speed of storage might be more helpful to keeping it, things like the transaction log, small. So the longer the backup takes, the more space in the transaction log you need. And the second part is you can't add or remove files from a database while you're doing a backup. It's just not allowed. SQL doesn't support it. It actually explains it in a nice little error message that tells you, yeah, finish your backup, then you can add that file. And so imagine you're running out of log space because you're growing and it's running and running. You can't add a second transaction log file, even temporarily, to push the data to another drive. Yeah. So if you're running out of space on a disk, you can't help yourself. The same goes for data files. Yeah. While your backup is running, someone runs an import job and you're running full on capacity, you can't do anything. You can't add a data file. You can still grow them if there's space, but you can't add a new file. So I like to do my backups as quickly as possible so that I'm not at any kind of exposure that I can't handle the file. Yeah. Also keep in mind, it's probably not a thing till recently, transaction log files can only be 2 terabytes in size. There's a size limit. Yeah? Data files can be much larger, but transaction logs are capped at 2 terabytes. So at some point, you might have to consider adding a second transaction log file, not for performance, you will not be any faster, but for capacity reasons, you might have the need for a second one. Yeah? I already have a couple of systems where I have that problem, and it's not a big deal. It's just something, even if you have a 4 terabyte drive, you have to add 2 files of 2 terabytes each, because a single one can't exceed 2 terabytes. I put in this little table to give you an idea. So what we have on the left is the speed, the throughput of our storage. It's either 1 gigabyte per second, 2, 4, 8, 16. I went with powers of 2. What your actual storage system, what your actual NVMe's SSD can do might vary, but it's somewhere in the ballpark of these. And on the top, you see the size of your database. I'm starting out with a terabyte, 2, 5, 10, and then go all the way to 2 petabytes. And the color coding is very simple. Everything that's green is, you can do a backup in less than an hour or a restore. Everything that's yellow, it's 2 hours, orange is 4 hours, and red is 8 or more. 8 hours means it's a whole business day. So if something happens to your database in the morning, you will not be able to be back in business if you have to restore it during normal business hours. Also means it's more than 8 hours. It might take things. So the unit that this table displays is minutes. So you can imagine if you have a 1 gigabyte per second storage array, that 34,000 minutes is probably not an acceptable time to take a backup or do a table scan across the whole data. The 266 minutes is still not in the green zone as I like it to be, but might be in a possible range of things to do. So what can you expect from the average storage that you get out? Network-based storage. This is what the cloud is using. So if you build your systems in the cloud, you're somewhere between 1 and 4 gigabytes per second. That leaves me with a maximum comfortable size of about 10 to 20 terabytes that I would put in the public cloud on a single system. I fully understand that the cloud ways to do everything scale out and something, but if you need consistent relational data, that is really hard to do. So you might be stuck with some SQL solution there. But as of now, there's not much in the cloud that goes any faster. When you have SAN-based storage, that's your in-house storage area network, you are somewhere between 2 and 16 gigabytes, with the majority of the systems these days are between 4 and 8. Could you have multiple of these connections? Yes. But most of the time, the actual storage array wouldn't send you the data any faster than that anyway. So with that, you can go somewhere into the 100 terabyte range of data, but then even then you might have some serious restore and backup times, or just times to scan the data if you need a query. If most of the data is just historic one and you can restore it at a later point in time or split up, it makes it a little bit better, but keep in mind. With direct attached storage, especially NVMe drives, if you put in one drive that is very old, you get 2 gigabytes per second. If you put in a lot of drives that are very new, you can easily get above 100 gigabytes per second. I'm currently in the process of testing. I showed you already the Perfmon show where I did almost 100 gigs per second. So these numbers are not impossible. And that is super cheap storage, just directly attached. No frills, no things. It's just 24 standard NVMe drives connected to a 2 CPU machine. That is not even really expensive for what it can do. You can have about somewhere between 2 and 6 gigabytes per disk. The more disks you put in, the faster it goes. And here is the big difference between all the centrally managed storage systems and direct attached. As I said before, you have, for storage to be scaled efficiently, you need to scale all 3 dimensions. And network and SAN-based storage have this easy way of just amping up the capacity. But when you do that, you're not making it any faster. And with direct attached, the bigger it gets, the faster it gets automatically, because it just comes with the way it's built. Right? So keep that in mind. If you really need high-end stuff, that's the way to go. So next one is, why do we need fast T-log writes? Whatever we modify in the database, if it's a table structure or we insert data, we update, delete, merge, bulk insert, rebuild tables, rebuild indexes, everything needs to write to the transaction log to have a consistent way. So there's just no way you can ever be fast enough on the transaction log. It will always be the bottleneck. The big problem with the transaction log is it doesn't show up in monitoring, because nobody monitors latency of disks in any meaningful way for the transaction log. Yes, you're checking if you have more than 10 milliseconds of latency on your SAN, because then it starts to get really fast. So, but that's not the part where you have the problem. It's when everything just works fine, it's still, the latency is not good enough on most log drives, and therefore your throughput is very low. And if you ask the storage guys, hey, we're having a problem, I can't write to the transaction log fast enough, it tells you, you're only writing 50 megabytes per second. Yeah, the system can do 2 gigabytes. Yeah, it's a problem on your end. No, it's the problem on the storage end, that each individual write takes too long. And I made another table that is. So if you have a write latency of 100 milliseconds, you can do 10 log writes per second. A second has 1,000 milliseconds, divided by 100 is 10. That means you can do 0.5 megabyte per second on log writes. Yeah? That is extremely, extremely slow. And then the faster you go, the more log writes per second you can do, and the more throughput you will get on your transaction log. So let's have a look who is using which latencies. Yeah. Everything above 10 milliseconds or even 5 milliseconds is an overloaded storage array. Yeah, that should not take that long to either do a read or a write. If you see that, it means it's doing too much work. Yeah, it's doing more than it was supposed to do. Yeah, it will still keep doing it, but it will doing it very poorly. This is the same as if your boss tells you you have to do 200 rollouts per week. You will somehow do them, but they will not be good anymore. Yeah. A regular SAN is somewhere between 10 milliseconds and about 2 milliseconds, and the new high performance SANs are going up to 1/4 of a millisecond. Yeah? That requires you to directly connect them and have dedicated ports and all kinds of things to make it that fast, but it is possible. So with network-based storage, you can get up to about 3,000 to 5,000 log writes per second, which gives you about 200 megs per second. 200 megs per second is the speed of a single hard drive. This literally, if you buy the cheapest hard drive you can get at your favorite dealer, that's what it is. Yeah, it's not it's a $200 hard drive can write at that speed. Yeah, so keep that in mind. That's what the network is doing to your latency, and we'll get to why. If you take a regular SSD and put it in, you're immediately about doubling your throughput. Regular SSD is the thing that you could buy 5 years ago. It's the thing that's probably in your old laptop. If you buy an NVMe disk today, which is the newest generation of solid state drives, you can get probably 10 times faster than 10 to 100 times faster than you're on your SAN connection. And this is a really cost-effective way of boosting up your speed. Especially you can do it without any hesitation on TempDB. When you do it for your database disk, you must ensure that the data and so is still protected, but we'll get to that in a few moments. So this is, if that is still not enough, you can use a technology called NVDIMM. NVDIMM is basically a memory stick with a battery glued to it that pretends to be a hard drive. And then you can write really, really fast. I've seen even up to 1 million log writes per second. Yeah, so that will usually deal with it. Because if you can insert with 20 gigabytes per second data, you're in pretty good shape. Yeah, 100 gig table would take 5 seconds to rebuild its index. Yeah? So everybody who has rebuilt a 100 gig table on a regular system knows that this is usually a multi-hour task. On a system like this, we would take 5 seconds. So doing it online would actually not help the performance even anymore. So good point to check for questions.
Yes, we have one here. Steve asks, for the throughput versus size slide, are you able to hit near 100 gigabytes per second with a single array? And are you running into HBA or SCSI limitations?
So no storage array can go anywhere above 16 gigabytes per second that I know with a single host. Not even storage arrays are not for high performance. High performance is done with direct attached storage. Everything above 16 gigabytes per second is direct attached storage. There's just no way around it. You can attach multiple arrays and you need multiple HBAs. The way I achieve that speed is, and I will get to the slides later, I do direct attached NVMEs to the CPUs. So I have 24 NVMEs directly attached to 2 CPUs, and each one is dealing with 12 of them. There's no way a storage array can ever get to that speed. Yeah.
Cool. All right, that's the only question we have at the moment.
Okay, so going back to the basics, what are raw storage devices we have? Hard drives, spinning disks. They are around for 50 years, they work, and they still have one use case, and that's long-term archival. Yeah, you need backups to put them somewhere. Hard drives are still a good choice because they're dirt cheap. The second group is SSDs, NVMe drives, solid state flash disks, whatever you want to name them. Time will tell what we settle on. This is what you should be using these days. Persistent memory was a great idea, but as the comment from the gentleman before said, yeah, Intel just announced 2 days ago that that's no longer an option. Yeah, so hard drives you should not use for databases anymore. Use flash disk wherever you can. Persistent memory is discontinued by Intel. It was a great idea. Problem is it was way too expensive to ever get traction, and then it didn't get traction. So Intel said, we're not making enough of it, therefore we can't make it cheaper. So nobody bought it, and it became a very niche thing that made no sense. NVDIMMs, they are simple because that's a normal memory stick with the battery glued to it. It's a little bit more complicated than that, but most major hardware vendors have an NVDIMM solution in their portfolio. They might not bigly advertise it, but they have it, and they're now up to 16 gigabytes in size per DIMM, and they even have now solutions where it's no longer a glued battery, but they actually have a way to connect the memory stick to the main board and have either batteries or capacitors to handle this. Yeah, so it's becoming a little bit of traction because that one is for the extreme cases, and people are willing to pay anything to make that happen. So you have the raw storage devices, and each one of these devices can come with different interfaces on it, and that's what makes storage so complex. Yeah, so you have a memory interface like persistent memory or NVDIMM. It uses the same interface as your normal RAM. You have PCI Express, which is mostly used by NVMEs and NVMe SSDs and storage controllers. You have SAS, serial attached SCSI, which is used by SSDs and HD hard drives. You have SATA, which is a cheaper version of SAS, and usually the hard drives are cheaper that are attached to it, but basically the same thing. Both SAS and SATA are for if you use them for SSDs, the interface is your bottleneck. The SSD can go much faster. The SATA or SAS is the bottleneck. That's why NVMEs decided not to use any of the old interfaces, but go directly to PCI Express. And the last one is fiber channel. That's used in the SAN world. There's actually hard drives that have the same kind of interfaces that your host adapter would have. So it's easier for the SAN vendors to have like one technology in their systems. It's a thing, but it's clearly on the way down. Yeah? There's a bunch of old protocols. If you recognize one of them and you used one of them, you are somewhere in my age. So congratulations. PMEM, no longer an option. Intel basically canceled it. PCI Express, NVMEs are on the uprising. More and more people, more and more solutions are using them. All the other technologies are basically on the way down. And they're still used, mostly because of historic reasons and the arguing from someone, hey, that's the way we always did it. So not the greatest things. So now we know we have these storage devices, we know which kind of interfaces have. So how do we connect them to our CPUs so we can actually get to the data? And this is where you will hopefully at the end of the slide finally understand why direct attached storage is so much more efficient than network-based storage. Network-based storage is super convenient. I need it somewhere else, I need it bigger, smaller, I can do that, but that doesn't mean it's fast. So NVDIMM persistent memory. It's very simple. You have your CPU, and you directly connect the storage device. There's nothing in between. It's just the memory bus, and you plug it into a regular memory slot, and it's just there. So that's the fastest. You can't, as of now, the only way to be faster is to buy an Apple M1 or M2 MacBook and have the memory inside the CPU, but that's not persistent memory. So not really using for storage, but that's the only way to make it faster than this. NVMe drives, on the other hand, has a CPU. They have a PCI Express bus in between, and then there's the storage device, which can either be a card or a regular hard drive that goes into the front or the back of the server and uses an U.2 form factor to connect to that. But on a protocol level, it's still a direct PCI Express connection. It's nothing else. It's called an NVMe disk, but it's the same thing as that card. It's just in a different form factor, and it has a cable instead of the connector directly. Regular NVMe SSD hard drives, you can also have a CPU with a PCI slot and then put in some RAID controller that pretends to give you protection of the data, and then have the regular disks connected to it. And the last one is you have a network attached storage solution, either SAN or iSCSI or whatever your favorite cloud provider uses. Yeah. So you have your CPU, you have your PCI bus, then you put a network card in, which is either an HBA for fiber channel or a regular Ethernet network card, depending what kind of thing is. Then you have a network. Then you have a network card on the other side. Then you have another PCI Express bus. Then you have a CPU. Then you have another PCI Express bus. Then you have some kind of a RAID controller. And then you have the disk. And even if that disk is the fastest disk in the world, that pile of hardware in between made it super, super slow. Because every time you do an I/O, each one of these little devices that are on the screen at the bottom need to do something. And that's basically, if you have a very large company, that's the chain of command, and you know how long it takes if the big boss says something till the little guy at the bottom finally actually executes on it. This could be days, weeks. In the storage world, it's milliseconds, but that's a long time when you're talking about computers these days. Current storage options, and that's another slide I had to modify in the last 2 days. You have NVMe disks or PCI Express cards. You have the NVDIMMs, that's the storage with the battery. Persistent memory was the third option, and the latency on modern devices is measured in microseconds and nanoseconds, not in milliseconds. So every time a storage device tells you their speed in milliseconds, a light should go off in your head and say, hey, that is slow. That is no longer fast. 1 millisecond, while being blazingly fast 10 years ago, is insanely slow today. And we have to get into that, because with constantly growing data sizes, we are cornering ourselves into a position where we can't get out unless we do something at a reasonable time frame. Yeah. On an NVMe drive, you can read about a petabyte in about 70 minutes if you do it right. Yeah. On these NVMe DIMMs, you could do 24 terabytes in about 300 seconds. So that's 5 minutes. 5 minutes to scan 24 terabytes. And on an NVDIMM, you can do 1.5 terabytes in about 3 seconds. Yeah. And that's a lot of data that you can move. But unfortunately, persistent memory, if you can buy, maybe you can buy it cheap now because it's discontinued, but I'm guessing that at least 1 or 2 generation CPUs down the road, they will lose the capability of deal with this memory, and then it's gone. So IOPS, I promised before, this is the thing I hate the most. IOPS is not a measurement that has any meaning. It's just not, it doesn't say anything. Yeah. So let's say 10,000 IOPS. Is this a lot or not? Yeah. And I can't tell you because I don't know, because if you don't specify the IO size with IOPS at which these IOPS were measured, it's a completely useless measurement. I hate it when storage vendors or hard drive vendors or anybody just puts an IOPS there and doesn't say, was this with 4 kilobyte, 8 kilobyte, 32 kilobyte, or 2 gigabyte IOPS? Yeah. Let's take the 10,000 IOPS. So I say 10,000 IOPS is A, super good, and B, super horrible at the same time. It's like quantum physics. It can be superposition and can be both at the same time. Yeah. 10,000 IOPS, when I do backups at 4 megabytes per IO, that's 40 gigabytes per second. That's an awesome box. That will give you nice little backups. Just imagine you have a 100 gig database. It takes you 3 seconds to take a backup. Yeah. 10,000 IOPS at 4 megabytes an IO. That's a great storage array or storage system that you built. 10,000 IOPS at random reads for SQL Server of 8 kilobytes each. That's 80 megs per second. Your phone is probably 10 times faster than that. Yeah. So 10,000 IOPS at 8 kilobytes per second, at 8 kilobyte size is not good at all. Yeah. So IOPS by itself is not anything that has any meaning unless you put it out there. And unfortunately, with IOPS, you cannot do simple math. So if someone tells you they can do 10,000 IOPS at 8 kilobytes, doesn't mean they can do 5,000 at 16. Could be that they can do more than 5,000 at 16. Can be that they can do way less. It always depends on the architecture and where and how they achieve doing things. So to summarize the whole thing about which types of storage are there, there's a storage pyramid that goes at the bottom of tapes. Yep, they're still around and they still have use cases. Hard drives, storage arrays, solid state disks, solid state devices, NVMe, persistent memory, CPU caches, and then CPU. Yeah. And the more you go to the top, the more expensive it is. The more you go to the bottom, the more latency you have, but also at the same time, you can get much more capacity on them. Yeah. It's much harder to put memory. To put a terabyte of memory in a server is much harder than to put a terabyte of storage in a server. Yeah? And that pyramid is there. So you can nicely refer to that. By the way, I already uploaded the things. So another good point to check for questions.
And we have one more question. They ask, regarding backups, isn't VSS the solution for making them finish faster?
So, okay, VSS. Honestly, I don't know if I can answer that question because I don't know if it's still under NDA or not. So I rather not. So whatever VSS does in 2022, in my opinion, only partially changes the game. So let's have a look at what it does today. Today, VSS allows you to take a snapshot on your storage array, which is great. Yeah, and which can help you in taking a backup very quickly. That is true. So that becomes what is called an operation that is no longer depending on the size of the data. It's a non-size of data operation. Yeah, and there's plenty of storage arrays out there, even the ones Anthony works for, that do this really great. And I've used this in the past. It helps you with backups immensely. The problem with that is it only helps you with restores if you put every database on its own storage disk. The moment you have two databases and you only need to restore one of them, you can't use the same technology to bring the data back. Then you have to do a size of data operation again by copying it back. Yeah. Because yes, if you take the snapshot and you can just swap that snapshot back in, you are good to go. The problem is if you don't need all the data back, that restore suddenly becomes a non-metadata operation, and then you have the problem there. Yeah, think it through. It's great for backup things. The discussion if a snapshot is a valid backup, because if you lose the storage array where you now have your data and your backup, is a different story. But you could use the snapshot to then mount the database on a second machine and then take the actual backup from there. But usually snapshot backups in any form, you need a lot of training for the DBAs and everybody involved to actually make that happen, to make sure that you can apply log backups after you applied the snapshot, and to do partial restores when you don't need all databases restored. So yes, it's a technology, but while it definitely makes your backups easier, make sure you have a plan for each and every scenario you need to restore. That can be tricky. I'm not saying it's impossible to do. I'm just saying lots of people don't prepare for it and then are surprised and then have a problem on the day when it happens. But the backup only took 10 seconds. Why does the restore now take 3 days? Because we can't use the technology. Yeah? So yes and no. It can help, it cannot. Good. Next chapter, the sad part.
Actually, we got one more question here.
Yeah, sure. Okay, sure.
And you may answer this later. I'm not sure, but is disk speed still the go-to tool to test the performance of your disk subsystem, or is there an alternative that you suggest?
So disk speed is a tool to measure the raw disk of your speed. I prefer to do all my disk performance tests through SQL Server, because then I know how it's actually going to look like. Yeah, it's very easy to create a table that is a couple of terabytes in size and do a table scan on it. Yeah, I have a script that creates that. I might even upload it and share it. Yeah, it's just using some tool to create an artificial workload can give you a basic idea what's going on. If you want to know what's really going on, have the actual tool, like in this case, SQL Server, do the stress testing. It's like you can do backups and restores. You can run 10 of them in a row, in a loop. Yeah, you do 100 table scans. You rebuild the same index 50 times. Yeah, these are all things you can test, and SQL is doing the IOs. So you see how it actually happens. Because yes, all these tools have great settings and how you do this, and random IO and sequential and this size and that size. But in the end, SQL does what SQL wants to do. And it's most likely going to be something different than the measuring tool will do. Yeah. So do I use them? Yes. Do I use them for the actual final tests and where I figure out what the systems can do? No, I try to use SQL Server itself.
Okay. We get more that keep piling in here. What about NVMe OF arrays? Do they have the same limitations of other arrays?
So the moment you have a network cable involved, it's slower. It is. Are storage array manufacturers trying to make that latency as little as possible? Yes, they do. Yeah, I remember times when SAN couldn't get below 2 seconds per IO. Now we're talking 0.2 seconds, or 10 times faster in 10 years. Yeah, that's a big accomplishment. Yeah, will NVMe based, so there's NVMe over Ethernet, there's NVMe over all kinds of technologies to be tested. Yeah, the main reason we moved from individual hard drives to shared storage arrays was because an individual hard drive could not be fast enough for the needed capacity. Yeah. With NVMe drives, that's no longer the case. So the main reason why we moved to a storage array doesn't exist anymore. There's now new reasons to move to a storage array with all their functionality, like snapshots, like clones, like all kinds of awesome things, compression, things they can do. But to get the maximum performance possible, that's never the reason. If you're looking for performance and you're looking in the direction of a storage array, and with performance, I mean high-end performance, yeah, then you're probably looking in the wrong direction. Storage arrays are very good for small, medium-sized, even the bottom of fast and large workloads. It's not for high-end. If you need high-end, you're looking at the wrong thing.
Okay.
If a storage array is a cheaper solution or not, it depends. It depends which price you're getting. It depends what your limiting factors are. Yep.
Okay, and maybe one more quick one here before we let you go on. Would you recommend formatting SQL partitions using 2 megabyte blocks?
Yes.
Okay.
I'm not recommending 2 megabyte blocks. I'm recommending whatever is the largest value currently possible on your operating system. So when Microsoft increases it to 4, 8, 16, or 200 gigabytes, choose that. While it has, for a single IO, it has no impact, but it lets the OS figure out where your block is faster if there's less blocks. Let's put it this way. Yeah. So if there's less clusters on the disk, you can find the individual cluster faster because it's less arithmetic to do. Yeah. It's very simple. If you put your money or if you put something into 6,000 drawers, it will take you much more time to get it out than if you put something in 10 drawers. Yeah. To get it out again. Yeah. And that's what the size is. Would I reformat a machine because I found it's formatted with the wrong cluster size? No. Would I put it as part of my automatic installation to use the right cluster size? Yes. Yeah. I've never reinstalled the system because someone picked the wrong cluster size for the hard drive format. But I make sure that all new ones would be built correctly. Yeah. Yeah, if you have like a 4 kilobyte size, I might reconsider it. But if it's currently 64K, you're fine, even if it can do 2 megabytes. But should you use 2 megabytes, definitely go for the largest. You will not have small files on the same drive. You will only have SQL database files, and the minimum size is literally 2 megabytes now. Yeah, so you can't have a single file that is not using the full cluster size. So you're not wasting any size in any form. Yeah, go for it. Good. Moving on to the bad side of storage. While storage arrays and out of storage is really good in detecting failed hard drives and detecting some things, they're really bad in figuring out undetectable write errors. It might be in the name, the word undetectable, that it's really hard to figure them out. So what's actually going on? Data is stored in sectors of either 512 or 4096 bytes. 512 is the old size. Every spinning hard drive uses 512. SSDs use either 512 or 4096. And modern NVMEs are most likely use 4096. Some of them have a mode where you can put them in the 512 compatibility mode. Thing is, storage arrays usually let you pick these days, so you can configure it. The reason for 512 was what they could guarantee that you can write in one atomic operation. They couldn't guarantee that the hard drive, if it loses power, would finish more than 512 bytes. That's why they limited it to 512. SSDs with capacitors these days have no problem writing the full 4 kilobytes, and therefore the size was increased. And same as with the cluster size of the file system, the less sectors you have, the easier it is to manage them. Yeah, because honestly, these days, more energy goes into the managing which sectors are free and usable than managing the actual moving the data in and out. Okay, so we have the data stored. The storage devices keep checksums to figure out if whatever is in that sector is okay. So while they give you 512 bytes, they actually have a couple of more bytes. In the past, there were actually hard drives that gave you 520 bytes, so 8 more, in addition to the internal checksums, so that the RAID controllers could use the 8 additional bytes to do their own checking. But that doesn't exist anymore. Yeah. So undetectable write errors happens if a multi-bit flip results in the same checksum, and that can happen. no checksum is perfect. Yeah, checksum they try to be really good in detecting multiple bit failures and things, but there will always be the possibility for a combination if you flip enough bits that in the end you end up with the exact same checksum. Yeah, and if that happens, then it's an undetectable write error. If you just flip bits and you get a different checksum, then you still have a write error, and that happens much more often than undetectable ones. But at least your storage device knows, oh, that's broken, so you should probably not trust what I'm giving you back, because I have no idea if it's correct or not. Some have even a couple of bits so they can fix like a single bit or double bit failure. They can correct it like memory, ECC memory. But there is three cases: the fixable ones, the unfixable ones, and then the undetectable ones. And that's the nasty ones. And I would say that on average, about every petabyte you write, you have one undetectable write error. That just happens. It's a bit that somewhere, a bit combination that somewhere flips and doesn't give you. Most detectable write errors are actually detected while you're still writing them, because the flipping doesn't actually happen on the storage device. The flipping might happen anywhere before there, and the storage device then checks the checksum again and says, oh, no, that's not correct. Please send it again. And then it doesn't happen the second time. So, undetectable write error, the RAID problem. People think RAID protects them for everything, and that's not true. RAIDs are designed to protect you from a failed disk. That's pretty much what they do. If a whole disk fails, they figure it out and they keep you going. But if individual bits on a sector are flipped in a way that the checksum doesn't change, a RAID array has no idea what's going on. So let's go for an example. The original data, a bunch of ones and zeros, and we have a RAID 1. Simplest one, 2 disks, they both get the same data. So the first disk stores a 0, 1 in the middle of that binary string with the checksum of 0, 1. And then our checksum calculation somehow, and this is super simplified, every regular checksum would detect that flip. Yeah, I'm just flip 2 bits around and I would come up with the same checksum. Yeah, super simplified, much more complex in the real world, but to understand it. So these are now the data on disk 1 and disk 2. Both disk things, hey, everything's fine. My checksum is correct. I'm a happy camper. So if you now read the data back from disk 2, everything's fine. You still have valid data, it's correct, and everything's happy. If you read disk 1, you get corrupt data. So most RAID controllers on a RAID 1, when you ask for the data back, they ask one of the 2 drives to give you the data back. So there's no check that this data is different on one disk to the other. Yeah. Some RAID controllers have a mode where they let you compare, where they read both drives and then compare the data and they give it to you back. The problem then is, if you read both, you don't know which one is the correct one. But we know in our example, because I told you in the first line, but if I don't show you the first line, you wouldn't know which one is the correct one. Yeah, and that's the problem with the undetectable write error, that you write data and you can't tell that it's wrong. And this is the problem with RAID. So the same problem exists on RAID 5. Yeah, the parity disk is calculated in a single checksum way, and therefore, if the bits flip correctly, you can't find it. On a RAID 5, you can actually have the bits flipped on different disks and create that situation. So what's the hardware solution? The hardware solution took many years to get, but it is. There's a triple RAID 1. Most modern RAID controllers now have a triple RAID 1. They call it TR1, something like this. It's actually, you have 3 copies of the data. So if one of them has this undetectable write error, you can ask all 3 disks and then you go with the majority. And it's very, very unlikely that 2 disks fail in the same way at the same time. Yeah? So the majority can give you. And the same goes for RAID 6. RAID 6 has 2 different ways of calculating the parity. So they have a chance of finding that. The problem is that RAID controllers by default these days either do not check data consistency, or because they sacrifice this for performance. Don't forget, 10 years ago, that RAID controller had to deal with 200 megabytes per disk speed. Now they have to deal with 6 gigabytes per disk speed. So everything they do is just something that slows them down. So by default, most RAID implementation these days just don't check for consistency at all. Yeah? And that is something to consider. Some of them have the option to turn it on, but then expect the controller to become slower, which is fine. It's always a battle between do I need correct data or do I need quick data? I guess, yeah, but it's there. There's a software solution. It's called SQL Server that can also find undetectable write errors. It's called Always On Availability Groups. No, the actual feature that finds the problem is the page checksum on your page. Page checksum is guaranteed to be a very different algorithm than whatever your storage system uses. So when your storage system flips a couple of bits and doesn't detect it, there's a very, very high chance that the SQL Server checksum will find it and tell you, yeah, we have a problem. If you have always on availability groups, there's a very, very, very high chance that none of the other replicas is affected by that bit flip, especially if you use independent storage for the replicas. In many cases, these days, when I build systems with always on availability groups, I consider not even having any RAID protection on the individual servers. The times that actual drives fail, yeah, it happens, but it's not a big deal anymore. You have always on, you fail over to the next node, you fix the drive. It saves you a lot on capacity, it saves you a lot on performance. It allows you to not use RAID controllers at all. It depends. Yeah, if that is the most important data the company has, yeah, different story. But most data these days can be reproduced or recreated from some other place. And having the one-off chance that all your replicas die at the same time, yes. Again, choices is there. You need a pair of servers anyway for HADR. So you have two copies of the data anyway. Going from 2 copies to 3 copies, it might be cheaper to have 3 servers with half the disks each than to have 2 servers with the full set of disks each. Yeah? Again, depends on where you buy, how you buy, but it's something I want to plant in your head that this could be an option. So the next one is just a reminder. This was in a previous talk from me, but it's so important. You have to balance your resources between your CPUs. Yeah? If you have 2 CPUs, you put half the memory on each CPU, you put half the disks on each CPU, and you put half the network on each CPU. This gives you the best possible balance in your system. Yeah? I see a lot of vendors that by default ship a configuration like this. They split the memory, but then they put all the disks and all the network on the first CPU. Okay? This is most vendors' default way of shipping things because it saves them $10 of putting in the second card or something. Yeah, that's what it is. I've even seen really bad vendors putting all the memory on one CPU and just putting in the other one blank. That means CPU 2 has to ask for each and every memory access the first CPU, which is insane. Yeah, so balance your resources. It's very simple. When you get a shipment, make it open, see where the cards are. If everything is in one half of the server, there's a good chance you have an unbalanced system. If everything is on your motherboard, you definitely have an unbalanced system because motherboards put everything on the first CPU. They can't because otherwise they wouldn't work unless there's 2 CPUs in them, and all dual socket motherboards work with 1 CPU. So everything that's on board is always on the first CPU. Yeah, probably one last stop before we go to the finish line for questions.
We have a question here. Is the main source of undetectable write errors cosmic rays from things like solar flares?
I don't know. I would say it's a combination of solar flares, overworked firmware developers, and bad luck. Could a solar flare do that? Yes. Is it more likely that someone's cell phone rang in the data center in the wrong moment? Is it possible that someone kicked the server in the wrong moment? That there was a light earthquake that made something happen? A power surge? There's so many reasons why this thing can happen. Don't forget, these things these days, if you look just inside your CPU, yeah, the things that connect the transistors, yeah, they are 3 to 5 atoms wide. Yeah, if this thing takes a turn and an electron is not staying in the lane, this electron just jumps to the next lane. Yeah, this is what's happening. Everything gets smaller and smaller and faster, and this happens. Yeah, would I put my servers out in the sun on a day of a solar flare? No. Would I freak out about every time there's a solar flare? No, because there's some almost every day. It's just the big ones that we bother about. Yeah. So yes, they are one of many reasons why it can happen. I guarantee you, bad software happens more often than solar flares. It's just, you think when you buy a hard drive, you buy it the way it is. They have software updates every couple of weeks because someone finds some reason why this hard drive in some conditions stores the wrong data. Yeah, and that same goes for SSDs and everything else. Yeah, even the commercial large storage arrays, they offer software updates very often, multiple times a year, because they make it better. Yeah, they find things that they didn't think about or that didn't happen up to a certain workload, and then someone has that workload and finds it, and it's great that they fix that. Yeah, same as with your server and SQL Server patches, same goes for every component all the way down to the individual disk or the controller, yeah, or the cable or something else. Yeah, so not always solar flares. Good. More questions?
Nope, that's it for now.
Good. So, this slide is a call. If any vendors are there, I'm looking for someone to build me that. You can't buy that. What I'm showing you right now, but that would be the ideal system if I want to use one CPU and I need to buy the perfect machine for databases. Yeah, that's what I would do. So a little bit of a legend first. We have 16x PCI connectors. We have 8x and 4x, and we'll use them. So you have one CPU. That's the middle of everything. And I would connect the dual port 100 gig Ethernet card with an X16. And yes, I know that X16 is technically not enough to serve two 100 gigs, but I would use only one port at a time. So therefore it's fast enough. This is just for redundancy, so I can connect to two switches. The next thing is I would take a triple RAID 1 controller with a hot spare for my transaction log files. And I would connect the fastest NVMe drives that I can get, which are currently 8x, onto that RAID controller, and would run it in super safe mode for finding undetectable write errors. Yeah. That would give me a theoretical these days a transaction log drive capacity of up to about 8 terabytes. Yeah, 15 probably coming soon, but for the full performance, we're limited to 8 terabytes. The 15 terabyte drives are not yet fast enough. For the data, I would take RAID 6 controllers, again in safe mode, and put 8 regular NVMEs onto one controller, and then have a total of 6 of these controllers in my system. And yes, that's the exact maximum a current AMD CPU could handle. One of the RAID 6 controllers would have to play the hard drive for the operating system, but I'm pretty sure I can squeeze out a couple of gigabytes in one corner of them. The remaining things could handle. With current today's disk capacity, you can run this at up to about half a petabyte of storage in a single box. That would be if someone would build a box where I can put that many hard drives in. That's why I'm asking for. What you practically can build is the same thing with a total of 4 RAID 6, 1 triple RAID 1, and 1 dual port 100 gig. That's possible. But the 2 additional ones, while the CPU could handle it, no vendor that I found so far has a box that could has the physical space and the layout to do all 6, but it would be theoretically possible. From a speed, the theoretical speed would be each one of these controllers can do about 28 gigabytes per second. So we are almost talking 120 gigs on each side. So let's call it 100 on each side. So that would be about 200 gigs per second theoretical read speed from the disks. Write speed would be slower because usually disks write a little bit slower than they read. Practically, and a setup with this, with 3 of them, got me to the 98 that I showed in the beginning with perfmon. With 3 of these rate controllers got me to the 98. So 4 will probably push me at the 110, 115 range, and all 6 will get me to the 150 range thing. Yeah. So that would be the ideal. The fun part is if you take the same exercise to a 2 CPU system, you will see a funny surprise. 2 CPUs, same starting point. So instead of 1 CPU, we have 2. The problem is, or the most important thing is, we have to connect these 2 CPUs with 3 X16 connectors. Then we can give each one a network card, which is nice. And then we can give each one a triple RAID 1 controller. So we can have, if we have multiple databases, each one can have its own controller, or you can use one for TempDB, the other one for your regular database log file, many possibilities. And then I can only attach the same capacity on data disks because that's the limit of PCI Express lanes. Still good. The nice thing about this 2 CPU system, while technically it has the same capacity, it can process most of the data faster because I now have 2 CPUs that can crunch the data. Yeah. So it depends. The first system gives you the lowest possible latency. The second one gives you the highest possible throughput with 2 CPUs. Can you build this in any other size? Yes. You can attach petabytes to larger systems. There are systems up to 32 CPUs these days. So you can imagine that you can attach a lot of things to them. Right? Good. So we're now coming to the last thing. Enough of hardware and anything. Let's go inside of SQL Server. What do you have to consider when you work with storage and multiple disks? Yeah. One of the most important features in Enterprise Edition is that you have read ahead when you scan through your data. Because as we learned at the very beginning is that an 8 kilobyte IO takes virtually the same time as a 64 kilobyte IO and takes virtually the same time as 256 or 512 kilobyte IO. Yeah, they take a little bit longer, but the majority of the time is to tell your storage system that I need that, and the storage system to find it and actually return it. How much it actually moves doesn't matter. It's like if you have a coworker and you ask them to do something, if you ask them, give me 1 sheet of paper, it will take them, I don't know, a minute to come back to you with the sheet of paper. If you ask them to give me a stack of 50 papers, it will virtually take the same time. It might take him 2 or 3 microseconds slower because it's heavier and it takes him longer to lift it. But everything else is going to take the same time. Yeah. So the more you can read in one go, the faster your overall system is. And the people who wrote SQL Server realized that and therefore implemented this system of read ahead. So when you scan a table, SQL Server knows you're not going to need just the next page that's in the list. You're going to need all the pages. So are the next couple of pages contiguously on the drive? If so, then we read them in one go instead of 8 kilobytes at a time. Yeah. So this is why when you had by rebuilding indexes is still sometimes a valid operation, so that you reorder all your pages on the disk so that you have as many contiguous pages as you can think of. So the ideal one is you have one disk, you have one file, and you have one table. Yeah? And you always insert into that table in sequential order, and then you always have a perfect way of scanning that whole table in one go, and therefore you can do a read ahead across the whole table theoretically. Yeah? So that's the ideal world. The problem is in the real world that doesn't happen. So first thing is we might have 2 different tables that grow at the same time and therefore allocate different amounts of space in between. So now read aheads could only read smaller portions at a time and not the whole thing. Yeah. So that's most likely to happen. So what a lot of people don't consider is that even if you have that scenario here, you would run an index rebuild and you would have all the blue ones in the beginning and then the orange one later, or the other way around, but you could clean that up with an index rebuild. The problem is if you use multiple data files, an index rebuild doesn't actually clean up what you try to clean up. Because when you have multiple data files, this is how SQL Server writes. It jumps between the two files. So one write to this file, next write to the next one. If you have 10 files, it cycles through all 10 files before returning to the first one. So if you now try to do a read of consecutive pages, it will not work because the next consecutive page is literally on another drive or in another file. Yeah. So when you use multiple data files, you effectively disable read ahead. And in the real world, this is even more thing is because if you have multiple tables and they grow at the same time, you have a jump back and forth between the files. It's a real mess. But if you would clean up everything, you would still not end up with contiguous pages on the same file. Yeah. And to fix that, there is, I think it's not the most undocumented. I think there's features that are not documented in Books Online at all. But in all of Books Online, there's a single paragraph mentioning that option. And it basically says, yeah, it's there. It can make things faster. Don't use it unless you know what you're doing. That's me paraphrasing that one paragraph, but look it up. It's under SQL Server Starter Options, -E. Don't confuse it with -lowercase e. -lowercase e, very different option. Don't mess with that one. It's -E. What that thing makes SQL Server do, that's your friend if you have large tables and multiple files. What it changes is, instead of allocating one extent in one file and then moving on to the next file, it will allocate 64 extents before moving on to the next file. So when you do an index rebuild, this is what happens. So it writes a lot of extents in each file and then moves on to the other file. And then you can do read ahead again, because if you have 64 consecutive extents, that actually gives you a total of 4 read aheads of 512 kilobytes each. Yeah. Thing is, if you use that option on a machine that has tiny little tables and something like this, yes, it's counterproductive. But on a big data warehouse where you have large tables, large fact tables, and you clean them up occasionally, this will allow you to have read ahead again. It's something you don't notice that easily, but if read ahead can make your IO go much faster. Good. So yeah, that's all I have for today, and I think I'm pretty good in time. So let's start with finish off if there are any more questions.
Yeah, we've had 2 come in. So first one is, I may be missing some hardware knowledge, but how do I dedicate a network card to a specific CPU?
So it's very simple. Each CPU has PCI Express slots connected to it physically. There's copper going from the CPU to the slot. You put one network card into that slot and the other network card into the slot that is connected to the second CPU. It's a physical thing. It's this. The drivers are finally intelligent enough to pick up on that and run on the correct CPU. It took them only 20 years to get there, but they're finally there. It took a long time. There were registry hacks how you could assign the drivers, but you not have to do this anymore. Every decent network card manufacturer now has drivers that figure out, oh, we are connected to CPU number 3. Let's run on CPU number 3. So we don't have to ask all the other CPUs for help every time we do an IO. No, it's a physical thing. It's every PCI slot and every expansion slot is dedicated to a specific CPU from the manufacturer. And you just make sure that you put them in one slot for each CPU. Okay. It's not a magic thing. It's very simple physics.
Gotcha. And then one more question I see here. Can you talk about how Enterprise Edition handles read ahead better than Standard Edition?
it does bigger read aheads, more bytes. The standard edition has a limit. I think it's 128, so 2 extends at a time, and Enterprise edition does 512 at a time. I think that's the last time I checked. The numbers might change. This is little things that Microsoft always tweaks around the time. So it might be standard, might be at 256 now. I don't know, but I know that only Enterprise can do the full 512. That's for sure. There needs to be a reason to charge us more.
All right, that is all the questions I see in the Q&A at the moment. So wait, one just popped in, made a liar out of me. For a 10 terabyte database, what is the optimum number of data files? 9 or 12? I'm guessing there'd be some testing involved in arriving at that answer.
So, so the number of files. So if you put the files on the same disk, it doesn't matter. Yeah, from a performance perspective. Let's put that statement out. If you have multiple disks and you want to spread it out, I would always recommend 12 files, because 12 files give you the most flexibility. 12 files, you can put all 12 files on the same drive. You can put 6 files on one drive and 6 files on the second drive. You can put 3, you can have 3 drives and put 4 files on each. You can have 4 drives and put 3 on each. You can have 6 drives and put 2 on each, and you can have 12 drives and put 1 on each. 12 gives you the most flexibility. So I usually have 12, 24, and 60 files. Yeah, 12 on everything below 100 terabytes, 24 everything below 500 terabytes, and everything above 500 terabytes is 60 files. Yeah. That's what I use. 60 gives you the most flexibility, because 60 also adds the capability of multiples of 5s of drives, while 12 gives you 1, 2, 3, 4, and 6, and 12. Yeah, so that gives you a lot of flexibility. 9 only gives you the flexibility to put it either on 3 drives or 9 drives, but nothing else. And that always not considers the log file, which always should be a separate drive. Yep. So
cool.
That's it.
All right.
And how many files you use is more like what you're comfortable with the maximum size of an individual file. Yeah. So my reason for 100 terabyte is so that an individual file doesn't get above 8 terabytes. The reason I feel comfortable with 8 terabytes is because I don't have a single hard drive that's not 8 terabytes in size. So whichever drive I find somewhere, I can put that file on it, and I don't have to worry about not having enough. This is more what you feel comfortable with. Yeah? Again, the more drives you have, you need to split it up to get the performance gain. But lots of storage arrays perform as well with one gigantic drive as they perform with 12 small drives. Yeah? So don't over-engineer your solution. Talk to your storage vendor. I know that some of them perform really well with just a single drive. Yeah, where you can even mix log and data files on it. Yeah, others have advantages if you have multiple drives. There's no clear answer. Every vendor is different.
Cool. All right, that's all the questions I got.
Good. So, as I said, I already uploaded the slide deck. Hope everybody could find some information. My email is hopefully somewhere. It's on this slide. Yeah, it's there.
Sorry, I grabbed the slides off
no
you.
problem.
I'm afraid to.
My email is on the second slide. So if you have any questions, email me. I usually answer over the weekend. So if you write me on Monday, it might take a week to get an answer. If you write me on Friday, you might get it the next day.
No worries. So, thank you so much. Thank you so much for your session, Thomas. Okay. And yes, if we have any questions pop up in Slack, I can see there's already a couple more coming in from Q&A. I know it's just feedback now, just saying great presentation. And Jim Murphy absolutely loved your session.
Okay.
So honestly, with your sessions, Thomas, I'm going to have to go back and rewatch just to have it all sink in, I'm afraid. Yep. Now, there's a lot of information that gets thrown at people out there. So, no, but absolutely amazing. Thank you so much.
You asked for it.
I know.
8,000 option, I'm going to use it. Yeah, and I hope there's a 64K option next year.
So everyone,
I actually do have a question, TG.
Yeah.
Can you dig into the 2 megabyte NTFS allocation unit recommendation? Because why would I want that to be greater than an extent inside the file system?
So it's not creating a split IO if it's larger. This has nothing to do with how much data. Even if you write an 8K, even if you write 8 kilobytes or a whole extent, technically it's a lot of 512 byte or 4K writes in the bottom of the IO stack. Yeah, it's this cluster size on an NTFS volume is a management unit. This is literally how many drawers gets the drive be in how many storage units do I divide it? And the more storage units I have, the more work it is to manage them. It's the same thing. If you allocate all your memory in 20 byte pieces, your operating system at some point will gonna go belly up. But if you allocate them in like a megabyte at a time, you're having much more efficient use of it. It has nothing to do with how much data is written at a time. This is just how the free space is managed on a drive. And
so I guess the question is, if I stick 4 kilobytes in a 2 megabyte drawer, am I wasting space?
Yes, but if you only put SQL databases on that drive, which you should not put anything else there, then there is no risk of ever doing that. Your SQL database files are multiple gigabytes. So you have let's say you have a terabyte. The worst case scenario is you're storing 2 megabytes extra if you have literally a file of 1 gigabyte and 1 8K page. Yeah.
Understood.
Yeah.
So all right. So the allocation is on when I create the file, right?
Yes.
Is what you're saying. Okay.
Yeah. It just lets Windows expand your files faster and more efficiently. Yeah. It's again, don't reformat your drives if they're the wrong. Yeah. But if you do it cleanly and you know you're just gonna things, don't put your operating system on a 2 megabyte cluster size because Windows will take up, I don't know, 200 gigs or something. That's all. If you have small, tiny files, do something else. Yeah. But for SQL, files are big. I've never seen small SQL databases. They don't exist anymore. They have been swallowed by data.
Yeah, and you mentioned one of my favorite guarantees, like when I talk to folks about SQL servers, there's one guarantee is that data will continue to grow. It's the one guarantee you have in your data center.
And storage is just barely keeping up. We got lucky with SSDs. If we would still have to manage spinning disks, we would all be fired by now because no, there's just no. I remember before we went to SSDs, I had storage arrays with 2,000 drives just for the performance, and they were half empty because if we filled them up, they got too slow. Yeah, so there was almost no. SSDs were a god's end for storing data, but we're approaching quickly the thing because people started, hey, let's not use HD anymore, let's use 4K videos, and then a year later let's use 8K videos, and then 12K, and let's store all that in SQL databases because it's fun. Yeah.
Right. Well, thank you very much. And everyone, please do leave feedback for Thomas and ourselves. Follow the link there, 8kb.online/feedback. You'll see a link to Thomas' session and a link to the event feedback as well. Please let us know what you liked, what you didn't like. We'll pass it on to the speakers. We'll consume it as well. And it just helps us make this event better. On next is, oh, nope, I'm on the, oh, there we go. Where are we? Is Ed with Advanced OLAP optimization with column store indexes, and that is coming up in just under 4 minutes. So have we got Ed there?
Yes, you do.
We do. How are you doing, Ed? You all right?
Yeah, I'm doing great. Looking forward to this. This will be fun.
Yes.
Just present whatever I want and people expect it, as opposed to like, oh, it was too advanced. Fun. I like this. You can melt brains and it's okay.
Give us the advanced stuff. We want the advanced stuff.
I would love to. This is an opportunity you don't get very often, so I'm going to enjoy it. I don't enjoy it a lot.
I need to know what's in Ed's background.
Oh, there's a lot of things.
Can we talk about that real quick? Do you have time for that?
On this side is a wide variety of Legos, mostly. On this side are some Pokemon. And then further in the background, who the heck knows? There's like the leftovers of SQL Saturday, New Jersey, kind of under the table there, like all the attendee bags I haven't sorted out yet and stuff. I'm sure I'll find some great giveaways for future events from there. And then I don't know what else is going on here. It's people like looking in the background and finding things. It's kind of entertaining.
Nice. And congratulations on SQL Saturday, New Jersey. I heard it was really successful.
Thank you.
Good job.
It was an interesting experience, like not doing one in person for years, and then kind of being the first one in the Northeast. And now there's so many events in the calendar. It's kind of heartening to see a lot going on, both virtually and in person. It was nice. It really was. So I'm glad it went well. Glad I can take a deep breath now, and I'm sure I'll have that mess sorted out within, I don't know, a couple weeks maybe. We'll see.
Awesome. So, okay, you have your moderator. Bob is still online, I imagine.
I am back for more. So
Bob is doing a double shift for us today. Thank you very much, Bob.
All right, extra melty. I love it. Should I go ahead and just share my screen on the first slide and let it sit there until we go, or what do you want?
Yeah, let's do that. So I will stop sharing, and you can grab the screen.
Excellent, excellent. So let's do this. Right now, you should be seeing some PowerPoint.
We've got your first slide up. Yep.
Great. And if I alt tab a whole bunch, now you see some SQL.
Yep. Looking good.
And then PowerPoint. And then SQL. All right, you get the idea now. Great. So I can do that over and over all day, and it'll be funny, but we get the idea. It's like when you step between two states, like you go to the Hoover Dam, and you're like, hey, I can go between Nevada and Arizona, Nevada, Arizona, Nevada. You can just do that over and over until somebody smacks you in the face and says, stop. What are you, a toddler? Maybe. I don't know. You can't work in this line of work without having a little bit of juvenile humor inside of you, right? Well,
absolutely.
Whenever you want me to go, just say go, and I will promise to not slow down. Unless you stop me for Q&A, feel free to jump in whenever I take a short breath, which you'll get a few milliseconds here and there.
So you want me to actively interrupt you when you have pauses? Then?
Sure.
Okay.
Sure. There's no need. You don't have to constantly interrupt, but whenever it seems natural, if there's like an obvious point that's been made and a question related to it, feel free to dig in and stop me for a sec. It'll give me an opportunity to breathe, which I sometimes can go hours without breathing, which can affect my ability to present. So that's cool.
Awesome. So we have one more minute. We'll let everyone go out, come back in, grab their coffees, grab their beers, depending on where they are in the world.
We're not at tears yet, I hope, today. That's an hour from now, perhaps, but we're not crying yet, I hope.
So what we'll do is we will all turn off our cameras and mute ourselves, and then in about 30 seconds, I'll give you an intro, and you are off, ready to go.
Sounds great.
Awesome.
Couldn't be easier, right? All right, awesome. Thank you very much for having me here today at 8KB. This is a wonderful event, an opportunity for us to kind of just dive in as deep as we want into subjects that are fun to us. And today's discussion here is going to be all about column store indexes, a feature that is very often seen as it's an index. I'll just slap one on and my data will be fast and life is good. And then a few months or years later, people are sad and crying and things are broken and not working the way they should. That's especially true of this feature, and it's why I've dedicated 75 minutes to this. I will move quickly. All the slides and demos will be posted later on GitHub. Feel free to download them and play with them, so I need to take notes really fast. And we'll stop a little bit here and there for Q&A on the way. This is really meant to be a dive into the things that most significantly impact column store performance. I can't hit everything. That's a book, which by the way I've written, but we need all day for that. So with that brief intro, this is who I am. I've been doing this for a while. I love speaking, presenting. I've organized many events related to SQL Server. I like SQL Server. I enjoy learning about the platform. There's a lot I know, there's a lot I don't know, and I enjoy sharing the things that I do know with the community. And that's where we are today, is here with the community. Here's our agenda. Very, very quick review, because we're not really here for review, but I'll provide it anyway and go very fast. We'll talk a lot about column store compression, because compression is key to understanding how these things work and how we can make analytic data fast. We can talk about writing, because how you write data can mean it's fast or it's slow. We'll talk about reading. What are the most optimal ways to read from a column store index? We'll talk about a bunch of other options and additional ways to make things fast. And then in 75 minutes, we'll take a very, very deep breath if we haven't passed out yet, and continue with our day on to the next presentation after this. An important note, everything in here uses SQL Server 2019. I do briefly talk about 2022 and the ordered column store feature, but everything here uses 2019. If you have a previous version you're working on, you may not find everything here in there, but I do promise that with every version of SQL Server since column store was introduced, things have gotten better and better, which is a great thing for us. All right, here's a review. Let's go back and talk about what column store indexes are all about. They're about for analytic data, and the challenge you're trying to solve is this. You have a transactional table. This isn't really how the data is stored, but it's a generalization that is useful. So we store row store data. That's your classic clustered index or a heap in one row at a time. So you have a table with 5 columns, and you store row 1, column 1, 2, 3, 4, 5. Row 2, 1, 2, 3, 4, 5, and so on and so forth. This makes it very efficient to do sequential reads and range reads and grab a handful of rows and bring them on back and return them. If you have a system of sales orders, you want all the details for a sale order, it's not that hard, right? I say, oh, I want this one sales order here and the 5 columns associated with it. I grab them, whatever page it's on, I get it, and I'm done. It's fast, efficient, and it's beautiful for transactional workloads. But that is not what this conversation is about today. We're talking about analytic data. Analytic data gets bigger and bigger and bigger, and we rarely say, give me one thing. We say, sum up a thing across, I don't know, millions, billions of rows or something, and that can be potentially very slow. It looks kind of like this. Imagine an endless table like this, where I say, give me the sum of just column 2, and that's it, and I want nothing else. In a row store table, I've got to go out and grab all the pages with all the additional columns surrounding it. And you could create non-clustered indexes and covering indexes and do things to try to make it better. But in general, it's going to involve a lot of scanning, and it's going to be kind of painful. And this isn't really ideal as your table gets bigger and bigger and bigger and bigger. As Tom said earlier, things get bigger, they don't get smaller in the world of data. That would be an anomaly, and it would probably be bad for business to know your data is getting smaller with time. It's not what you want. You want more sales, not less sales. You want more money, not less money, so on and so forth. So column store takes and it organizes the data by column. So you say, all right, we're going to take each column and compress it separately into segments and store them on storage. That way that when I need data, I can grab it column by column, not row by row. Therefore, if I say, hey, give me the sum of the sales for the past year, I can simply grab the 1 column I need, or the 2 columns I need if I have to filter by a certain column, and be done. I could have 10, 20, 50, 100 columns in my table. I wouldn't need to worry about the rest of it. I just grab the column I need, and life is good. This is the challenge we're solving with column store indexes, going from the read everything to the read just what I need and not much more if I can help it. Here's kind of the architecture overview of column store indexes. You take a big table with tens of millions of rows, hundreds of millions of rows, billions of rows, whatever, and you organize it into row groups. A row group is up to 2 to the 20th rows per row group. I have the exact number on the slide. It's about 1 million rows. We'll call it 1 million for argument's sake. This is great. And then you just make more and more row groups for however many rows that you have. And then each column is used separately and split into segments. So within each row group, each column is compressed into its own little data structure called a segment. And so your number of segments, which will include up to the 2 to the 20th rows, for 1 column, the number of segments you have will be equal to your number of columns times the number of row groups. In my hypothetical example here, you have 6 columns times 4 row groups, therefore 24 segments. In a real column store index, the wider and deeper table, we could be talking about thousands of segments or more, very, very easily. A nice thing about this is there's metadata that's stored centrally about all of these segments and all these row groups. And that metadata isn't just like statistics for your standard tables that are kind of like an estimate that can fall out of date. The metadata is accurate, and the optimizer will use it to generate really great execution plans, and we'll demonstrate this and talk about this more later. The way we can do this is by eliminating the things we don't need. If you don't query for all the columns, SQL Server won't get them. If you have 6 columns and query for 2, the other 4 are simply ignored. You don't read them out of your storage, you don't read them to the buffer pool, you don't do anything with them, they just sit there, and that's nice. If that metadata can filter out row groups that are not needed because we know that certain data filters don't apply to certain row groups, we can read less row groups. Therefore, for this hypothetical index with 24 segments, I could just read 2 if I filter nicely and only query for 2 columns. Imagine a bigger and bigger and bigger index where you have 1,000 row groups and 50 columns. This is a big deal. This is the difference between reading 50,000 segments and reading 50. But it isn't that simple. The initial release of column store indexes was kind of that simple, but it left out a lot of problems. A big one was, how do you write to a column store index efficiently? Because decompressing a highly compressed structure and then recompressing it constantly is expensive, and it would break your server. It would consume all of your CPU. It would use a lot of compute. It would slow everything down. And the people trying to access your data would do a lot of waiting, which, as we know, nobody likes to wait. I don't like waiting. My kids don't like waiting. Nobody likes waiting. So we don't want to wait. So to facilitate fast writes to the column store index, we need a few additional features to get added to do so. The first is the delta store. The delta store is just an under the covers B tree that if you insert small numbers of rows into the column store index, instead of saying, okay, we'll decompress all the segments that are affected, put the new data in, recalculate all the metadata, then recompress the whole thing again and wait a lot. Instead, the data will get inserted directly into a delta store, which is a B tree. It's just classic old index, nothing fancy, it's a row store. And then it'll sit there. And asynchronously, every so often, SQL Server will push that data into the column store index. You can do it yourself. I'll show you how to do that later. But this is a good thing. You may think, oh, a big pile of heapy data, that's terrible. But it's not terrible. It makes it so you don't have to keep decompressing and recompressing segments. And when you have 1 billion rows in a column store index and 100 rows in a delta store, it's not really a big deal. So this is a good thing to have. We want this, and it's an important way to make these things writable efficiently. On the flip side, how do we get rid of data we don't want? Again, if I delete 1,000 rows across, I don't know, 100 segments, the last thing you want to do, you have to stop the presses, decompress all the segments, remove the data points you don't need, change the metadata, recompress the segments, and plop them all back. Again, lots of waiting, and waiting stinks. No one likes waiting. So to facilitate that, we have a structure called the delete bitmap. So those don't exist normally until you need them. If you delete rows, it will create delete bitmaps, which is really just a 1 and 0 structure that overlays your row groups and says these rows are deleted. When you read from your column store index, it will check the delta store and say, are there any rows in any delta row groups? If there are, it'll include them in your results. It'll then check the delete bitmap and say, do we have any deleted rows? And if there are any, it'll exclude them. The key here is that deletes aren't really deletes. They're soft deletes. And there are ways of dealing with that later. But up front, those rows stick around for a while. It's kind of like fragmentation in a way, as we would talk about it in a row store index. So they're flagged as deleted, they're ignored, but they don't go away until later. And we'll talk about the later. Take my first breath. Review complete. Any questions about the review before we dive into the real material here? All right, hearing nothing, I will keep going until somebody stops me and I breathe again, which sounds great. Column store compression is very important. This really is what makes column store indexes take up less space and ultimately allow you to read lots of data quickly. And knowing how it works will let you architect better storage structures, better column store indexes, better OLAP data access. Each segment contains data for one column, and that's very important because one column, one data type, and one data type means you have very similar data that will compress nicely together. If you throw together data of all different data types, it's hard to compress it all together. How do you compress a string, a date, and an int? And the answer is it's kind of hard. But when all the data in a segment is an int, or a date, or a varchar 30, you can do some work on that and make it really small. Every segment is compressed separately with its own compression methodology. Therefore, we can save a lot of space here. One key about compression is that data that is closer to other data by date and time typically compresses better, and we'll demonstrate that later on. That means if you sort your data by a time dimension or a relevant dimension that you filter your data by frequently, and we'll talk about data order later as well, you'll get better compression. There's many ways to improve compression in column store indexes. We're going to kind of break this down into 3 rough steps on how column store indexes compress segments. The first step is encoding. The goal of encoding is to do some switcherooing and adjust how your data is formatted to make it take up less space. The most common encoding methods and the ones that are exposed to you directly via the views in SQL Server for column store indexes are dictionary encoding and value encoding. We'll demo all this shortly. Dictionary encoding is basically making a hash table, so you can then do lookups later and not have to store the same values over and over. And value encoding is using math to shrink the size of your storage. As expected, these are lossless algorithms. If you use them, you don't lose any data, but it's intended to reduce the footprint and also make it easier to compress further down the line. We have some dynamic management views that tell us all about them, and we'll demo them shortly. Dictionary encoding is essentially taking values that repeat often, creating a dictionary, which is basically a hash table, and then putting each value in the hash table, and then having your data, the segment itself, reference the dictionary. This is a way of taking repeated values and replacing with small indexes. For example, if you had, let's say, a segment that had 100 values and then there were strings, maybe varchar 50s, you can take each of those 100 values, put them in a dictionary, give them an index from 0 to 99, and then reference them. And then now your data is no longer a million strings, it's a million itty bitty inty kind of things, which compress nicely. There are a few caveats to dictionaries. Dictionaries are limited to 16 megs in size. This is very important. If you have dictionaries that get very, very large, then they will split. And when a dictionary splits, your row groups that use the dictionaries will split as well. The reason for this is that a single row group can only have a single dictionary per segment. You can't have multiple dictionaries per segment. You have one primary and potentially one secondary, but you can't have like 10 different dictionaries. So if you have a segment and you have a dictionary dedicated to it and it fills up, it's going to split. And when it splits, your row group splits. Instead of having a row group with 1,000,000 rows, you now have a row group with 500,000 rows or less. The things that generally cause this will be columns that have high cardinality and that are wide, some combination of many, many unique values and lots of width. And usually SQL Server, when deciding whether or not to use dictionary encoding, will look at this first and say, is this efficient or is it gonna kind of stink? And if it thinks it's gonna stink, it won't use it, but it can't always catch that. Typically, the strings are the ones that benefit the most from dictionary encoding, but numerics can use it as well. Though typically they'll prefer to use value, and it could even use both if needed. Only compressed row groups use encoding methods like value and dictionary encoding. The delta row groups, the delta store, no. They don't use any kind of compression at all like this. They're not meant to be heavily compressed. They're meant to be written to frequently and read from frequently, and therefore we don't want to compress the heck out of them. All right. Here's an example of what dictionary encoding looks like. Let's say I have a small set of yummy data, some desserts from a bakery perhaps, and we have some sales data about them. I don't know. Here they are. I got a bunch of values. Here's how big they are in bytes, assuming you have single byte varchar characters and not nvarchar. Total size is 203 bytes for this data. The first step in dictionary encoding would be to create a dictionary. So I'll take each unique value in my data and I'll pop it in the dictionary. And so now we can see that our original data was 203 bytes. The dictionary is one copy of each string value, which consumes about 82 bytes. So there's our dictionary. We have our original data and a dictionary lookup. And notice the index IDs are pretty small. There's only 5 values, and numbers 0 to 4 are not very big, which is good. We want that. And so the last step is we now take our dictionary and cross-reference it as a hash lookup to our original table. And so now our brand new table, our dictionary encoded data, instead of having chocolate chip cookies and baklava, has numbers from 0 to 4. And things that are 0 to 4 can be shrunk down to as little as 3 bits. That's all it takes, right? The number 4 is just, not much. It's 100, done. So we can represent that in a very small format. And therefore, the dictionary encoded data is like 33 bits, and that's it. So we can see how we saved a lot of space here. There's a little bit of upkeep here. It isn't free to have a dictionary. You gotta store the index IDs in the dictionary and so on and so forth. But there's a lot of savings here. This is, pretty much having the size of our data, which is a big deal. Let's jump over to SQL Server finally and look at it. And Wild World Importers here. And just to intro us to some of the DMVs we're looking at here, this one is called sys.column store dictionaries. You get 1 row per dictionary. And do note that dictionaries are not shared across partitions. If you partition your data, and there's a great session earlier on partitioning, each partition will have its own copy of a column store index, essentially. You have one column store index table, but physically it's separated by partition. And so if you have one column store index and 4 partitions, every row group will kind of be separated across the partitions. So you'll have row groups here, row groups here, row groups here, row groups here, and so on. Here's what the data looks like here. It's just a big, long list of dictionaries with a little bit of information about it. We want a little more useful information, so I'm going to join a whole bunch of views together and do a little bit of cleanup here to make sense of it all. So I'm just going to join column store dictionaries to partitions, objects, columns, types for one table. And we'll go ahead and run this. And we can see here all the dictionaries that are defined on this table. We can see the table, the column, the partition number it's located on. We can get some more metadata about partitions if you want on the side to find out the details of it if you want. What type of dictionary is it? Is it global or local? Most will be global, but occasionally SQL Server will create local dictionaries as well for use in single row groups or smaller structures just for specific tasks at hand. But most will be global. The number of entries and the size. I mentioned earlier there's a limit of 16 megs for a dictionary, and we're nowhere near that. We're talking dictionaries here that are 10K at most. In general, this is what you will see. Most tables, column store indexes will have small dictionaries. They can get big, but for the most part, they'll tend to stay pretty small, and that is what you want. If you happen to notice any here that are approaching 10, 15 megs, then you might want to be concerned. Do a little more research into it and find out what's going on. What column is it? What can we do about it? And we do have some advice about that. I can also kind of flip it inside and say for each column, what do we have for it? What's the size of the column, precision, scale? Is there a global dictionary? And if so, what are the entries? Is there a local dictionary? If so, how many entries are in it? And so on and so forth. And there are a few nulls here because some columns will not get dictionary compressed. For example, some identity on a table, some big int identity that just goes up and up and up with unique values is not appropriate for a dictionary. And SQL Server sees that. I have 1 million values and they're all unique. My cardinality is 1 million. I'm not going to dictionary compress it. It's a waste of resources. It'll cost more to maintain than to not use it at all. Are there any more like that? Yeah, here's another key down here. High cardinality, we don't compress it. So just kind of a useful view into the fact that SQL Server provides a lot of transparency into column store indexes and how they function. And that is very useful. One question you may ask is, if I have a very wide column, does normalizing it help? And the answer is, if you have a lot of distinct values and it's getting dictionary compressed and they're kind of wide and your dictionary is getting big, then normalizing a wide column may help. It's the sort of thing you don't really do unless you need to, but it can help. For example, let's say I were to take the description in this table and normalize it. And I make a dimension table, I make a new fact table, I insert some distinct descriptions, I look at it, there's my lookup table, this is a dimension table, not a dictionary. I then go in and plop in my normalized data into this fact table here. I create a clustered column store index on it. I'm not doing any further optimizations yet, we can talk about that later. And then I just run a query here to give me the size of each table. You'll see that it's a little smaller. I went from using 5.66 megs for just the table to 3.76 megs for the one that's normalized. So in this case, normalizing out the big description column was beneficial because now I'm just compressing a bunch of little itty bitty ints here, which is handy. And you may want to separate that description elsewhere, especially if it's a column you don't really rely on very often. You can put it off to the side and not worry about it. Ultimately, column store indexes work best on data warehouse style data. Doesn't have to be perfect, but when it's data warehouse-ish, it performs better. So numbers are great, big, long, nasty strings, not so great. Any questions so far? Or I keep blazing forward.
We just had one question pop up, which is just where can the demo scripts for all this be found?
I will plop them all on GitHub as soon as I am done here shortly afterwards. I promise.
Awesome.
That was an easy question. I love a nice
there you go.
softball. Thanks. All right. The other type of encoding, we have dictionary encoding, which is basically creating a hash table that we then link up with index IDs. We have value encoding. Value encoding is all about math. What can we multiply and add to our numbers to make them smaller? At first glance, it sounds kind of weird. How can I math myself smaller values? But it's actually pretty cool. And because each segment's compressed individually, we can apply different rules to each segment. This one can be value encoded. This one can be dictionary. This could be both. This could be neither. And that makes sure that SQL Server can pick the right compression algorithms for each one. And this can be applied to dates as well, because dates can be represented by numeric. Here's an example of value encoding and how it looks. And so far, I haven't said anything meaningful. Here's how it'll look. Imagine I have a table, a segment with a bunch of values in it, and they all look like this. I see they're all divisible by 10. And I can see my size in bits. I have 108 bits of data over there because they're kind of chunky. 950,000 takes up 20 bits. 8,000 takes up 14 bits. Imagine for a moment, I divided all those values by 10. I can do that. All I guys remember the fact that I divided by 10, multiply by 10 to the negative first, and my values got smaller. And now my minimum size in bits has also gotten smaller. Each value has gotten smaller by at least a few bits, which now means that my overall size of my data went from 108 bits to 76, or savings about 25%, which is quite meaningful. So I just took a bunch of numbers here and shrunk them, and I got 25% savings just like that. That's pretty cool. And I can also do it via additive properties too. So you can multiply by -10 there to shrink your number down, or I can also subtract a number, pick a common base and subtract it. Let's say I subtract 30. 30 goes to 0, 100 goes to 70, 120 goes to 90, and you can see the numbers shrink and the size in bits also shrinks. Now this didn't get me quite as much back here. I only saved 7 bits. So given the choice, dividing by 10 makes a lot more sense, and SQL Server may do one, the other, or both, depending on what it thinks will be most efficient. This is all just playing math games here to save space. And it works very efficiently. Here's a very interesting use for the additive property, though, an identity column. Identity columns stink for dictionary encoding. We'll never use dictionary encoding for an identity column. But imagine this. I'm up here at 1.5 billion on my identity 11, and I have 1.5 billion, and they keep going up. What can I do? And they're 32 bits. That's kind of big. 320 bits for 10 values. What can I do about that to make it smaller? And the answer is subtract 1.5 billion from every value. And so now I go from these big chunky 32-bit numbers down to small values. My numbers are now 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 instead of 1.5 billion, 1.5 billion and 1. And my size in bits goes from 320 bits, or 32 bits per number, down to anywhere from 1 to 4 bits per number, more if I keep counting up, but only 46 bits. So for a big identity column, you'll see that value encoding is going to frequently be used because it saves gobs and gobs of space. This compresses nicely. You wouldn't have thought a non-repeating number would compress nicely, but here's how it works. And because each row group has only 1 million rows, you'll see this very often based differently per segment. So how does that look in SQL Server? We'll go back to our metadata over here, and I have some more lookups here to kind of make sense of it for us so we don't have to kind of figure out what numbers mean and types mean and all that. There's 2 columns called base ID and magnitude ID, and they provide an additive base and a multiplicative magnitude that tells what to subtract or divide by. And I can look through my data here and see lots of value-based encoded columns. -1 means it's not used. That's how they did it. And so you can see here a variety of things. For example, here is order key. This is clearly an identity of some sort, and you can see that value encoding is using an additive base and subtracting big numbers based on the numbers of the IDs per segment within each row group. And the numbers go up and down depending on what's there. Similarly, we can go down a little bit here and see there's one column here that divides by 100, last cost priced. First look, I see a decimal, 18.2 dividing by 100, I think money, right? And money is a great candidate for that sort of value encoding. I can go and just say, hey, show me the data in this column. And yeah, I see money. I see dollars and no cents. So dividing all those values by 100, and maybe it's something else, but in this case it is money. Dividing it all by 100 will shrink our values down and make them compress more nicely. So that is the first step to column store compression. Step 2 is something completely different. Is there a question, by the way?
We have one question here that just popped in. It's kind of in depth, so I'll try, and this might be a better one to answer later, but I'll read it off to you. You can see.
Sure.
In my current project, we use session context inside the RLS function. Session context is inhibiting parallelism, causing a huge impact performance on clustered column store indexes. The SQL team confirmed this issue in SQL 19 as per below in recent docs, but context info is working fine. If I want to replace session context with context info, are there any gotchas?
It sounds like I'm being the Microsoft support team. That's a very impressive question.
It is.
It is out of scope for this, but feel free to contact me later. I'll have my info at the end of the session. Feel free to contact me. I actually would love to chat about that, but now it would take too much time to really dig into it. But thank you for the question. I appreciate it. That's a chunky question, chunkier than some of the tables I'm working with here, but I do appreciate it. Thank you. So we talked about encoding. Value and dictionary encoding are the primary ways we encode our data. Now I'll talk about optimization. This is important. A column store index has no predefined order at all. Even in 2022 with the order feature that I'll talk about later, there's no predefined order. The data in the column store index is inserted in whatever order you happen to insert it in, and it sits there forever like that or until you do something about it. Because of that, the row order within a row group does not matter at all. And therefore, SQL Server can reorder the rows within a row group however it wants to. This is kind of an expensive process. So there's a couple catches here, a couple gotchas, but it makes compression much more efficient. The term for what SQL Server does is VertiPack optimization. That is the name of the process SQL Server uses to optimize data. And don't let this confuse with like query optimization. This is its own special thing. And the purpose of optimization is to prepare your data to save more space later. It doesn't actually save you any space now, but it allows you to save more space later. So here's an example of what optimizing data looks like. So here's our dictionary encoded data from before. I had a whole bunch of desserts and I went in and I encoded them into numbers. So I don't have big long strings anymore. I have numbers 0, 1, 2, 3, 4, 2, 2, 4, 2, 0, 0, so on and so forth, 33 bits of data. Optimizing it means I'm simply going to reorder the values in order, just basically do an order by and done for the row group, not by segment, but by row group. SQL Server is going to determine which order makes the most sense for a row group and use that. But what this means is that I now go to having a scenario where my data is now 0, 0, 0, 1, 2, 2, 2, 2, 3, 4, 4. The data hasn't shrunk at all, but it's now ordered in a way that will make it better to compress later. Because when you're compressing, you want lots of repeated byte patterns together. And that's kind of the next step of compression after optimization. This is a very important step. And when you don't have optimized segments and row groups, you'll find that things don't compress as well and they take up more space. So let's demo really quick how to see this. Once again, our views tell us more information that can be handy. The view DMDB column store row group physical stats will tell us whether or not VertiPack optimization has been applied to a row group. I can go ahead and just peek at all my row groups and see what I get going on in here. And I see lots and lots of row groups. And most are optimized. I see one set of row groups here, one table are not optimized. And realistically, they're going to be a little larger because they're not optimized. And I may or may not care if it's small, if it isn't a big table, whatever, but you might care. If you have a giant table, like a terabyte table, and you don't have optimization across most of it, it's going to probably take up a lot more space. And that's not what you want because taking up more space makes everything slower. Keep in mind that just like pages and page compression, rows and row compression, and so on, when data is compressed in a column store index, it remains compressed in storage, remains compressed in memory, and is not decompressed until required by the process of the engine. Therefore, you save space everywhere, memory, disk everywhere. Cool. So this one's not optimized. That's kind of weird. Let's make a new table, same table with optimized data, and go ahead and insert a little bit of data into it, create a clustered column store index on it, and then go on back and look at these tables and compare them. And what I see now is my sale table actually did have one VertiPack optimized row group and then 3 that were not. And then I have the new one where all of them are optimized. And if I were to compare back and forth, it's kind of hard to compare here. We would actually, if you added them up, see that I gained a little bit of space here. I made it a little more efficient. Now, in this case, it didn't get a lot more efficient, but it got a little more efficient. And to me, that's good. If you're talking about terabytes and petabytes of data, a little bit is great. Even 5% can be a significant amount of savings. More often than not, you'll see more savings than this. It depends, right? It depends on the table, but savings is good, and VertiPack optimization is generally easy to get. So if you can get it, why not? There are some caveats, though. It isn't free. There's 2 scenarios where VertiPack optimization is not going to be used. One is if you have a non-clustered row store index on your clustered column store and you trickle in data from the Delta store, it's not going to get VertiPack optimized because there's simply too much going on at one time to manage. You've got to have that linking between the non-cluster, which is ordered, and the row groups that are not ordered. And so when that row group is created, it will vertipack optimize, but then for all the data inserted in afterwards in the delta store will not. And so you'll see zeros there where it's been optimized, and it'll generally be larger. And there's ways to deal with that. You can drop non-clusters, you can do rebuilds, a lot of ways around that, and it may not be a big deal to you necessarily. You could have partitioning and clean up your old partitions. You can do partition swaps. You may or may not need to clean this up, but it's good to be aware of the fact that if it's not optimized, it's probably taking up more space, and you might want to do some maintenance to clean that up and shrink it down. The beautiful thing about this is once row groups are optimized, they will remain optimized. The data will keep in the same order until you come along and hit it with a hammer. So unless you rebuild your index or reorder it or create a new table, it's going to keep the same order. And so you don't have to worry about anything changing in terms of optimization. So a little bit of planning can make things compress better later. It's not something I would freak out about. If you have a table with 5,000 row groups and 5 aren't optimized, I'm not sure if I would freak out. But if the whole thing wasn't optimized, you might want to look and do some maintenance to clean it up. Our last step here in compression is compression. What? The last step is to actually use traditional compression algorithms. When you think of compression kind of just casually, you think of taking repeating byte patterns and squishing them on together using algorithms. And that's what happens in this last step here. And it is very important. There's 2 different compression algorithms used by SQL Server. Standard column store uses xvelocity. Column store archive uses express. If you want to learn more about them, there's white papers that you can read, and probably want a lot of coffee to go along with that. But there is some cool, interesting stuff in there if you're curious. Both of them will always use at least bit packing and run length encoding no matter what against your compressed segments. Other algorithms may or may not be used depending on the situation. That's what SQL Server decides when it's doing this work. But at least these 2 will go over because they're always used and therefore they're interesting. The first one is simple, and I kind of inadvertently demoed it already, but we'll talk about it again. That's bit packing. Bit packing says you store your data in fixed width data types. Int is 4 bytes, big int is 8, small int, tiny int, so on and so forth, all are stored in fixed width things. If I have a 4-bit int and I store the number 5 in it, it takes up 4 bytes. Even though the number 5 is kind of itty bitty, it takes up 4 bytes. What bit packing says is I'm going to shrink down the size of my data stored here to only what I need to store the number. Therefore, the number 30 in an int would normally take up 4 bytes, 32 bits, but I only really need 6 bits to display the number 30 and represent it mathematically in a meaningful fashion. Therefore, I will only use 6 bits. So essentially, bit packing shaves off all the unneeded bits and makes your data smaller. In this example right here, a bunch of numbers from earlier, we went from 288 bits down to 108. That's pretty big. I didn't really do much here, and I shrunk the data by a pretty big margin. So that's pretty cool. Run length encoding is what takes advantage of vertipack optimization. So run length encoding says I've got a mishmash of numbers from earlier. I optimized them, which means I sort them in a meaningful fashion. Now that I've sorted them, though, I don't have to repeat them over and over and over. If a number is repeated over and over, I can really represent it logically as a value and then an index to indicate how many times it repeats. For example, if the number 65,000 was repeated 1,000 times in a segment, I don't have to repeat it over and over 1,000 times. I can simply say, here's the number 65,000. It's going to repeat 1,000 times. You know what you're doing, SQL Server, compress it, and you're done. And so a little bit of shorthand logically allows you to encode it. Now, here it doesn't look very impressive. I shrunk down 10 values into 5 representations. But when you get to 1 million rows, you get a lot more bang for your buck, especially for columns that repeat a lot. This is really where repetitive columns compress nicely. Statuses and common dollar values, account IDs, things that repeat over and over and over benefit heavily from run length encoding. All right. So all this discussion of compression is very important because everything else that happens from here on out depends upon this. And we can improve the quality of our column store indexes, the speed at which we read and write our data, knowing how this compression works. This isn't all the gritty, nitty-gritty detail, but it's enough to know what we're doing and use the dynamic management views provided by Microsoft to get out meaningful, valuable data about our index and our data. All right. Now we're going to switch over to talking about writes. Very often, everyone talks about how fast you can read data from a column store index, but realistically, you care about write speeds too, especially if you do very large data loads. If you load in millions of rows, tens of millions, hundreds of millions of rows a day, you want that to be fast Faster is better. Writes are expensive. Reads can be made cheap, but writes are expensive. Go back to Thomas's presentation on storage. We want to minimize as much as possible how much we're going to smash our storage infrastructure, regardless of whether it's in the cloud, whether it's directly attached in a data center somewhere, wherever it is. You want to smash it as minimally as possible. So here's how SQL Server does it. We have a beautiful special case here. In every other case in SQL Server, when you want to bulk insert data, in other words, minimally log it, you have to do something special like BCP or the bulk logged recovery model. For column store indexes, this is automatic though. If you insert 102,400 rows or more in a single insert operation, SQL Server will revert to a minimally logged bulk insert model where it will insert all those rows in one chunk at one time and do it as a single operation, and it'll be minimally logged, which means that your transaction log will be smaller for this operation. It means your transaction log backups will be smaller. It'll mean your insert is faster. And that's a really good thing. This is automatic. You don't have to do anything. It's very important to mention this a few times. You don't have to do anything special. There's no special keywords or query hints. It just happens. But if you insert less than 102,400 rows at once, it'll use the Delta store. And now you're plopping row after row after row fully logged into Delta row groups, which are basically B-tree heapy things. And it's going to take your time and not be fast. So what happens if you insert more than 102,400 rows? SQL Server will do its best to do the most bulk inserting it can until it's done. So at first, it'll say, all right, for every 2 to the 20th rows, bulk insert those and make row groups out of them. Done. Whatever's left over, the excess of 102,400, bulk insert that too. And then whatever's left over, use the Delta store and be done. An important key here is that it's doing its best to bulk insert as much as it can and make our lives easier. Updates. When we think of updates, we think update being a delete plus an insert. You delete some data, you insert data. But SQL Server, due to the nature of how updates work and having to be ACID and having to conform to all the properties that make transactions atomic, durable, isolated, and consistent, doesn't bulk insert. There's a lot of things updates can't do. In fact, you don't want to ever really update in the columns or indexes if you can help it. But if you do an update of 1 million rows, you're going to delete 1 million rows and then insert 1 million rows into your Delta row groups. And it will be slow as all heck. It'll be fully logged. That's a very, very important point. Avoid updates. Updates do not do what you want them to do. It'll be slow. It'll be very, very slow. And the more rows you update, the slower it gets, the more painful. I've seen servers be brought to their knees by large updates on large column store indexes. So you really just never want to do them. Let's demo how this looks. We can read the log and learn about this. I'm going to create a table and I'll talk about it afterwards. I'm going to create a table, do a bunch of stuff. Let's do this all first and then we'll chat about it. I'm going to create a table here called fact sale transactional. Just a PK clustered classic row store index, nothing fancy, page compression. I'm going to insert into it 102,400 rows, magic number. And then I'm going to go into FNDB log and I'm going to pull out the size of this transaction. How much did it take for me to run this transaction? How big was it? This is important because this is going to tell you about how much data is going to get pushed to your T-log files and how painful this is going to be on the right side overall. Not just your T-log files, but then your T-log backups, and that carries on forever. So just keep in mind that when you create a large transaction, it's going to carry through and carry through and carry through, and it's going to show up in your backup records and things like that. So it'll be big. I'm tired of waiting here. It's taking its time, but here's the number that it will be, 489,960 bytes. So about 500K of T-log is what was created by this insert of 102,400 rows into a clustered PK table that I created. All right, what if I now go ahead and create a column store index table and do the exact same thing again? I'm going to go ahead and run this. You can just see I'm creating a clustered column store, nothing fancy. It's a test table. I'm inserting the same 102,400 rows, nothing fancy. Do I feel like waiting very long? No, it took 1 second earlier. It's taking a lot longer now. I have no idea why. But the number is going to be 118,612. And so by simply using the column store index and the bulk insert, my transaction size went down from 500K to about 118K. And that is a big savings. I see there's a question there. I'll grab it soon. Our last example here is going to be, what if I create a table that is a column store index, and I insert, let's just run this first, see if it'll actually finish on me. Let's say I create a table. I put a column store index on there, and then I insert 102,399 rows. At first glance, if you didn't really know about how this works, you'd say, oh, it's got one less row, so my transaction size will be a smidgen smaller than it was before, right? But the answer is wrong. What's going to actually happen is you're now reverting to a fully logged insert into the Delta store. So while we're waiting for this, it is going ahead, inserting the rows one at a time into the Delta store, logging the whole thing, all the details of each row. And that's really expensive. And if what I did before is going to take a long time, this is going to take even longer. So I'm going to stop. My system clear is having a busy day, and that's fine. But the amount it took to do that was about 1 megabyte of log. I wasn't inserting a lot of data here, but it took a meg because now I am fully logging into this uncompressed heapy thing, and that's unfortunate. We can also check the structure of our table by going out to our column store row groups dynamic management view, and feel free to steal whatever views, whatever queries you want from this later. Download my scripts, steal my scripts, use them. Lots of cool stuff here that takes you into the DMVs that describe column store indexes. So if I look at it, what I'm going to see now is that I have no compressed row groups here. Everything's open, which means I have a delta row group here of 102,299 rows. And so I don't really even have a compressed row group yet. This is all uncompressed data sitting in delta row groups. Awesome. That's not very efficient. On a bigger index with more rows, this could be more painful. I can do a reorg and do compress all row groups and then go back and check and see. And by all I'm doing here is doing a reorg, and it's forcing the contents of the delta store out. When I do that, I can see I now have 2 tombstone rows, which is not Halloween related. All this means is they're being flagged for cleanup by SQL Server. They're not active. They're going to go flying away later and be gone. What is active is this, though. I see here now that I have a compressed row group, 102,299 rows, and no deleted rows done. So I've compressed my data now, and the previous delta store structure is going to go away. If I run one more alter index, I can make it go away. Reorg, and now it's gone. And I can see a beautiful clean row group with 102,399 rows in it. So all isn't lost, but it still took a lot of effort to write those rows into here. I'm going to stop at this point and take a few questions. I see some questions coming in. What do we have?
Yeah, we got a couple here. So first one says, for a few of our queries, filter push down is not happening on clustered column store indexes. Could you expand on what scenarios cause this issue?
That is a great question. I would probably want to get a little more detail on that. It would really depend on filter predicates and the structure of the table. You may not get that if you're inserting into the, we're talking about a read or a write here. If we're talking about a write operation that has a read involved, it could be how we're inserting going to the Delta store. If we're talking about reads, that probably needs more information. I would probably want to take that outside of this conversation here, because this may not be a column store index question. It may simply be a aggregate push down question. So feel free to chat with me afterwards a little bit more on that one. I don't want to speculate right now. I kind of want to get a little more information and talk about it and think about it.
Okay, next question here. Can you use tab lock to get a minimally logged smaller insert? Will fully logged inserts use parallelism? So I guess that's 2 questions in one there.
Great question. So when you insert into your column store index, the bulk insert is automatic. You can't influence it with any tab locks or anything like that. You can use like max stop 1 if you really want to remove parallelism. It probably shouldn't matter for a well-structured data load process, but you can't really change how the bulk load process works. This is not like other minimally logged processes where you can kind of cheat and get what you want. This is a scenario where it's going to either happen automatically or it's not going to happen, but there are no query hints that will force this to happen. So if I insert 1,000 rows, I can't force a bulk load. It will always go to the Delta store. That is how it works.
Okay. And one more question. I'm actually going to abuse my position as moderator here to ask my own question. For bulk inserting, does the table have to be empty? Or if I have a table that already contains rows and I insert more than the number, will it be minimally logged as well?
Great question. My demo had an empty table. It doesn't matter.
Okay.
It will always bulk insert into any column store index, regardless of the contents. Assuming you're inserting at least 102,400 rows, it will revert to a bulk insert, minimally logged. If you do less than that, it goes to Delta store, and it doesn't matter how big your table is.
Awesome. I did not know that. Okay, cool. That is all the questions I see here at the moment.
Awesome. Here's a little bit of guidance on inserts to try to help us through this. So I said a whole lot of stuff about how bulk insert works. How can we take that information into practice and be useful? Since the theory is great, how do we put it into practice? One big thing that happens sometimes in the world of data loads is trickle inserts. I want to insert 1,000,000 rows, and I'm grabbing them from, I don't know, 1,000 or 100 places. So I'll insert small batches, one after another, after another, after another, after another. And if I do that, they're all going to go to the Delta store, and it will get processed behind the scenes. SQL Server will asynchronously use the tuple mover, which is an internal process, take those rows out of the Delta store and asynchronously push them over to the compressed row groups. So they will get where they have to go eventually, but you have to pay the price on insert because you have bigger transactions. If you want to speed up your inserts, one easy thing you can do is stage your data first and then insert it all at once. In the world of transactional tables, we often are encouraged to batch your inserts because you insert 1 billion rows at once in a transactional table, you're going to sit all day and wait for it. And while you're waiting, your table is locked. In the analytic world, this is very different. Creating compressed row groups through a bulk insert is very fast. So a large batch is preferable. There's no real benefit to inserting a batch above 2 to the 20th rows. 2 to the 20th is the size of a row group. If you insert that exact amount, you'll get a row group, and that'll be cool, minimally logged. But you can go bigger if you want. Really, the limitation will be wherever you're reading from and the expense of the read. But SQL Server loves to insert large batches into column store indexes. So test bigger and bigger batches, because in this case, bigger is better in general. If your read performance is good, though, you don't have to really tweak something if it isn't broken. If you have a data load process in a column store index and your data loads are acceptably fast and you're happy, and your reads are acceptably fast and you're happy, you don't have to play with it. You can be an optimizer and make it better, but you don't have to do anything. One thing you can do, if you find a lot of data sitting in Delta row groups all over your index, if you have many, many row groups, many partitions, you may have a lot of Delta row groups, and it's possible you may end up reading a lot of them. It can be kind of slow. If that happens, you can test running a reorg and with the compress all row groups syntax and pushing everything into the column store index like I demoed before. And that may make your reads a little faster. But again, test the before and after and verify it really did make things faster and it wasn't just solar flares or something like that, or your imagination playing tricks on you, or somebody launched their Minecraft server at the exact moment that you were hitting F5. Who knows what happened, but whatever it was, we don't want to get confused or tricked up by that and think that better performance happened when maybe it didn't. You want to show consistent, better performance, and if so, make changes. How about in the delete and update side? In general, this is where fragmentation comes from in the column store world, is deletes, updates, and unordered inserts. Those are really where it comes from. The number one rule here is do not update a column store index. This really is a don't do it thing, and I mean it, like never do it. If you have to do an update for any reason, restructure it as a delete and an insert. It sounds silly, but I promise you it will perform faster, guaranteed, and you'll benefit from bulk inserts on your insert side of things. The real reason for this is that to maintain ACID, atomic, consistent, isolated, and durable, on your crazy transaction with all your inserts and deletes happening simultaneously in the background through your update, it's painful. So let's avoid the pain. Just don't use update operations. There's many requests out to Microsoft to speed up updates, but as of right now, they're not fast. So use a delete, followed by an insert, and your data load will be faster. If you migrate a table from row store to column store, be sure to check for updates and make sure that if there are any out there to fix them, and make sure you're inserting big batches and not updating. Keep in mind your deletes are soft deletes. When you delete rows, they don't actually get deleted forever. They get soft deleted. The delete bitmap will be created, taking up a little bit of space, and it will flag things as deleted. And so when you read from it, it will then ignore those rows, which is great, but you don't really want that. Ultimately, if you need to delete data, that's fine, but try to avoid it if you can. If you need to do it, there are ways we can deal with it. And of course, if you're deleting off of the tail end of your table, let's say you have a column store index that covers 5 years of data, and everything older than 5 years gets pushed somewhere else, then deleting off that tail is not going to really impact performance much. But just keep in mind, these are soft deletes. But newer versions of SQL Server do have some great ways to fix that, and we'll talk about it shortly. And they're called self-merge and merge. And those allow us to combine undersized row groups and get rid of deleted rows. And that's a really wonderful feature that was not around back in the beginning, but we really do appreciate it now. What's a merge and a self-merge? Merge is an automatic background process when you run a reorg. SQL Server will say, hey, you're doing a reorganize, which by the way, a reorg is online for column store indexes. That's really important. So when you run reorgs, they're online. You can just do them and things keep working and life is good. Here's a hypothetical index here with 5 row groups, 200K, 300K, 900K, 800K, and 1 million, and then 2 of them have some deleted rows. If I were to run a reorg right now in it, I would find the 200K and the 300K would get combined into 500K, just like that. The 900K would get shrunk down to 650K. Those deleted rows would get taken out, save a little bit of space. The next one would have 400K deleted rows taken out because they got deleted. They're gone now. So the merge was up top. The 2 deleted rows sets getting removed or self-merge, and the 1 million row group gets left alone. And then the next thing here that will happen will be that the 500K row and the 400K row groups will get combined into a 900K row group. So we'll see 5 row groups become 4, become 3. And this is a nice feature. This means that a reorg can meaningfully shrink the size of your table and make it more efficient. It will not reorder the rows in your table, but it will combine row groups as needed. All right, so that's really how the writes work. And I'm going to kind of take a break from the writes now. Knowing how to write data efficiently is very important. Knowing how to read it is also very important. And I would say that one of the most important things to understand about column store indexes is segment and row group elimination. Now, I know that in the documentation, it's all called segment elimination. I refer to it as 2 things to kind of help separate between 2 phenomenons here. The first phenomenon that occurs with the column store index is that because everything's compressed separately into their own segments, I don't need to have them all to do my query. If I have a 20 column table and I query for 3 columns, the 17 columns that were not requested can be ignored. So all the segments and all the row groups for those 17 columns get ignored. And that's segment elimination. That's a very big deal. It means that when you leave out columns, they're truly and completely ignored. It's not like in the row store world where you'll just return less data and it'll be a little faster to like your application. They're really not being read from storage, and that's huge. Do note though, if you add extra filters into your queries, any columns you filter by, group by, order by, having, whatever, will all have to be requested to complete your query. So sometimes in the transactional world, you might throw a few extra filters in there to try to speed up your queries, maybe use a few extra non-clustered indexes to speed up your reads. In the column store world, unneeded filters will make your queries slower because you don't have to read the segments that contain the filter columns to then process the filter and return your rows. So to kind of keep that in mind, that the more columns you ask for, the more segments you request, the slower your query gets. At the end of the day, a read of your column store index is a read of segments. And the number of segments you read will determine how fast or slow your query is. If you read 1,000 segments, it'll be this fast. If you read 1 million segments, it'll be this slow. The flip side is row group elimination, which is also called segment elimination in the docs, but I'm going to separate it by calling it row group elimination because you're eliminating row groups. There's no order in column store indexes, but you can put an order on your data. You can insert your data in order and apply an order. And by ordering your data, all that metadata in the column store row groups view becomes valid and useful. There's a min data ID and a max data ID that tell you for each row group, what are the min and max data IDs for each segment within there. And that's really valuable segment metadata. It tells us that SQL Server can ignore any row groups where a filter does not match what those min and max IDs are. This is the #1 way to make your reads against a column store index fast. Nothing else will impact performance more than this. Compression is great, Vertipack is great, but this is #1. Ordering your data will make your reads faster. It'll allow you to eliminate lots and lots of row groups, making your queries faster. And it'll even save on storage because typically data from a similar time period compresses nicer. And time tends to be the dimension you order by, that you can order by other ones too. But similar data compresses better than dissimilar data. For example, if I have data ordered by a date, data from March 1st of 2022 will compress better with data from March 3rd than from May 1st of 2002 or something. This is a really, really important piece of how SQL Server works. So I've already created these tables for us because it would take a long time to create them. I'm putting like 23 million rows into an index. So here is a clustered column store index with no order. Here is just an idea of how big the data is. So 23 million rows spanning 2013 to 2016. I can go in here and look at the column store segments, DMV, and see what is going on in here. for every segment for this one column, order date key, which is my most important column. When I run a query against the state, I want to filter by order date key. Critically important. It's a date. That's all that matters to me. Is I want my quarterly results, my daily results, my weekly results. It's all that matters to me. And I have, what, 4 or 5 years of data here. Note, the min data and max data ID for every single segment up until the end are the same. That means that if I say, hey, give me the data for one date, what's going to happen, it's going to say, well, I don't really know which segment has it. It could be any of them because they all have the entire range of all the dates. So I'm going to read them all. I can test this. I'm going to run an analytic query against this table to get 1 month of data. I'm going to sum a single column for 1 month. Classic analytic query, right? Give me a sum. I run it. I get my result back fast enough. And I'm actually going to turn on the execution plan here too, just to show one thing. So in an execution plan for a column store index, you're always going to see column store index scan. You can hover, you can right click and go to properties to get more details. But in terms of how SQL Server functions, there is no such thing as a seek against a column store index. You're simply scanning segments. That's how it works. So do not feel afraid of this or bothered by this. This is how every single read against a column store index is going to look. It's going to be a column store index scan, and that's normal. It does not mean you're doing a table scan. It just means you're scanning segments. If I have statistics IO on, I get a little bit of bonus information here. First off, my IO tells me that I have like 12,000 something lob logical reads. These are all lobs, they're segments. They're not, classic rows and tables and cluster indexes and B trees. So they're lobs, 12,000-ish reads. I have this additional piece of information here that is awesome. It tells me on my clustered column store index, I read 24 segments and skipped 0. This applies to non-clusters too. I read 24, skipped 0. That means that I read all of my row groups and skipped 0, which means I read everything, but I only asked for 1 month of data. What can I do about this? And the answer is order my data. And there's many ways to do this. Data tends to naturally order by time. If you insert by time, if I go into my index every single day and I insert all the data for August 1st and all the data for August 2nd and so on and so forth, your data will naturally order beautifully. But you can force it. I'm going to create a new table. Again, it's already done because I don't have time for this right now. And I same exact table as before. I'm going to order it. I'm going to start by putting a clustered row store index on it, on the order date key. I'm going to insert a big old honking chunk of data. I'm going to then add a clustered column store index on here. And notice that I use max stop 1. This is valuable because whereas parallelism is a great thing to have when you read a column store index, if you use parallelism on the write operation, you're going to separate your data into separate streams that are each individually ordered maybe, but insert them like shuffling a deck of cards. When I shuffle my deck of cards, it won't be ordered anymore. And that's bad. So there's a benefit when you're creating a cluster column store or any column store index to max stop 1 it to ensure your data order is retained from what you had before. If I run the exact same query as earlier, get my exact same result, exact same execution plan, but I see here that I read 1 segment and skipped 22. And I can also note that my reads went down to next to nothing. And the reason is I read 1 segment. I didn't read all of them, I read 1. That's a big deal. And and you notice there's less segments and things are smaller here. It compressed better as well. Ordered data compresses better. This date column compressed better. Any data that is date dependent also compressed better throughout the whole process. Vertipack optimization was more effective. Run length compression was more effective. Everything was more effective on that data. And now if I look into my metadata again, I can see that min and max data IDs are not the same anymore. They increment slowly. And what this tells me is that if I go in and look for a narrow set of values, or maybe a broad set of values, give me a whole year, I won't need all the row groups. I will only need the row groups pertaining to the segments that fit this filter here. So having ordered data that matches the criteria of your filters most often used in your table, which will often be a date dimension or a time dimension of some sort, you'll have more efficient reads because I'll skip lots and lots of segments. I can compare my storage size for these tables too. And I can look here and say, wow, these are the same tables, same data, same contents, but the difference is they're ordered, one of them. The unordered one consumes 340 megs. The ordered one consumes 108 megs. It shrunk down to a third of its size. Now, in reality, you may or may not get this level of performance, but you will find that ordered data compresses better. So not only is it faster to read, and smaller and more efficient and better in most ways. But it's even better on the storage side. So this is a huge, huge win. The number one thing you can do to make your reads faster in a column store index is order your data and make sure your filter criteria meet that data order. Now, one caveat here is that you may have heard in 2022, we have a thing called ordered column store index, ordered clustered column store index. It sounds really cool. It's kind of cool. You can actually add the order clause to your index and tell it, hey, order by this column. When you do this, it will not apply to pre-existing row groups. So any data already in your index will not get reordered for you unless you do a rebuild. Some caveats though, there's two caveats to this though. It will order the incoming data for you, which is kind of nice, but it's an offline operation. So when you do it, your affected partitions are going to go offline and wait until you're done. And that's a little painful potentially, unless you have a off hours time where it's acceptable to take your data offline you're inserting to. The second caveat is it uses tempdb to sort data. That means that if you have not a lot of tempdb defined, this could be problematic. If you insert 10 million rows into a clustered column store with an order, it's going to sort 10 million rows for you. You might need a little more tempdb potentially. So my personal recommendation right now is if you can order your data via your data load process, do it. This feature is good. When it becomes online, it'll be better. But as of right now, it's okay. I don't love it though. If you can do it yourself, you're probably better off. But it is a cool feature and I see it becoming an online feature in the future. Again, this is like a 2022 CTP. For all I know, it's going to improve next week. But for right now, this is where it is. Is there a question?
There is. We had one come in and they say that statistics IO output should really state that it's row groups read or skipped and not segments read or skipped, correct?
Yeah, if it was being more accurate and being clearer to you, yes. It is segments though. I will say that like while it's a factor of row groups, if you're reading many columns, you'll find the number of segments there will increase. So it is actually measuring segments, but the limiting factor is row groups. Like what's causing that to happen is row groups. So the unit is correct, the cause is not. And I just use the different nomenclature up front to try to separate between the two phenomenons. One is you read less columns, and one is you filter by ordered data to eliminate row groups.
Cool. All right. That is all the questions at the moment.
Cool.
Oh, wait. Reed just posted one in here
We did
from
just
Slack.
have one
I'm
go into
sorry.
Slack. Sorry.
Yeah. Sorry. So from Slack
Real
to
time.
yeah, inserting into column store page lock versus table lock. Is there any downsides of using page lock?
I typically don't force any particular kind of locking on the column store index. Again, you're inserting data into row groups. There's not going to be a huge impact. You're going to lock anything that's touched by it. I wouldn't use either, honestly. I don't really typically find a reason to. If you have a use case, though, specifically why you use certain kind of locking as you insert into columns index, I'd love to chat about it later. But typically, I've not really pushed that unless there was a very specific use case, and I've really not found any directly on data yet.
Cool.
All right, let's plow forward then. There was a great session earlier on partitioning. Partitioning is a natural fit for column store indexes. If you've gone through the trouble to order your data, you have a beautifully ordered set of data ordered by your date or some other ID that's meaningful that you filter by. Partitioning on that same column will give you the benefit of maintenance, easier maintenance in general. Note that each partition will become its own column store index structure. The metadata is still centralized, but you'll have separate row groups in each partition. So in general, you want a lot of data in each partition, like at least millions, tens of millions of rows or more. If it's going to be less than that, your partitions are too small. Because of this, partition elimination and row group elimination are great friends. You saw earlier that I used segment row group elimination to reduce my segment reads down to 1 from 24. If I had partition data by year, it would have shown segments read like 4 and skipped 3 instead of 24 skip 23. So partitioning reduces the amount of data you have to actually access to figure out what you got to do. So it makes your metadata reads faster, and it also allows for maintenance. So the main reason to do partitioning is maintenance. The partition elimination is nice. You get a little bit of a query and performance benefit, but maintenance is a beautiful thing here. You can partition swap and truncate. You can do index maintenance by partition. You can do archive compression on some and column store on other. We'll talk about archive later a little bit. But the maintenance is really the huge benefit here. So if you have a big table, hundreds of millions, billions of rows, tens of billions of rows, consider partitioning by whatever the column is you want to order your data by, because it will improve performance a little bit and allow for a lot of cool maintenance tasks that will make your life easier in the future. Because granular maintenance is nice. You can touch one partition, leave the rest alone. And that's kind of cool. In addition, you can also note that if you have data that's kind of like write once and then you kind of read only it afterwards, any partition that's old won't get touched again. You can rebuild it and call it a day and it's done data. Here's some general guidance that goes along with the tricks and tips and everything talked about today so far and what's been a lot of information. In general, how big should your table be before you use a column store index? It's very often asked. And the answer is at least millions of rows, tens of millions of rows or more, and growing. If your table has 500,000 rows, 100,000 rows, 50 rows, column store is going to buy you nothing because now you've got to put all your data into one row group and then read all of your data to get it. So you're not going to really benefit a whole lot by doing that. Really, the more rows you have, the better. You really want at least millions of rows per table and at least millions of rows per partition, but more is better. More is always better. Archive compression is a cool feature. It's an additional compression algorithm you can apply using your column store build or rebuild. And when you do it, it'll cost a little more CPU and resources to compress it and read it and decompress it, but it'll take up less space, maybe 10 to 20% less space. Archive compression is great for colder data you're not going to read very often or touch very often. It's expensive to write. You don't want to be writing to it all the time. But if you're not going to touch it again, or if it's data that's saved for posterity, you can archive compress it and make it smaller. Not a bad thing. How about other things, other kinds of indexes? You can put non-clustered row store indexes onto a column store, a clustered column store if you want to. And I try to avoid it in general. I almost always will create a column store index first and see how it performs, and only add a non-clustered row store if I need it later, if the performance and the use cases arise that show that I need to do that. Non-clustered row store requires a very complex mapping under the covers between the rows in your non-clustered and your clustered column store row groups. It's kind of complicated and kind of messy, and it takes a lot of space. If you have 2 dimensions in your column store index that are very, very important for filtering, for aggregating, for things like that, I would highly consider potentially 2 separate column store indexes and maintain both of them side by side, one ordered by date and maybe one ordered by account ID. It sounds a little crazy, but you may actually find that it doesn't cost much more storage, if even, and it'll be faster and easier. Again, test thoroughly, consider whether you need it or not, but I'm very hesitant. You do not want to go trigger happy on non-clustered row store indexes in a clustered column store. If you go trigger happy and put 10, 20, 50 on there, you're going to pay a lot of storage for it, and the benefit's going to be rough. So just be very careful before you begin throwing these on. It may make things seem faster for a moment, but you're going to pay a price in the long run. How about non-clustered column store? This is an interesting option. It really works best in tables that are more read, less write. If the table is highly transactional, tons of deletes, tons of updates, lots of little trickle inserts, it's going to be hard to maintain your column store. But we have the benefit of, with non-clustered column store, you can do it on a limited column list, which is kind of nice. You can put it on 2 or 3 columns as opposed to 100. The key is to really test. How does a covering index perform? How does a non-clustered column store perform, both reads and writes? Make sure it really performs well before you use it. A lot of times people think I just throw a non-clustered column store on there, it'll be fast. Real-time operational analytics, woo! Those are the buzzwords. But make sure it really performs well before you do it. And it may, but just be sure of it. Don't assume it's going to be awesome, because it may or may not. Because again, you're mixing OLAP and OLTP, and you're crossing the streams and mixing stuff that's kind of weird. It may or may not work. The last variation that people talk about sometimes is memory optimized column store index. In general, I avoid it, because under the covers, a clustered column store in memory optimized world is still a row-based memory optimized index with column store stuff shoved on top of it. Because at its core, memory optimized table is meant for OLTP scenarios, lots of contention, lots of writes, lots of locking and deadlocking and latching, stuff like that. You get rid of that with memory optimized tables, but column store is not really meant for that. It's worth testing if you really, really think it's going to be awesome, but it's a niche. It's a totally niche use case. You may use it, but most people will not use it or benefit from it. So if you're going to play with it, play with it, but it may or may not provide you the performance you think it'll provide you. All right, I want to leave a few minutes for questions at the end and kind of slow down here and take a breath, because we're blasting off the speed of light here, and that's fun. Column store indexes, you can set them and forget it, and they might work for a while, but eventually you're going to pay some pain for the setting it and forgetting it. You're going to perform updates and deletes. You're going to do, add some new processes that are touching the data in ways you don't expect. Your data is going to be unordered. Things are going to happen. And eventually it's going to be kind of slow or less efficient than it could be. Everything I talked about today really can be boiled down to those last handful of slides of best practices. How do you keep your column store index lean and fit and running nicely? And the answer is a handful of tips on how you insert your data and how you read your data. But the details of how they work are key to this. We can go into more nitty-gritty detail. I wrote the book on column store indexes if you're curious, and it's like hundreds of pages on this stuff. So we can go on for hours about the nitty-gritty of how this stuff works, but we don't really need to do that at this point. Understanding the basics of how data is stored in column store allows you to make good decisions about how you write to it and how you read it and how you maintain it. And always look out for the one-offs, like you have some major release that updates everything. You have some major one-off, a migration, or moving data from server A to server B. We're going to add always on. Like whenever you make any major architectural changes, just review and make sure it's not going to muck up your column store index, especially if it's big. If you've got 50 billion rows in an index and there's like 20 partitions or something, and it's really big, make sure that whatever changes you do are going to not mess with it at all or change it or make it slower. Because when you use this correctly, when you use column store and effectively, it can really scale to obscenely large sizes and still be fast. And I personally deal with these in production scenarios and I love them. But the ordering is the key. The bulk inserting is key. All these things are key to making them stay fast so that people aren't scratching their heads as to why they don't go fast. So at this point, I'm going to stop, take a deep breath. Here's my info. Feel free to contact me on Twitter and tell me what you think. Ask some questions, get a conversation going over some of the harder questions, the more complicated ones that I just didn't have time for here because I have 75 minutes, not 75 hours. And you don't really want to hear from me for 75 hours anyway. So I'm going to stop and take questions and see what we got.
All right, we have one here in Zoom, and they say, does any background update statistics operation apply to column store indexes? I noticed that for SQL 2016, that the first time querying was very slow, but subsequent querying was very fast, but they didn't analyze that very much.
Stats are very different for column store indexes. Ultimately, what you're really looking at for stats is that metadata that's stored with segments and row groups, and that data is maintained live. It's always accurate. When you compress a segment, the segment metadata is updated, the row groups metadata is updated immediately. It's part of that process. And so you're really worried about that metadata and not stats. You don't have to touch stats for a column store index. Now, if you have row store indexes on top of it, or you have a column store on a row store, you may care about stats, but for a strictly clustered column store, stats don't really matter. And SQL Server is not going to care about, it's going to care about metadata and that speed of the metadata. And if you're reading things for the first time, it'll be slow because you're reading segments from memory, most likely. If I have to read 100 segments from memory, that's going to take time, which does remind me, ensure you have enough memory in your server. If you have, let's say, a column store index takes up 10 terabytes, and you typically have, 50 gigs in RAM at any one time, make sure you have 50 gigs of RAM, or maybe 100 or more available for just this column store index, or else you're going to have segments go in memory, and come out and go in and come out and go in and come out. And the last thing I'll be doing is reading off storage all day. That's slow.
Okay. There is one more question in Slack that you are tagged in, and it is much more specific. So I'm guessing you might want to just answer this one offline.
Sure, I can do that. I'm
they're
not
asking
looking at...
they're asking for general advice and pointing in directions. So you're tagged in that one. You should be able to see it when you log into Slack.
Awesome. I was not peeking at Slack while I was doing that. That level of, back and forth would explode my head. But hopefully everyone else's heads here are melting slightly. I do like melting brains. They're fun. Are there any additional questions from anybody about column store?
Nothing else has
make it
popped up
better
yet. Well, I thought this was excellent. I really enjoyed it, and my brain is a lukewarm jar of mayonnaise at this point.
Nice. We got 2 more sessions, right?
Yeah.
We have 2 more sessions to go. So if everyone's head isn't melted enough, they are going to be melted very shortly. Thank you so much, Ed. Your pace of presenting is, you speak quickly but clearly. It's really, really good. I really enjoyed that session.
Thank you very much. It was fun to be here and just be able to unload column store. I really enjoyed this.
No worries at all. What I'm going to do is I'm going to
session.
Sorry, Anthony. You go.
So we might take you up on that 75-hour session
All right, we can do that sometime if you really want it.
All right, what I'm going to do is I'm going to grab the screen off you, and I'm going to drop my screen in there and just say, as before with all the other sessions, please do leave feedback at 8kb.online/feedback. We've already had some feedback coming, Fred, during the session. I guess some people had to drop out, but the feedback so far has been absolutely fantastic. I will say it.
All right, well, thank you very much. It was awesome. Looking forward to the next session. So I will mute myself and kind of take a step back now, but enjoy your break. I certainly will grab about a bucket of water and breathe, and be back a bit later, right?
Absolutely. Thank you so much.
All right.
Yes.
See you soon.
See you soon. So yes, next we have Taran, Andy, and Aaron looking at availability groups at scale, lesson learned at Stack Overflow. I'm pretty sure everyone here attending this session knows what Stack Overflow is, what it does. So we've got three absolute experts here going to be talking about Stack Overflow setup. Looking forward to this session very, very much. Oh, I can see you there, Andy. How are you doing?
Unmute my mic. Good. How are you?
Absolutely fantastic. Good stuff. Aaron, we got you there as well in your swanky office.
Good afternoon.
And I can see Taran online as well. There we go. Awesome stuff. So yeah, we've got about 13 minutes, folks. So what we're going to do is we're going to give everyone a bit of a breather and let them all relax, get a cup of coffee, or if you're in the Irish time zone and it's 6:15, you can all go get a beer, and we'll be back ever so shortly. Thank you.
Don't tell us when we're allowed to drink, Andrew.
Yeah,
No,
we all have our
very
own
sorry.
schedules.
Well, one of us is actually in a bar right now. All right.
I was not willing to do the session from my office, so I came to the tavern to do my session.
Oh, you are literally in a bar.
I'm in the tavern, what we call the tavern in our house. We don't have a dining room. We have a tavern, but very literally, all my booze is up here and over there, and yeah.
Can we change the session from availability groups to craft cocktails with Andy, Taryn, and Aaron? Right?
Yeah. So
Perfect. That sounds perfect.
I could make a Manhattan while we wait.
That's why I drink.
But can you make a Manhattan for all of us?
I don't think I have quite enough bourbon for that, Ree.
Matt Gordon's here, just saying.
I mean, there's a horse farm right behind me, as you can obviously see. There's a distillery definitely right next to that somewhere. So
Right.
I feel like this is a solvable problem.
I just, shipping times from Louisville to Maine doesn't always totally work out.
Lexington's an hour closer to Maine, so we've got that going for us.
Well, what I hear Andy saying is he's not prepared. Got it. Okay.
Yes, correct. I could probably make a Manhattan for every presenter and moderator and everything, but I don't have enough for the 135 people on here, which is a failure on my part. My apologies.
I actually need to look at my calendar for the rest of the day to see what anybody's level of expectation might be. I'm just kidding. I have to moderate for Kate. So I mean,
so what I hear is the next edition of 8KB is going to be 8KB plus concierge cocktails. Am I understanding that right?
8KB pub edition.
Sign me up.
I was gonna say I don't hear any objections. Is Andrew still here? Andrew still is. Lessons learned for next year, Andrew, pub edition.
Right.
I think he's run down to the pub.
I am
Actually.
totally going to get a beer. Sorry.
I have beer too if you want to stop by here, Andrew.
Just a short flight.
Yeah, I'll just nip over, mate. No worries. See you in a minute.
Well, I mean, you're probably the closest, right, across the pond to each other.
I definitely am.
Anybody.
The flights from Europe to Boston and New England all fly right overhead. So I think even if you're flying into New York, the Great Circle that they used to get to New York from the other side of the pond. Goes right overhead. But probably the airport down the street here might not be able to take a plane that could also make it across the pond.
That's probably true. I'm guessing there's not an 8KB private jet. So
not yet.
Where do you think we're doing with all the t-shirt money? Let's be serious.
This brings us back to John Morehouse's cash in a box or something. What was it you said, John? How can we just give you money?
I just want to give you money. I ordered 2 t-shirts, but give me a link and I'll just throw you some cash to help out.
Could see that. Yeah, I actually ran my Sunday car race this weekend with my Mix Accent shirt on under all my cool suit stuff. So it brought me good luck mostly. So
Nice.
Thank you. Didn't hit anything, so we'll take it. Before we get into the session here at 1:30 my time, from a question standpoint, are there built-in breaks? You just want me to yell? How do we want to do that? Not to bore us all with logistical stuff, but I feel like we should figure that out.
Oh yeah, we probably should.
Yeah, I'm usually okay with disrupting. I think that we might get to a point though where if there are a lot of disrupting questions, we might want to switch that mode. I find it a lot more natural if we'd let people just, oh, someone had a question about that thing we just said. Let's address that question now. But we might have a hard time squeezing into this 90-minute slot. So we might want to, start that way and just have the ability to turn that knob off.
Fair
And
enough. Yeah.
I'm happy later today to answer questions in Slack if it goes beyond the time. And so
Okay.
And we do have some time built in because we're going to be swapping presenters as we go. So there will be a little break in between each of us when one stops sharing and the other starts. And we have time built in. Well, we were hoping to have time built in at the end for questions, but we'll see how that goes.
All right. So I'll kind of go with the vibe of the session. And if I'm screwing that up, just tell me. Be like, hey,
yeah, sure.
Not now.
Yeah, we can just wait.
I will do
and
as
say,
I'm
hey,
told.
No more ad hoc.
And also, I guess if there are questions that in your estimation will be easy to go back to at the end, you can always make the decision on your own too.
All right.
We'll roll with it. Whatever.
Yep. So we've got 7 minutes before the start, so we'll let all the attendees get themselves sorted, and then we will kick off. About 3 minutes before, what I'll do is I'll get rid of I'll stop sharing my screen and get which one of you is presenting first.
I am.
Okay, so you can grab the screen, and then I'll give you a quick introduction, just saying session title, the usual jam, and we'll go from there. But until then, we've got 6 minutes. So yeah, absolutely.
Do we want to just test? Like, I haven't used this webinar platform in a long time. Maybe we just want to test.
Absolutely. What I'll do is I'll stop sharing if you want to try and grab it.
Sure.
Just curious what the transition is going to be like. That's all.
There we go. We got your first slide up there.
Okay, fantastic.
So if you folks want to test grabbing the screen off each other, you're all panelists. You've all got the ability. There's a little taskbar down the bottom.
Yep. I'll give it a shot.
Just stopped, Aaron. So.
Okay. Oh, wow. So I have apparently 4 PowerPoint windows open. Awesome. So I don't know what I'm going to show you if I open this.
One of them is probably the presenter mode, if you're
right.
already in presenter mode.
There are 4, and they all say Microsoft PowerPoint unknown. So they're not labeled, so I have no idea which one is which, but let me try.
What's good is the Office apps aren't hogs or anything, so they'll just stay in their lane. It'll be fine. Yeah.
Oh, I have to let this do it. I have to quit Zoom to let it share my screen. All right, so I will join back in a minute.
This is why we do tech checks, everyone. No worries.
we didn't do one for him.
So I did a session, I think it was a couple of weeks ago, where they used this platform that I hadn't used before. It was all done through a browser, so I couldn't. There's no like little box like you get in Zoom when you're presenting. So apparently it cut out 10 minutes before the end of my session. I just carried on, absolutely oblivious. And it was only until the end of my session I went, so do we have any questions? And I went to the browser and it was like, you've been logged out. I was like, how long ago did that happen? Get Aaron back in? No.
That'll be fun if we don't get Aaron back. Oh,
there he is.
Andy, you can just cover his spot. You know that. You know this.
Yeah, like we were talking about earlier, we're just the same person anyway. We're a package deal at this point.
That's very true.
Oh, excellent. Yes, you can see your screen, Aaron. So you got the first PowerPoint slide up.
If you're talking, Aaron, we cannot hear you.
And if you're advancing slides, we can't see it.
This is because I joined. When you join, it mutes you, even if you're a panelist. Okay, so my screen looks okay. And how do I sound?
Good.
Yeah.
Okay. I've been using my earbuds exclusively for meetings and not using my Yeti mic, and I kind of don't want to have to set that up at this moment if I don't have to. So if this is decent, then cool.
Yeah, no, that's good.
Just make sure your earbuds are charged, Aaron.
Yeah, the earbud should be highly available, especially for this session.
I have a pair. They are async secondary.
That usually does the job.
Yeah. Okay, so I'll stop sharing.
Okay, yeah, so we have 2 minutes to go. So Taryn, do you want to grab it?
Sure.
We won't put our slides back up now. I'll
Okay.
get rid of those up. Yeah. Okay, looks great. Now we've already had a comment from someone in the Slack channel, so I hope they have good advice on getting proper help from Microsoft support. Oof, okay.
Well, I'll mention that.
I need to change my background now, Andy and Aaron.
No,
Not
Aaron,
yet.
It's okay.
Not yet. Soon.
Soon.
Okay, so I think that's pretty much 6:30 in my local time zone, or 5:30 in UTC. So this is our penultimate session, everyone. I hope you're still with us. I hope your minds are not too melty. We are here with Aaron, Taryn, and Andy with Lesson Learned at Stack Overflow, Availability Groups at Scale. Take it away, folks.
Hi, everyone. I'm Taryn Pratt. I will kick us off. Welcome to our session about availability groups at Stack Overflow. Andy, Malin, and Aaron Bertrand are also here. They will introduce themselves in a second. But first, again, I'm Taryn. So I used to work at Stack Overflow. Right now, I am a senior PM at Microsoft. I also love pivots. If you know that, you probably follow me and know that I love pivots. And my pronouns are she, her.
I am Andy Malin. I am a staff DBRE at Stack Overflow. My pronouns are he, him. I've been a Microsoft Ed Platform MVP since 2017. So 6 award years, but 5 years on the calendar. And I'm super lazy and impatient, and that helps me be good at my job.
Yes, especially impatient.
Yeah. Go ahead, Aaron.
Yeah, so I'm Aaron. I'm also staff DBRE at Stack Overflow. I've been an MVP for, I'm not going to put the year down. I'll just say I've been awarded 25 times. And I'm an old Canuck with many opinions, and my pronouns are he, him.
Okay, so quick overview of what we're going to be covering today. So obviously availability groups, Stack Overflow. I'm going to go in a little bit on the architecture that we have. Aaron's going to cover how Stack does observability and performance, and Andy's going to get a deep dive into scalability problems. And hopefully, if we have time at the end, we're going to have an Ask Us Anything about Stack. So architecture and why we built and how and why we built it. So first up, I have to start with a disclaimer for all three of us. None of us were around when any of this was built. So many of the decisions that were made at Stack were inherited by all of us. I left it to Andy and Aaron to kind of take it over when I left, but I inherited it and I worked on it for a very long time, trying to make it as stable as possible. And even though I've been gone for almost a year, I still know the infrastructure very much like the back of my hand. But the big caveat that I have to say is that the architecture and setup that Stack has worked for our needs at the time. It does not necessarily mean that that will work for you. The problems that Stack was trying to solve were very unique to Stack. So that is something that you have to keep in mind when looking at our architecture. So the Stack architecture is very different than a lot of other places. It launched in 2008, and we were always very hardware constrained. What I mean by that is we didn't have a lot of money, so we didn't have a lot of infrastructure. So we had to make do with very limited infrastructure for our on-prem layout. It's very much still an on-prem organization, as Andy and Aaron know, and they still very much run on very limited hardware. Limited hardware, but it's very beefy. So when I say beefy, the Stack Overflow server has 1.5 terabytes of RAM. And while we were limited to restricted to limited hardware, the goal always was to be as efficient as possible across the entire platform. So Stack is outside of the Stack Overflow database. There's always where it was built as a multi-tenancy architecture. So what that means is each one of the sites across the entire network has its own database. And that pattern of a multi-tenancy continues for Stack Overflow for teams where there's thousands of schemas, one per customer in each database instead of thousands of databases, because Andy and Aaron would definitely not want to be maintaining thousands of databases. The one thing that I do have to stress is that Stack Overflow always has said that performance is a feature of the site. I know that I drilled that into Andy, and I assume he probably drilled that into Aaron when Aaron started. Performance is a feature. And what I mean by that is that the goal has always been to load the site as fast as possible with very little latency across the board. So like, for example, if you Google Stack, any type of question or anything like that that pops up on Google, that points to the question show page within the architecture, and that's actually querying the database directly. So that's not cached. We want you to be in and out as soon as possible across the board for any of those questions. So performance has always been a feature of Stack. Overall, the architecture of Stack Overflow is very simple. There's not a whole lot to it because we didn't have a whole lot of hardware. So we have there are two data centers for Stack. The main data center is in New York. Technically, it's New Jersey, but we never wanted to change the names of servers. And the DR site is in Colorado. The infrastructure is basically, there's 9 web servers. They use Redis for some caching, Elastic for search. And then there's 4 SQL servers basically that handle all of the public-facing sites outside of Teams. We're not talking about Teams for this. So within the public-facing sites, I'm talking about Stack Overflow, and then the Stack Exchange network of sites. And each one of those clusters it's a 3-node cluster. We've got a primary and a secondary in the New York data center. And then we have basically the same infrastructure, obviously, in our DR site in Colorado. So it's a very, very simple layout and very simple architecture that we have when it comes to infrastructure. And that goes hand in hand with the fact that we didn't have money. So Stack didn't have a lot of money, so they didn't have a lot of infrastructure. So now when we start looking at the SQL Server side of things, this is a very high level, very basic layout of how SQL has been or was when I was part of the team. There are 2 main clusters. There's a Stack Overflow cluster and a Stack Exchange cluster that handle all of, as I mentioned, all the public facing sites. They are both 3-node clusters, 2 in New York and 1 in Colorado. We also have an additional cluster, which is an internal dev cluster. Again, 3 nodes. Those are on VMs though. Those are not physical hardware. And then there's the it says channels cluster. That is, channels is the Stack Overflow for Teams product. They initially were called channels. Again, we didn't want to change the architecture and change the names, so everything says channels, even though it's actually Teams, but that's a whole nother story. So in this overview, you can see that we have a Stack Overflow cluster, Stack Exchange cluster. These are, as I mentioned, they're 3-node clusters, and we use availability groups for them. So the Stack Overflow cluster, there's only 5 databases. That's where the beefy guy, Stack Overflow, exists. So there's 1 availability group. On the Stack Exchange cluster, there are 4 AGs, 388 databases. One of those AGs has 375 databases in it, or had 375 databases in it when I was there. And then you'll notice that we have these lovely red arrows where it has SODAG, HADAG, INTDAG. So basically, across the infrastructure, outside of using always on availability groups, we also use distributed availability groups. So what we do is on the Stack Overflow cluster, there is an AG, but there's also a distributed AG that ports basically and replicates the data from the Stack Overflow cluster down to our reporting cluster. I'm going to use reporting in quotes because it's like a rudimentary data warehouse. So the reporting cluster gives the internal teams and engineers the ability to query the primary and query live data in the databases without taking down production. Hopefully, that's the goal. So across the board, we have multiple AGs, and then we have distributed AGs that all point down to the reporting cluster. And for that cluster, there's 2 servers. There's 1 in New York and 1 in Colorado. Outside of those, Stack also has a whole bunch of miscellaneous servers that include like log servers, dev, test, a bunch of other stuff. So that's the very basic overview of the Stack Overflow infrastructure. So one of the things that is the most important thing about to remember and realize about Stack is that while we had limited hardware, and there's perks to that because there's less patching. There's less things that you have to worry about, especially when you're on-prem and you've got to patch stuff. There's a lot of challenges that come with having limited hardware. The main thing is, like, you really have to know your infrastructure. Like, you have to know it really well. I had to always be mindful of free space. When I first started working on the SQL servers, we were at like 90 to 95% full. So there was a lot of juggling of data. There was even some shrinking that would take place on the databases because you have to make do with what you have. And so that's a challenge that you can have when you have limited hardware. Patching and upgrades can be really, really difficult when you don't have a lot of hardware because when you only have like a 3-node cluster, let me go back here real fast. When you've got 3 nodes in a cluster and you've got a primary and a secondary, and you are going to you need to patch the primary, and you fail over to a secondary, you've got all of your traffic going to one server. So things that you have to consider is you've got to consider user connections and the load and all of that stuff when you are patching. And when you start talking about upgrades and you have distributed AGs, that adds some additional complexity, because when you switch versions, you've got servers that are not going to work when you have limited hardware because you've changed versions and things like that. So some of the things that I would really stress as across any kind of environment is monitoring, and knowing your environment is incredibly critical to making sure that you are successful and you can keep your servers up and running. And I am going to now kick it over to Aaron.
You're such a fast talker, Taryn.
I know. I'm sorry.
No complaints. Aaron's going to talk for like 25 minutes.
No.
I knew that you both would kind of pick it up and like would fill it in, you know, so.
Yeah. All right. So as far as observability go and performance go, basically the question is, how do we keep the lights on? How do we make sure that our database servers are performing well, that the application is performing well? And so from a DBRE perspective, we have a lot of observability tools. And there we go. And the first one that we use is OpsServer. This is an open source tool. It's at github.com/OpsServer. And we use it for a variety of things. High level and detailed resource usage. We look at the availability groups, their current configuration and their status for some of the other services like Redis. And then it also has a nice summarized top and active queries view. And we can also look at exceptions from various servers there as well. And why do we use that instead of built-in tools? It's just, it's a much more concise view than SSMS or SQL Sentry for AG specifically. And some of the top query stuff too is very powerful to see aggregates. And I'll show a couple of screenshots from those. So at a high level, we can look at all the database servers and the web servers, and we can see what's their CPU, what's their CPU been like over the past hour, what is the memory usage, what kind of network are they using, what kind of disk are they using, very high level view. But if something is performing very poorly, it's going to stand out here very obviously if it's very different from the others or very different from its pattern over the last hour. The AG view I love because it's all of our AGs are on one screen. So we can see, instead of like going through dashboard after dashboard after dashboard in SSMS or all of these views inside of SQL Sentry, we've got one screen where we can see the status of every single AG, every cluster, every node in each AG, and see what the latency and the rates, log send rates and everything else are all visible right here. We can see how many connections are on each server, what the status of all of the databases are, and all of that. And then the top query view can show us aggregated view of all the queries that are running, which is very different from what you would see in Query Store or SQL Sentry or any other monitoring tools. Just because it aggregates all of these things, how many times are these queries running? What is their average runtime? What was the last time it was executed? Much better view than things where if you're failing over and your databases, you go from a primary to a secondary and then back again, you lose a lot of this information with the built-in things like Query Store. We use Andy's DBA database for a lot of things. Mostly for me, it's for availability group latency. It's the one store procedure in there that saves me the most amount of work because I am way too lazy to memorize joins like this. I don't ever want to have to write this from scratch. There's a store procedure in there. You just say check AG latency, and boom, you get all of this written for you. Very powerful database. A lot of other useful stuff in there too, so I highly recommend checking it out. Whether using AGs or not, this is just one of the aspects, but we were also using it yesterday to look at how much free space was left in one of our log server databases. We've got multiple file groups and multiple files in those file groups. And instead of going and trying to figure out what are all these joins between sys.partitions and sys.file groups and sys.dataspaces, that just already does it all for you and gives you what is the size of each one, how much free space is there, and all of that. We use SQL Sentry, and not just because I worked there for 9 years. It has very fine-tuned alerting, so you can really set up how you want to be alerted on things that you want to be actionable versus non-actionable. And it's very good for post-incident analysis. So for Observer, you can see what's going on right now, right? Most of the things are just real-time view. You can't go back in time. With SQL Sentry, we can go back and say, what was this thing that happened for half an hour yesterday at lunch? And it allows you to go back and see those things that happened and correlate everything together. It's got a great dashboard. It's highly configurable, a lot of drill through. Downside, some features are not supported. So we can't look at distributed availability groups, for example. It doesn't support it. And actually, when you try to load the availability group screen right now, it crashes. So not the best experience for that specific observability. But this is just an example of the dashboard. So if I see something, a minor CPU spike yesterday at 5:30, I can click and drag on that chart, jump to, and I can go look at the top SQL statements that we're running or other things. We also use signal effects. We use Splunk to feed all kinds of metrics and our own custom homegrown things to feed metrics into signal effects. This is mostly for hardware and OS. Or for our team anyway, we look at the hardware and OS level metrics like storage and network. We have some app-specific dashboards, like how many teams are active, how many teams have been created. So certain teams have specific things in there. And why do we use this tool? Well, the dashboards are easy to configure. And this wasn't something that we enabled for DBREs. This is something that's used by other teams across the company that don't have anything to do with databases, right? So it's just something that is a bunch of metrics are being fed in there, and it can be a useful place to check for certain things during certain incidents. And it's just an example. See, when we look at this for a SQL server in our environment, it's pretty boring because there's nothing. I mean, you typically don't have any of the kinds of spikes that you see in other application level metrics. We have some other internal data and tools. We have HA proxy logs. This is the place where we store all of the traffic that's coming in to the network. And it really enables us to investigate things like site instability issues that you might have seen us managing in the last week or so. We go through and try to slice and dice and figure out what IP ranges are these queries coming from, and what routes are they hitting, and why are they taking longer than they usually do. And it's a lot of data, and it's not very fast, but it allows us to really hone in on something that just happened and see what are all the patterns for that traffic. Datadog. So we are currently in a POC for Datadog. We're taking a look at that, and this is primarily to reduce observability sprawl. I don't want to talk about our observability in 5 or 6 slides. I want to talk about it in 1 slide. So ideally, we eventually like to get onto one tool. I don't know how fast that'll happen, but this tool is already paying off. It already pointed out an imbalance we had on a load balancer. We had a load balancer sending requests to 9 web servers, and it immediately, as soon as we turned it on, it pointed out, hey, this load balancer is not distributing the load evenly across these servers. So it's already had one little positive impact. And so one of the things that we want to do in an effort to keep this as a performance as a feature network of sites is to minimize database load, right? We don't want the database to ever be the bottleneck, and we want to deflect the blame from the database as often as we can. Because usually it's not, but you still have to make an effort to get there. That doesn't just happen automatically. So some of the things we do to minimize database load, we use readable secondaries for a lot of read-only queries, right? And for other activity like backups. So sometimes the readable secondaries, people think, oh, well, let's just throw all the read activity at the secondary. Well, that only works to a point because that secondary has the same kind of limited resources as the primary. Typically, they're similar to the primary. And you can't just say, well, throw 8 billion read queries at the secondary. It'll be fine. Nothing bad will happen. A lot of the things that you do on your secondary affect the primary, and they affect the network, and they affect the response time of the app. So something you do have to be mindful of. It's not just your TempDB porta potty of your cluster, right? Sending all the traffic there. We use Redis, so mostly for best effort read caching. So things like lists. So you have a list of questions that belong to a tag, let's say. And so that's a good place to cache things like lists. Not a good place for large content like a post, right? So this is, Taryn mentioned earlier, when you go and you request to see a question with its answers, that goes to the database, not to cache, because if you think about how many questions there are on Stack Overflow alone, and then across the entire network, your Redis instance would have to be bigger than your database in order to always have a cache in. So most of the time you're going to have a miss if you're trying to pull a question from Redis. And because questions, especially when they're brand new, are edited and metrics about them change constantly in the first day or for the first certain amount of time, like you would be constantly flushing those into Redis to make sure that the cached version is the one that everyone sees, right? Is up to date with the one that is actually in the database. So all of that flushing just doesn't make sense to use that as a cache for large content. Sometimes we use it to offload writes. So one example is we have, when you go to post a question and you start typing, you might notice that if you close your window and you come back, you still have a draft there. That's written to Redis, and it holds that in the Redis cache instead of writing that draft to the database. So you'll also notice that sometimes if you wait too long and you come back, it's gone. So it's not a permanent thing. So that's just one way we offload writes. Instead of saving that draft to the database, we save it there. We use Elastic for searches, and the primary reason for that is that we don't want all of the searches that users are running all of the time to go against the database. We can't use a product or a feature like full text search. You can't solve most of the searches that our users are running because they're searching for things that are inside of code or certain keywords that aren't really words or segments of words. And we have all kinds of custom filters like, is it a question? Does it have an answer yet? Does it have an accepted answer yet? All of these things. And then we have a CDN, we have HA proxy. So we have these things at the outer layer that can offload some of the requests that even come into the application, never mind the database. So we cache, I don't know, one of the things we were talking about today was favicon. So we have a favicon at the top of the thing. That doesn't have to come in from the application. That can be something we can cache out at the outer layer, and the request never comes into our network. Things like that. So if we think about the layout that Taryn was describing earlier, we've got 9 web servers out here. We've got the Redis and Elastic nodes. We've got the primary and secondary databases. Most of the read-write or most of the write activity goes directly to the primary. We can't write anywhere else, except for the minor example I was talking about with putting drafts into Redis. All of the reads, we try to get all of the reads or most of the read activity coming from the secondary, so we're not interrupting and having impact on the primary. So these come from Redis, Elastic, and the secondary. We also offload some of our internal analysis to additional copies of the data. So something I didn't put on the slide is SETI. So we have a Stack Exchange Data Explorer. That's those queries that you see run across an anonymized separate copy of all of the network databases. So we have those, we put those copies of those and refresh them every week. Yeah, every week. And those have copies of the data that end users can go and run analytic queries against, and it doesn't impact our main site production workload because it's a separate copy that's just for that purpose. We also have things where internally we're using sources like Snowflake. We use Snowflake to perform some of the analytics against our data so that the teams that are performing those analytics also aren't impacting our production workloads. This is one of the trade-offs we make. So we currently use async secondaries just to avoid the penalty of waiting for the acknowledgement, right? So async secondary has a slightly different behavior, and performance is a feature. So we want to make sure the page load for something, or not the page load, but something that the user does that ends up having to write to the database, they shouldn't have to wait for the acknowledgement from the secondary for that write to right to happen and for them to the page to return to the normal behavior. So we kind of trade safety, a tiny little bit of safety there to reduce latency that the user experiences. Some other best practices we violate. This isn't really performance related so much. We have several of our applications have no schema prefix. So all of the queries say select columns from posts. There's no, if you ever see in any of our incidents, we show a query that is run, or even the sample queries that we put on SETI, select from posts, not from dbo.posts, because part of our architecture is made to support multiple tenants inside the same database. So we have every team, let's say, has their own schema. So when they come in and they authenticate as their schema, they're in their default schema, team 1, 2, 3, 4, 5. And when they say select from posts, they get select from team 1, 2, 3, 4, 5.posts, which is fantastic for not having to have a separate query for every team, right? So every team gets to reuse the same code. So when you fix a query, you add a semicolon to the end because it was never there, or you change some logic in it. You don't have to change it for all of the teams that we have and all of the networks we have. You deploy that same changed piece of code, and it works again. It continues to work against all of the databases because of the authentication. The downside is that now if you have 10,000 teams on a server and they all run the same query, you have 10,000 copies of that plan in the cache because each one is associated with that schema. So that's a downside we kind of have to pay attention to. Stored procedures. So this was kind of a little pet project of mine when I started. It's like, we don't use stored procedures. This is really bad because it reduces visibility and control for us. If we want to help tune a query, we have to first catch exactly the query that was sent because the application is constructing the query. And it's really hard for us to go into the C# code and figure out what is the actual query that gets created in this scenario because it's all constructed dynamically. We use Dapper as an ORM, and I feel like if we spot a situation in a query that's come across and we want to help tune it, our hands are kind of tied, right? We have to go back to the development team and say, hey, this query that comes from this page, this line in this file, it does this, and we need to add this hint, or we need to change this join criteria to this, or change the way the data type that this parameter is passing. And this is something that's been here since before Stack existed. So Jeff Atwood wrote the store procedure a long time ago. Who needs store procedures anyway? And that's kind of been the Bible since then, and will continue to be the Bible since then. So kind of I don't know, it's a bittersweet thing because on the one hand, I want to have store procedures because I want to be able to have that visibility and be able to solve the problem instead of just having to talk to an engineer about how they can solve the problem when it's clearly a query or a database or some kind of tuning issue on our side. But on the other hand, can't argue with results. So they have spent a decade optimizing the code to minimize page load times, and it works, right? The entire web app for all the networks runs on 9 web servers, right? When it's active in New York, when it's active in Colorado, 9 web servers, which is kind of amazing when you think about the volume, right? These web servers are consistently at less than 10% CPU. They use about 30 to 35 gigs of memory on a regular basis. Page renders, 20 milliseconds. That's without caching. That's what Taryn was talking about. You read a question, you open a question page, and it pulls the question and the comments and the answers and the reputation and the users, all the users that were involved. That page renders in 20 milliseconds. How am I going to argue? How am I going to fight for stored procedures, right? Like I'm going to say, hey, I could make that 18 milliseconds if you change all of your entire development model and introduce stored procedures, and I'm going to save you 2 milliseconds per page render. They're going to tell me where to go. Like, it's not enough. There's no ROI there for fighting to change the way that we currently do things until it becomes enough of a problem where we have to, right? When that goes to 50 milliseconds, am I going to have an argument? When it goes to 200 milliseconds, am I going to have an argument? And at some point I will, I'm sure, but it's not right now. We serve 6,000 requests a second, 2 billion page views a month, 2 billion page views a month with no store procedures. And all of those page renders of question and answer pages, again, no caching for those. All of the public network sites run on 2 primary SQL Server instances, right? Technically 4 because they get the read activity from the secondaries, but all of the write activity, which is a lot of it, is on 2 servers, 2 SQL servers. Those are consistently at less than 15% CPU, but they do use all of their memory. That is not a question. So if you think about this setup, right? 9 web servers with 96 gigs of RAM, 2 Redis instances and 2 Elastic instances with 32 gigs of RAM each, and then secondaries or primaries and secondaries with 1.5 terabytes and 768 gigs of memory. And that's 2 billion page views a month at 20 milliseconds per render, which is that number just blows me away. I work here and I just think it's phenomenal. So the performance problems that we do chase, sometimes we find a pattern, right? We're usually finding classes of problems, not this query is bad, but the way that we're approaching how we're getting the data for this query and whether we can pre-aggregate it up front instead of getting it in real time every time. Those are the kinds of classes of problems that we're constantly chasing. But a lot of them are just not related to end users, right? Or the application. And a lot of times not even related to the volume. They're just things that aren't working the way we expect. So currently we have a problem with our failovers. And the way that we deal with this is under normal operation, we have read-write activity that goes to the New York web servers, and then they interact with the services that are in that data center, right? So you have these 9 web servers in New York, and they talk to Redis and Elastic and the primary and the secondary in New York. This is the way things normally operate. So during patching, what we could do is we could just point the New York web servers to Colorado, right? So we could do our failovers inside of New York, and the New York web servers could just talk to the services in Colorado and the databases in Colorado. So that would look like this, right? The databases, we pretend they don't exist, and we send all the traffic to the databases in Colorado. Instead, we fail over the entire architecture. So we have DNS and proxy out front that sends the requests instead of going to the New York web servers. They go to 9 web servers that are sitting in Colorado that are specifically designed to handle the workload, just like if the New York data center exploded or flooded or whatever, right? Pretend the New York data center doesn't exist. We have to mimic the architecture there so that the site can stay up even if a data center is gone, right? So what happens there is DNS sends requests to the Colorado web servers, and the entire site changes mode to read only. So now in Colorado, they read from the Colorado replica or from Redis and Elastic, but they don't do any writes, and the application just prevents any writes from happening. So that kind of looks like this, right? So this kind of pretends that New York doesn't exist. The reason we have to do this is what Andy's going to talk about next, and he's going to explain how many databases fit in an AG.
Thanks, Aaron. Do you want to stop sharing so I can share my screen?
Yeah, as soon as I.
The other things that so we use the failover to Colorado for any maintenance window. So that includes we were doing network maintenance last year where we were replacing all of our network hardware. So we were able to run completely out of the Colorado data center while we did that, take down the New York hardware, replace it, and then move back to New York later. And it was a really smooth maintenance window. And most people didn't realize that there was a period of time where we had 0 network connectivity in our New York data center. But we're here to talk about how many databases fit in an AG. So I'm going to start by I'm trying to hit my buttons while I'm on the presentation instead of being like on the Zoom instead of being on my actual computer. Where did PowerPoint go? Where's my slideshow? I swear I'm a professional. I've done this before. My slideshow, it won't let me switch to my slideshow. Okay, I'm having the same problem Aaron did. Let me stop my share. Go back to my slides. There we go. Share.
So we've got a question while you're sorting that.
Yeah, while I'm being incompetent with PowerPoint.
No, PowerPoint's really frustrating. Says, when you fail over to Colorado, is the Colorado SQL server a single point of failure? Should you have 2 Colorado SQL servers?
So I will go ahead and say that there's not really a need to have 2 servers there. If we were planning on running in Colorado for an extended period of time, we might need high availability. But we don't plan for cascading failures. Cascading failures being not only is New York unavailable and we have to move to Colorado, but also something happens in Colorado at that exact same time. And it's an ROI thing. It'll change for different businesses. For some people, it will be, whoops, now it's working. For some people, the ROI means that you do need to have high availability in your second data center. When I worked at Wayfair, all of our storefront database servers had 2 nodes per geography. But for Stack, that's just not in the ROI for us. It would be really common for e-commerce or healthcare or some other things. Go ahead, Aaron.
The difference is, like, for e-commerce, that's a cash register, right? And you need the cash register to always be available. But for a lot of sites, I think that, you know, having a secondary in your DR site is like carrying 4 spare tires on your car, expecting that, you know, either all 4 tires are going to blow out or you're going to blow out the same tire more than once on any given trip, you know. So it's kind of like, is it worth having that extra redundancy just in case multiple things happen?
Can I just chime in and say, I know that we did have an extensive discussion about this probably a year ago about adding another node in Colorado because there was going to be a massive hardware change that was going to happen in New York, and New York was going to be taken down for a while. So we were going to be running out of Colorado solely off of 1 server, and all the red flags went up. Like, I don't know if we can do this. Like, we don't know if we can successfully run off of a single server for a week. So the SRE team worked very hard and very diligently to make it so that it was possible for them to do the upgrades that they needed to in New York while still running out of New York with just maybe some read-only time out of Colorado, because buying additional hardware when you're on-prem is very expensive. And as Alan said in chat, like, there's licensing costs that come along with that if you add additional hardware. So, and as I mentioned, the hardware is beefy, so it's going to be expensive to license an additional server that's just going to sit there most of the time. So yeah.
Cool. Good question. Excellent question. So now I'll go into this. Before we talk about problems, what actually happens when you fail over an AG? So there's 2 parts of it. Transitioning from primary to secondary. So the server that is your initial primary stops allowing writes. It has to perform the rollback or roll forward for things that are in flight at that time. So for most things, if there's a transaction that is open at the time of failover, it has to roll that back because the partial transaction won't be finished. And it also has to begin accepting logs from the new primary, and then everything is all turned around. On the server that is the initially secondary and becomes primary at the end, it has to make sure that all of the transaction logs that have been received are completely redone, and then it can begin taking transactions, including writes. And usually this whole thing takes less than a minute or so, depending on how many databases you have, how busy they are, and a bunch of other factors. So let's take a look at what failing over an availability group looks like if you've got 380 databases in it. So Aaron mentioned we typically run pretty low on our CPU utilization. So I'm going to make them nice round numbers and say that we're running at about 20% CPU utilization on the primary node and 10% on the secondary node. And when we fail over 380 databases, you'll see here in this graph, CPU spikes to 100% very quickly. Instead of being finished in a minute, CPU is at 100%. And then a couple minutes later, the CPU on the former primary, that initial primary, drops back down. Sigh of relief. But the new primary is still pegged at 100%. Okay, a couple more minutes, and now the new primary has settled down to about where we expect it to be. Oh no, the former primary is back at 100%. Now, the first time I did a failover after I joined Stack, Taryn had already experienced this. So she was like, buckle up, Buttercup. This is going to be a ride. And she told me what was going to happen. I still wasn't prepared for the anxiety of watching a server where your CPU graph looks like this. Now, some people might be thinking, okay, but the new primary seems to be healthy during this time. And it is. It is. But what about all of those read-only connections? What about non-availability databases on the other node? Taryn mentioned we run multiple availability groups on these servers. The other availability groups, if they are still running on the SQL 03 in this graph, that server's at 100% CPU, and there is no way any of those other databases on that node are going to be able to do any work. This is really important. It also ties into something Aaron mentioned along the lines of we use async mode for the AG because we don't allow automatic failover. If we allowed automatic failover and one AG failed over, we would be screwed because the former primary CPU is going to be all over the place and we're going to have sites down. We're going to have stuff not working when CPU is at 100%. So during the maintenance window, when we do a failover, this is where we have time to chit chat, take our anxiety medications because our anxiety is through the roof, Papa Xanax, whatever. After about 45 minutes, the CPU comes down. Now, why does it do this? It's terrifying to sit there and watch it. So we started having this after we upgraded to SQL Server 2019. It was not a problem when we were running on 2017. This is important if you're currently running on an AG that is 2017 or below with a lot of databases in your AG. Make sure you do as much testing as possible to figure this out because you may run into the same issue. But I will also say this has been difficult for us to reproduce outside of our production environment. And Microsoft hasn't identified a specific change in the versions that is responsible for this. We had a support case for an extended period of time. We did a lot of trace captures, lots of different levels, iterated on that a bunch of times, and we weren't able to identify what exactly was causing it. Or rather, what change was causing it. We know what was happening when the former primary goes through recovery in order to set the databases into secondary mode, and it has to do that roll forward, roll back. It does a lot of work simultaneously, and that leads to thread exhaustion. Even when the databases are not particularly busy, even when the databases are not particularly large. So, and you can see that the server runs with great CPU utilization all the time. I think we can all agree that 20% CPU utilization is fairly low on a server. I wouldn't consider it high until you get above 50% or higher, even higher than that. But still, even though we're using servers able to do business as usual at 20%, doing the simultaneous recovery on all of those databases sends the server to 100% CPU. So we thought about what we can do to make recovery faster. We went through, we verified that we didn't have any databases with crazy high number of VLFs. Having to scan a lot of VLFs can cause recovery to take longer. It can cause your failovers to take longer. We ensured that indirect checkpoint was enabled on all of those servers so that they're checkpointing as often as possible. Checkpointing pushes changes to disk, gets them out of memory, and just makes sure that everything is ready. That also ensures that failover is fast. We also tried doing manual checkpoints along the way. Doing a manual checkpoint before failovers. We enabled accelerated database recovery, which is a new feature in 2019, to make, which is, and the name says it all, accelerated database recovery. We want to make recovery faster, so we enabled accelerated database recovery. Aaron wrote about that. We saw some benefits on our backups being much faster after we did all of this work, but none of it affected our failover time. So at the end, we could add more CPUs, right? Add more cores. CPU hits 100%, add more cores, throw hardware at the problem. But we're running on physical boxes. So if we want to add cores, we have to buy new servers. And as mentioned, that's really, really expensive to buy matching ones, 3 new servers, to make them super beefy. And CPU utilization is fairly low all the rest of the time. 360 days out of the year, CPU is low. It's only when we're doing failovers that we're having a problem. So it seems silly to spend all that money on hardware for something that happens 4 or 5 times a year. This also came up already, but SQL Server Enterprise Edition licensing is not cheap. So in addition to spending all that money on hardware, now we have to spend additional money on licensing. Again, for 5 days a year, and the other 360 days, that money is going to be wasted. So this is when we came to the conclusion that our next step was to break up the AG. So we're going to take that big, huge AG and just break it into smaller AGs. Thankfully, this is actually not as hard as it seems. So after you get the AG itself created, so I'm leaving out here the fact that you have to create a new AG. There's domain objects and permissions and stuff that goes along with that. Let's forget about all that stuff. But when you go to move a database, it's actually fairly easy. You pause log backups just so that they don't get in the way. You remove the database from the availability group. You do that on primary as stuff flushes across to the secondary server and everything gets redone. So it basically drains the send queue and the redo queue. Now the database will flip from secondary to in recovery. After it does that, you run a new command on primary to add the database to the second AG, and then do the join on the secondary server. You do not have to restore a log backup. You don't have to do any sort of reinitialization. No, so even if the database is large, this process will be quick. It's only going to take as much time as it takes for your send and redo queue to flush. So if it's a busy database where you're sending a lot of changes across, then that wait at number 3 might take a little bit longer. But it doesn't matter the size. It's not a size of data operation. A lot of people think that you would need to restore on secondary, and you absolutely don't. And then the last part is we need to repeat this 380 times, which is not great. I don't want to sit at my computer for weeks saying alter availability group, remove database, alter availability group, add database. I'm going to go insane. So Patrick, one of our teammates, he wrote a PowerShell wrapper that does these 6 steps, and you pass in a list of database names, and it pauses log backups for those databases, does the swap to move it to the new place, and then resumes log backups at the end. It'll take a few hours to move 60 databases from one AG to a new one, but it's very little work. We were breaking them up into groups of, I forget what we picked, 6 or 10, some smallish chunk to do it, so that if the script, if we ran into any problems, we wouldn't have like a script that's running for 4 hours. But it's worked pretty great. So the question that I asked at the start, how many databases fit in an AG? If you read the docs, it says that the number of databases you can have in an AG is unlimited. Now, an instance has a limit of 32,767 databases. So that means that any AG can have up to 32,767 databases in it. Microsoft recommends that you don't put more than 100 databases into an AG, but there's no enforcement for that. Their test cases are built around 100 databases. I believe I read somewhere that it's 100 databases and 10 AGs, so 1,000 databases on the instance total. But Azure Managed Instance does enforce a 100 database limit. So if you use MI, you can have up to 100 databases per managed instance. And then after that, you need a new managed instance. If you care about high availability and those failovers, I would say that 100 databases should be your absolute maximum. You can test it. In testing, you might find that you can push that a little further. You might find that you need to pull back a little bit. But your a generic statement, I would say 100 databases per AG. And if you do testing and do thorough testing, you might be able to go a little bit in either direction. But it's going to be closer to 100 than 32,000. Okay, now I have another story. I think this one's Taryn's favorite, probably, even though it happened after she left.
I did laugh.
Yeah, I'm sure you did. So like disruptive DML, DDL changes in an AG, right? We failed over, we did the thing that Aaron mentioned for maintenance, where we moved to Colorado for like half an hour for me to do some of these schema changes. So let's think about how this happens. We make a change, it's written to the transaction log on the primary and secondary. If you are using synchronous commit, which we're not, but if you are using synchronous commit, that change, whether it's DML or DDL, it gets written to the transaction log on the synchronous replicas before it's considered committed on primary. The data is changed on primary as part of that script, just like normal. You know, it goes to the log, it happens to the data in memory, your transaction is done. On secondary, the redo part is always done asynchronously, even if you're using synchronous replicas. It's not synchronous change happening on both, it's synchronous writing to the transaction log. After it's written to the transaction log, all of the secondaries pick that up and redo it. If you're querying a readable secondary, Readable secondaries force the use of snapshots so that reads don't block writes. But if you're making a schema change, it still has to take blocking locks. In order to change a table definition, you can't have people actively querying it. So let's talk about the time I broke stackoverflow.com. During the maintenance window, we had it in read-only. We're running out of our DR location in secondary. Great, I can make these disruptive changes, except I've kind of given it away. So specifically, we're removing sparse columns. These were, again, kind of dating back to a decade ago when we were being really frugal with our hardware and our storage. Sparse columns were used for columns that are frequently null. Nowadays, row compression is a much better answer for that anyway. But we also have plenty of disk, so we don't have to worry about using sparse columns. Sparse columns, one of the reasons why we were proactively removing these sparse columns is sparse columns on very large tables prevent online DDL operations. So an online add column, which is great normally, adding a column doesn't cause blocking. Exactly what we want to avoid. So we have to remove the sparse columns for that to happen. When the redo started to happen on secondary, everyone was blocked. I had this perfect plan. I would make the change on primary while we ran out of our DR location. Nothing would go wrong. After we made all of those changes, we would fail back, and I wouldn't have caused blocking and wouldn't have taken the site down, except that I did. And we were removing a bunch of columns. So the first column I removed, stackoverflow.com went down. In the middle of the maintenance window, we altered our approach. On the readable secondary where we were running the site, altered database, set HADR suspend. Now it stops redoing all of those logs. It's like paused in the AG. The stuff I do on primary is going to queue up and not be sent to secondary. So I made my change after I suspended change on the secondary. And that means that I'm writing to the transaction log on primary, but it's not going to Colorado. It's not being redone in Colorado. I'm not going to break production again. Then after I made all of my changes, moved traffic back to primary, came out of read-only, made sure everything was happy. And then I resume HADR, set HADR resume. And that now after we're off of that server and we aren't actively using it, it sends across all of those disruptive changes. And again, this is something that really works because of the way we've built our architecture, where we can use DR for real anytime we need it to serve read-only traffic. Okay, that was the end of my story. And my mouth is super dry because I was either talking really fast or I'm super nervous. We'll find out later.
So we've got a couple questions to get into, one from Q&A in Zoom and one from Slack. So the one from Q&A in Zoom, somebody pointed out that they found with more than 150 databases, the latency within the AG got too high. So they generally end up settling around 100, 102 per AG. And we're curious for the thoughts of you folks about, is there kind of a magic number where the latency seems to tail off? Or is that just kind of, is that not just dependent on number, but a whole lot of other factors?
It's definitely dependent on other factors. One of those factors, I'm going to stop my screen share here so I can look at everyone's sunshiny faces. It's more a factor of how busy databases are. So with us running 380 databases in one AG, we don't actually see a lot of latency because the change volume is relatively low, or at least relative to this person that's running 150 databases. But there are a limited number of threads that get used for sending. So in the case of having high volume data churn, breaking up some of that to move some of the busier databases out, so they're not all of the busy databases aren't in one HE, can definitely help the send performance on that. I don't know the exact internal details on how that works. Alan Hurt is in the Slack channel. I'm sure he will correct me on any details I say, but.
So let me thank you up front for that perfect segue, because I was about to relay a question from Alan, and I'll read it verbatim. It says, one interesting thing I would love to hear: how do you size, scale, configure your TempDB for your porta potty? I find customers do this poorly. Don't have a clue, since a read-only replica is not exactly the same as a readable DB and how it works. I would love to hear your approach, and that is for the group.
You want to start, Taryn, since
because y'all probably have made changes, so that is on your plate. I don't have access to the infrastructure any longer, so it's up to you guys.
The one change we did make, Aaron made, so maybe Aaron will start and talk about the TempDB in-memory TempDB.
So we did enable the in-memory TempDB configuration option on all of our servers, and then we turned it off on a couple because we were getting stack dumps that still haven't been analyzed by Microsoft, and that there is still not a CU fix for. Microsoft has acknowledged that it's a problem, and they just don't have a fix yet. So we were getting disruptive stack dump behavior on a couple of servers with very specific workload types, and that setting was not helpful in those cases. So I hate when we have a setting that we can apply on most of our servers and not a couple, and we have these exceptions, and that kind of sucks. But that's where we're at right now. We don't know of a timeline from a fix from MS. Karen, you're supposed to change your background, I think.
Yeah, my bad.
Sorry. I'm not trying to badmouth Microsoft. I'm sure it's a complicated problem, and I'm sure there isn't a fix yet for a reason. It's been known for at least for a couple of CUs so far. They've known about it, so I'm not sure. But,
yeah,
got it.
To go back to Alan's original question, though, we don't do. The OLTP website workload doesn't make heavy use of TempDB. So we don't necessarily do anything super special for TempDB on these servers. We follow general guidance roughly, but since utilization on TempDB is pretty low, we don't have to worry about it too much.
Got it. Yeah. Well, it was interesting to hear the development refinements, because a lot of times developers will just lean on TempDB to, as that scratch pad, right? And it sounds like obviously Stack's done a lot of work over the years to not do that, which the DBA part of my brain appreciates very much. So we've got 3 questions that have just come in Zoom. Well, one just disappeared, so never mind. So we're down to 2. One is, would you recommend spending HADR on secondary when applying CU patches and failing over, so you wouldn't experience issues on the primary?
No, I don't bother. I do switch to async if I'm going to be doing planned maintenance and plan a restart of the service. I'll make sure that node is switched to asynchronous commit before I start doing restarts. But other than that, it's no problem. And since we run in async as standard operating procedure, we don't have to make that change at all.
Got it. Makes sense. We've got another one here in Zoom. It says, do you re-index your large tables regularly, and do you notice any impact to your AG secondaries?
I'm going to take that one.
Rock and roll.
I will take that one. So we used to. I can't speak to whether Andy and Aaron do. My guess is probably not, unless they have to do it ad hoc. I used to have a job that did index maintenance weekly. I took the server down. Remember how I said that we had limited drive space and limited infrastructure? We ran out of drive space during an index maintenance job, I completely maxed out. We were at 100% disk utilization. It was completely gone. So we had a very severe outage on Mother's Day. I remember the day, and I had just started the job. So no, that job got turned off because of those issues that we had with free space. We did periodically do index maintenance if we needed to rebuild an index. Sometimes we would do that, but yes, you do have implications when it comes to the secondary with that, because for one, there's like log issues. You've got to write all of that. So there's some additional issues if you're doing index maintenance. I wouldn't normally do that any longer. I'm sure Aaron and Andy don't do it unless they absolutely have to do it. We always had some databases and some tables that had to have some hand holding. I don't know if they're still doing any of that. I will let them comment on that. But yes, you have to be very careful.
Yeah, we do not rebuild any indexes at any point in time. We do have a job that runs on Sundays that updates statistics with full scan on our very large tables, and the tables that have that are known to cause plan skew because there's data skew, and we get crappy plans if statistics are out of actually, we get crappy plans when there are auto statistics specifically. So for those tables, we update stats weekly, and we also have auto statistics turned off on them. Which brings me to another problem that we have noticed on our AG, which is temporary stats on secondaries. Even when there are real statistics that are up to date and not stale in the database, the secondary will sometimes trigger auto stats, and the secondary will have temporary auto statistics, which then cause read-only queries on secondary to go sideways. So that was fun. But yeah, as a general rule, we do not rebuild indexes. I would rebuild an index if we dropped some big columns, some wide columns, and thought that we could reclaim space, significant amount of space, maybe. But for the most part, in the days of modern fast SSDs, statistics are probably 10 times more important than rebuilding your indexes. Maybe more than 10 times.
So I'm going to throw a bit of a curveball because it seemed like a lot of the undercurrent here was understanding your workload, which is obviously really important. And you mentioned some tools, obviously, that get you in much better touch with that. For folks that don't have those, that are relying more on gut feel, if you're trying to get out of gut feel into, I at least have some information in front of me, what would the three of you recommend?
I'm going to recommend my DBA database. If you download it from GitHub and install it according to package directions, it will also, there's two scripts that you run. So you download my script, and there's PowerShell script in there that will grab who is active, the first responder kit, and Eric Darling's stuff, and Ola Hallengren's stuff. And it'll install all of that in the DBA database. And that is the set of all of those open source tools, all those open source scripts, give you a lot of stuff.
Yeah.
Yes. Ozar's Blitz stuff too could be useful to have. And Observer is open source. So if the limitation is, hey, we don't have money to spend on commercial vendor tools,
right?
I do think there are a lot of options that maybe aren't, flip a switch and suddenly it's working. Observer you have to configure and all of that. But there are certainly open source tools that are not, where cost is not the barrier.
Yeah, it's more that bridge between, oh goodness, I have no idea what to do. I don't know what I'm looking at. I'm basing this all off gut feel. And yeah, that bridge to at least productionized open source tools and then stuff you pay for after that. Andy, could you drop that link in Slack? Because that would, I think folks would find that very helpful.
Earlier.
I'm happy to drop it again.
More information is not bad. Just had another one that came in on Zoom. I know we're creeping up on time here. Said not use distributed AGs before, not DAGs. You're welcome, Alan. Any gotchas or advice for a newbie to these?
I have a couple.
Yeah, go ahead, Taryn.
So for one, there's not a whole lot of tooling around it, which makes it difficult. That's one thing. The second thing that I would say is know your latency between your primary AGs and everything between all of the distributed AGs. So we had a very long run of an issue between the Colorado data center and the New York data center. And when I say issue, it was like going on 2.5 years. We had a latency problem between the two. And when you have a distributed AG and you have the Stack Overflow database that needs to replicate to our reporting cluster, which then has to replicate to the Colorado server and then the node in Colorado, and we had a latency issue. One thing that we always would have is the log on the primary for Stack Overflow wasn't truncating because the log hadn't fully flushed throughout the distributed AG. So that is something that you need to kind of pay attention to. And again, it comes down to the fact that we had limited infrastructure. So hard drive space was always something that we were worried about. So monitoring like the logs and the latency between your environments is very critical. And there's not a lot of tooling built in for distributed AGs. So Observer, I mentioned in chat, I lived in it because it shows in Observer what the log sizes are. So I could monitor and I knew what the normal log was for Stack Overflow or for any of the sites. So those are things that you kind of need to kind of pay attention to. And those are some gotchas that I have. I don't know if Andy and Aaron have others.
Yeah, I was going to say the same thing, but the lack of tooling. Taryn, close your ears, pretend you're not here. The lack of tooling is a huge problem. Like you just have to, everything's T-SQL or PowerShell for distributed AGs. So you have to be really comfortable with that stuff. I wish that there was a semblance of tooling, that they would at least pretend to have something for tooling for distributed AGs. So that's a barrier. It's not a starter feature. It's definitely a pro feature. And then I also reiterating what Taryn said on network latency. Having a solid network between nodes is a requirement for any AG, including a distributed AG. If you have latency, jitter, bandwidth, reliability issues, all of those things can affect your ability to sync across the distributed AG.
Those are all good tips. I don't see, as of right now, any questions left. So I think we technically have 2 minutes left. Are there words of wisdom that you'd like to pass along that you haven't yet?
I see one question. Someone asked where I got the Darling data shirt.
Oh, right. Yes.
Max top 8. Or what do I have? Max top 0? No, I have max top 8. There's max top 8 and max top 0 shirts. They are not for sale as far as I know. I think you have to do a favor for Eric and get one. I don't exactly remember. I think Taryn and Aaron both have one too, right?
I have a max top 0 because I'm team max top 0.
I don't have one, but I've heard that if you compliment his tattoos, he may send you one.
That's how my husband Ken got his Darling data shirt. He complimented Eric's tattoos.
Well, those are certainly words of wisdom.
Comment from in the Q&A, SharePoint, max top 1. There are no max top 1 shirts available from Darling data.
SharePoint. We could probably have a whole session on SQL Server in that, couldn't we?
Yeah, I mean, we definitely need to, that would definitely need to be something where we make sure that everyone has their calming liquid of choice, whether it's hot tea or a keg of bourbon.
Yeah, it's interesting to me. There's been some chat here in Slack about distributed AGs and, is the tooling going to come along for the party? It's used under the covers in managed instances. So it's interesting to me that, there's not tooling, because there are scenarios where they're useful for, but everything Alan and other folks have said here is spot on. If T-SQL and PowerShell management scare you, don't do them, because that's how it has to work.
I just wanted to add something really quickly before they stop, before they break off this part of the recording, and that's Alan Hurt's comment in the Slack that says, "Let's be clear, Andy's answer is spot on, know your workloads." And then he added, "Andy's good." So I just wanted it to be part of the recording.
There you go.
You just wanted me to blush on camera?
You don't blush.
Duly noted. I see Aaron's so I was going to say, somebody just popped in and said, "Are you using Windows Core Edition?" Aaron just answered that. So for audio posterity's sake, would you like to comment on that before we switch over here?
On Windows Core?
Yeah.
I don't know of a single server where we've installed Windows Core.
I've actually never run into a Windows Core installation in the wild in my experience.
Yeah, I understand the benefit of it. I'm not saying it's a bad thing to have, just I haven't come across an org yet that has deemed the benefits worth not being able to RDP and interact with it like all of the Windows machines you've worked with your entire career.
And as someone who's not a consultant, I admittedly run into fewer environments in the wild than some other folks. So it's not like me saying I've never run into them is saying that they're not in use, or that they're rarely used, but just that even at companies like Wayfair and Stack Overflow, we just use good old fashioned Windows with desktop experience.
Yeah, so it looks like we've got John Morehouse in Slack, who said he does have a client runs Core. Some other folks noted that they have seen it or have had clients that did, or they did, and the regret seemed to follow shortly thereafter. There is a compliment in the Q&A panel. Great session, great details for real life use of AGs. Thanks a lot for this. So well done, everybody. There's another one that says, "Are you set favor background app for SQL?" Not sure what we're getting at there, to be honest.
I think that's the configuration in the server, set favor background services instead of foreground application. I have no idea, but we don't have any applications that would apply to that are running on our servers. So I don't know that it would really change anything on any of our SQL Server boxes.
All right. This is not AG related. So as we're switching over, because I think the next section starts at 3 Eastern, which is 7 UTC, if my math brain is working right.
Yeah, we have about 12 minutes to the next session, so we're all good to keep chatting for a while.
All right. So this is a nice generic one. What SQL Server 2022 feature do you expect to help you or anybody? I'll add to that the most.
Aaron, do you have to think about it?
Not everybody at once. Come on.
Well, I mean, we are talking about eventually going to managed services in Azure. So at some point, the ability to fail over to a managed instance and fail back to on-prem is going to be pretty important to us. But I mean, that won't be for a while. So not something that, as soon as we start using 2022, we'll be able to use that. That's more down the road.
Yeah, that's the same one I was thinking of. I was thinking of MI link, managed instance link, they're calling it, that'll let you fail over and fail back from managed instance. Because if you're going from beefy on-prem hardware to the cloud, you might not get all of your performance sizing sized correctly. So I love having a failback plan when I do stuff. The other thing that I'm really excited about is contained availability groups, because all of this, like my entire career, I've spent 20 years with nonsense about copying logins from your primary server to your secondary server, and have it, and just all the other stuff that's stored in MSDB that you end up master in MSDB that you end up having to copy across. Just the idea of AGs being able to help you with that makes me excited.
But you already have jobs that sync everything, Andy. I mean, come on.
We do have jobs that sync everything, and they no longer cause us any problems. But
I'd say there are at least 2 of us on the screen right now that have slides that talk about this, probably more that I just haven't seen. But yeah, it will be helpful because, I mean, speaking from my experience, it was an easy step to miss. I have a whole part of a presentation about missing that, because you just don't think of it. You're like, oh, we set up this thing. It's really cool. It just came out. Oh, right. We can't log into anything. And none of our jobs magically went over there. So easing that on-ramp into AGs does strike me as a useful thing. Certainly would have saved me a couple stressful phone calls over the years.
Yeah, and like if you have a job that you create, even if your sync job runs daily or every hour, you run the risk of having made a change that doesn't get synced across when your job runs next. So
yeah, that's all true. I see the display has been taken over. So
sorry, I grabbed it just to get the feedback slide up, just to tell all the attendees that we're going to keep chatting, but please do leave feedback for all the sessions. We send them on to the speakers, and we have a link there for the event as well. So please, as I've said before, after every single session, please let us know what you liked, what you didn't like. Those of you who are commenting about the burritos question, I'm not taking the burritos question out. It's going to stay. So please do leave your feedback. We can only make this event better if you tell us what you liked and what you didn't like in the comments and those questions. So thank you very much. And
when you're leaving feedback, keep this in mind. We did not rehearse or plan for the timing to work out so perfectly. I think it's kind of amazing that we all talked our faces off, but still didn't go over time. I think that's pretty impressive.
I didn't even look at the time until I was done, and
it's almost like you three know. It's almost like you three know what you're doing and have done this before.
I was going to say, I just assume you're all that good. Yeah.
I don't know if people know this,
we've never done this presentation before. That's
right. It's brand new for all of us. Yeah.
I just thought that like Taryn had a shot collar and a remote, so that if when they talked long enough, she just gave them a little zap. They were like, "Over to you, Taryn." Is that not how that worked? Have I been doing that wrong with my co-speakers?
We don't discuss those things.
It authenticates against the Stack Overflow domain. So now that Taryn doesn't work here anymore, she can't log in through Okta to send a shock.
You know she left a back door. You know she did.
So Andrew, I found my snack selection subpar. Am I allowed to leave feedback about that?
Oh yeah, you can leave feedback all you want. I mean, I have total control over all of this, so I can delete all your go nuts.
I do find it's a little hot in the room.
I was gonna comment on the temperature of the room.
It's
in my individual speaker evaluation. So
yeah, no, I once had feedback saying, "Oh, the stage was a bit squeaky." So I'm really sorry. I don't know what I'm supposed to do about that.
Nice.
Yeah, there's not much that can be done about things like that.
One thing I do want to mention, anyone who's watching the YouTube stream, it's been brought to our attention that there is a chat on the YouTube stream that is not being monitored. We are really, really sorry. All the chat is happening in our Slack channel, the 8KB channel, in the SQL community Slack. So I posted a link in the chat there. Please do come and join us. There's been a whole bunch we've got a whole load of SQL Server experts in there as well, all chatting away and talking, discussing things. So please do join us there, because we are literally not monitoring the YouTube chat channel at all, I'm afraid. But next we have Kate Smith from Microsoft talking about intelligent query processing in SQL Server 2022. Kate, how are you doing? We can see you there. You all set up?
I think I'm good. Yeah.
Cool.
I'm as good as I'm going to be.
So we have about 6 minutes. We're going to let all the attendees get a cup of coffee, or if they're, in my case, it's 5 to 8 here. So I'm going to go grab another beer just after you start your session. We'll let them all get sorted out. And yeah, we'll just, in about, I'd say about 3 minutes, what I'll do is I will stop sharing my screen. You can take over, we'll do a quick tech check. And then we'll all turn our cameras and our mics off, and it's over to you.
Okay, sounds good.
So looking forward to this session. It is our last session. I hope everyone is still going, because we've had some absolutely just mind meltiness going through today. We say we want in-depth tech sessions, and we put it out there, and the speakers definitely always rise to the occasion. How's everyone doing that? Anthony's still with us?
Yeah, I'm fixing a typo in the GitHub repo.
I was wondering why you look so, you were concentrating so hard there. He's GitHubbing. No worries.
Exactly.
Andrew, you need to get a fridge closer to your desk so that you can go get a celebratory beer when you're done with your session.
I have to go and climb like 2 sets of stairs to my fridge. So absolutely, go and plug one in down. Just over here, I reckon it'd be great.
Well, hold on. Do they have coolers over there? Like you could just put a 6-pack in a cooler right there by your desk. You don't have to buy a fridge.
This is true. This is true. You're gonna lead me down. Lead me down a very, very dangerous rabbit hole.
How many 8KBs have we done, and we're just now coming up with Andrew needs a cooler? Like, we failed you. Like we have failed you.
I think that's the first time ever someone has said Andrew needs more beer.
No, I'm not saying you need more beer.
Just a way to keep it.
I just think you need it beer closer. That's all.
Yeah, very good.
Just don't get caught in any cupboards or anything.
Yeah. Well, no, we've taken all the doors off every single room in the house. It's not going to happen again.
Wait, is there a story that we should tell?
I'm going to have to follow up on that later.
I'm not going into that story again. I told that story once at MVP Summit when I was having a meal with a bunch of people, and it has followed me around my entire career.
So lesson learned. Got it.
I think I heard it the next day when it was recounted to me after you told everyone at dinner.
Yeah, pretty much happened. Oh no, I've done online events, and I've done in-person things, and people have said, have you checked to make sure there aren't any cupboards around? So it's like, yeah, thanks very much.
Wow. I'm sorry that you're being bullied, Andrew.
Well, I'm a big boy. I'm pretty sure I can handle it.
I'm not really sorry. I'm not really sorry. It's lip service. I'm just, that's what I'm supposed to say. So I'm so sorry that's happening to you. When in reality, it's pretty funny. So have any of you met Kate in person? Or am I like the only person who's met Kate in real life?
No, we haven't met Kate.
No, I'm new to all of you. So you're all new to me. I assume I'm new to you.
No, Kate, how long ago did you transition over to like Azure SQL and that team? It's been at least 2 years, 2.5 years.
Well, I was it was November 2019 that I joined the PM role.
Right. So, and then the world stopped in March, or they would have met you at MVP Summit that year, and blah, blah, blah. Right. So I've actually worked with Kate now over the last 2.5 years in like a variety of things, because they're like, oh, Kate's good at this. Let's move her over here. Kate's good at this. Let's move her over here.
I know. Yeah. Yes, so, I like my career processing. That's definitely.
You do seem to be a little bit of a nerd about it.
Okay, so
like an excited level nerd. Like, oh, we did this really cool thing, and I'm like, here we go. It's awesome. No, it's awesome. I think it's awesome. And you got 100 nerds on the call with you, ready to do the same thing.
No, it's like, so yeah, this talk, like, well, when it's time for me to introduce it, I will, but it's going to be it's going to be more mathy. Like a ton of math.
More mathy.
Awesome. Okay, so what I'm going to do is I'm going to stop sharing my screen.
Okay.
If you want to grab it.
All right. Let me make sure I do this the right way. Okay, so if I do it this way, I have it now. Yes.
Yep. We can see your first slide, no problems. And it is on the hour. So everyone, this is Kate Smith with cardinality estimation, comprehensive look. Off you go, Kate.
Okay, great. Thank you so much, Andrew. So yeah, my name is Kate Smith. I'm a PM at Microsoft, and my pronouns are she, her. I've worked in the space of query processing in various roles for like a decade now. And so I'm going to go and give a comprehensive look of cardinality estimation in SQL Server. So I'm going to sort of give you some history and build up to sort of where we are today. And I'm going to sort of try and tell a story about how we got from, cardinality estimation, what it was, 15 years ago, to cardinality estimation that we have today, and the new features coming out in SQL 22 around cardinality estimation feedback. My goal is not to melt your brains, I'm sorry, but to actually build some understanding and some intuition about the concepts. A lot of you have heard these words flying around a little bit. If you've been paying attention to the SQL 22 announcements and stuff like that. So I want to sort of build a deeper understanding. Okay, so next slide. Sorry. So a little history. Cardinality estimation. When I joined SQL Server, there was a project that was ongoing to rewrite the cardinality estimation module. So cardinality estimation is basically the part of the query optimizer that looks at a particular expression or expression tree and estimates its cardinality, or the number of rows that would come out of it. And as it was existing in the product at that time, the code was hard to maintain. So we were getting bugs and requests for change and things like that from internal, external, and it was becoming very difficult to maintain the code. So the original effort was to rewrite that module in such a way that would be easier to maintain and address issues moving forward. So we did that. What was interesting is, so cardinality estimation uses something called a model, which is a basic set of assumptions that we need to make about the structure of the data in order to move forward. And you'll get a more intuitive sense of what I mean when I say the model as I go through my talk. So don't worry if it's a little weird right now, it will make sense. And that original model had three basic assumptions. We called them independence, uniformity, and containment. Now, we rewrote the cardinality estimation module, and we hewed back to that original set of assumptions. And when we ran it on real customer workloads to see, well, how does this perform compared to the cardinality estimator we had before, we found that it actually didn't produce better plans. That by going back to that original model and adhering to it more strictly, without all the little changes and tweaks that had evolved over time, turns out that model had deviated. And so now we were in a situation where we had to figure out what model would make sense given this information. So we had some very talented, experienced, in the problem space and mathematically minded devs on the team at the time. And so they said, well, here's some variations that we could try. We could try changing this assumption this way or changing that assumption that way. And they implemented a whole bunch of different options around model variants. And then we reran a whole bunch of workloads as much as we could to see which performed best across the majority of them. And it was tough because we still had to pick one set of assumptions, one model to go from to start. We couldn't just say, we still had to have one baseline, right? We couldn't have multiple different models existing at one time. So, but that laid the groundwork, as you'll learn, for what's coming next in SQL 22. So before 2012, we had this assumption of uniformity, independence, and containment. That's what we perceived our CE model to be, although it wasn't quite accurate when we actually reran the tests. But we didn't really know what had been changed. We just knew that changes had been made that made workloads better, right? So then we came and redid this cardinality estimation model, and we still had to pick some assumptions. We picked uniformity, partial independence, or exponential backoff, if you've heard that, and a different take on the containment assumption with regards to joins. You'll understand that better later too. But CE feedback, which is coming out as part of the intelligent query processing improvements coming in SQL 22, changes all of that. It diverges completely from this one-size-fits-all model. Now, for every query, not just every workload, but every query, you can choose, well, you don't choose. Actually, that's the cool part, is we can try, well, for this query, maybe this model variation would work better. And for this query, maybe this one. And we could automatically test that out, decide if it really is better, and then encapsulate that using Query Store in such a way that you don't even have to change your code, and you get a different model that fits your query better on a per query basis, which is super cool. Okay, so now I'm going to dive into this concept of uniformity. So we're going to have some look at statistics. Those are the building blocks of cardinality estimation, right? So underneath cardinality estimation, there is statistical data about the columns and tables in your database. And if you've ever done a DBCC, show statistics with histogram query, you would get a response that looks like this. It's got sort of these different columns, right? High key, range rows, EQ rows, distinct range rows, and average range rows, which is derived from range rows and distinct range rows. And I'll explain that. So here's a picture of a histogram, okay? So the black lines, vertical black lines, correspond to those EQ rows. Those are heavy hitters, data values in your column that are at a high frequency. And so we give them their own information. We create a histogram step and we make that the EQ rows value. And then that range rows, range high key is, and then EQ rows is the number of values corresponding to that high key in the column. Then you can see here in our picture, you've got these column values that are sort of the in between those black lines, the red dotted lines, and those are the other values that actually appear in the data. But instead of keeping track of each individual value, we put them into that bucket. That's the space between the two black rows. And within that bucket, we keep track of the number of rows that we've seen in total between those two, in that bucket, and the number of distinct values that we've seen in that bucket. And we can use that to compute the average value for anything in that bucket. We just assume an average across that it's flat, even though you can see from the data it's not. That's what we do. So because the alternative would be to keep every single data point again in the statistics, which I don't know how useful that would be. At some point you have too many steps. So so that average range rows is where this uniformity assumption comes in. We assume that all of those distinct values in that bucket are evenly spaced and that they all have the same frequency. Again, average range rows. So within each histogram step, those distinct values, we know that they're not actually evenly spread in most real world data, but we assume that. And each value has the same frequency. They all occur at that same average range rows occurrence. So let's give an example here. So here is, we want to estimate the selectivity of a column equals constant predicate, select star from T, where T.C1 equals 50. So you see our picture down below. we've got a bucket boundary at 58 and a bucket boundary at 29. So 50 is going to fall somewhere in the middle there, right? We assume, okay, that 50 exists in the histogram bucket. It may not actually really be there, but the assumption that's built into our model is that it is there. That is a take on the containment assumption that if you query for it, it is there. And that part of the containment assumption still holds in SQL Server today. It is only with joins that we've changed it, and we'll talk about that later in the talk. But we also assume that the frequency of value 50, meaning how many values are in there, is the average frequency of the bucket, that where that green area is. That's the number of 50s that we would say there are, because it's within that bucket boundary. So that's how we use uniformity today in SQL Server when we interpret our histograms. So let's talk about CE feedback, uniformity, and row goal. So this is part of SQL 22. So row goal is a feature that can apply to queries of type select top n star or fast n or in or exists. Okay, so these types of queries, we would want to know how many rows do we need to read to get the top n of this value, right? And we want to optimize the query so that we can read as few rows as possible to get the result that's requested. So if there's a large percentage of rows that match that predicate, then maybe we don't need to scan that many pages. We can just do a table scan and we'll find that very quickly, right? If the data is not uniformly distributed, what could happen is that even though we think we might just need to look at a couple, the data might be spiky and might be in a different place in the index, and we might have to scan a lot more pages than we originally thought. And therefore, that row goal operation was inefficient. So CE feedback can disable the row goal scan and enable a seek, so that we would just get that specific seek to the values that match what we're doing top n on. So let's move to a demo, unless there are questions.
Yes, so there's a couple of questions. So can you pin a CE path in Query Store in 2022, much like pinning a plan?
Yes, yes, I think you can. And we'll talk about that. You would use Query Store hints to do that, and I'll show you how it works. I'm going to show you right now how that works. Yeah.
One more question. This person thinks that they have 200 steps in a histogram, and they don't think there could be too many more. Is that different in 2022?
No, we have not changed the underlying histogram structure. It's still 200.
Good. That's all we had so far.
Okay, sounds good. All right, let's bring up the demo here. Okay, I'm just hoping you can all see just fine. Can everyone see? Yes? 3? Okay.
Yes,
right.
Sorry, I was muted. Yes.
No, it's fine. I just want to make sure. So I'm just going to set up my environment here. I'm using AdventureWorks 2016. And I'm doing a bunch of stuff to like set up Query Store and whatever. And then we're going to clear the plan cache and drop the buffers. And then we're going to create an X event session. This isn't really interesting. I'm just showing you that this is what I'm doing. And then we'll start the X event session. Right. Start. Okay. Let me refresh this here. There we go. All right. And then we'll go ahead and we'll select watch live data. And I'm going to just put it over here off to the side right now. Nope. That's not what I wanted. There we go. Put it off to the side right now, and we'll see. We'll drill in on that as events show up. So here I have a query that shows I'm basically selecting that top 1500 from sales order header, joining sales order detail with a filter on the date, and we're gonna run it a couple of times for CE feedback to say, this query is one that we do indeed want to start analyzing. If the query isn't run very frequently, it doesn't make sense to trigger analysis on it, because we wouldn't want to analyze every ad hoc query that comes through. We want to make sure that it's a consistently run query so that we're not working too hard for very little benefit, right? And then we'll flush that information to the query store, make sure that that's flushed. And we can look at the plan that we got here. Let's come over here and look at our query plan. That would be the wrong one that I clicked. Hold on. Why did I not run it? Sorry. This is what happens. I'm like, I will do a live demo. Ha ha ha. Okay, well, I guess the plan wasn't there, but it's very frustrating. I'm sorry. All right, let's look at it. So this is the plan that we have now. Okay. I apologize because this was supposed to work and then it didn't show up, and now this is what happens when you do live demos, people. It's dangerous stuff. That's all right. We can still look at what's happening. So we executed the query enough times that CE feedback created this X event that it thinks that it would be better if we disabled optimizer row goal. Okay. And so it says, we think we might try that. Okay. And then you have to execute the query again, and it tries to validate that. What it does when it tries to validate it is it looks at CPU time and compares the CPU times. Okay. And it says, okay, yes, the CPU time in this one was faster than the original. So we're going to disable row goal. And and then once it's disabled, the feedback gets applied, and it's consistently applied. So then we can alter, we can stop our X event session, kill that because we saw our X events, but you can see where they're applied in this table query store query hints. So with there's a feature coming out for query store hints in SQL 22, where you can apply hints to queries. You can do it as a user. You can specify a hint, or you can actually CE feedback can also put the hint there, and then you can see what, for this query. This is the hint that we're applying. This is the source, so it came from CE feedback. Here, I'll zoom in so you can see that better. And then you can look at what that feedback is. Another place that you can see what's happening is if we look at query store plan feedback. So here you can see CE feedback added this hint and verification passed. So that feedback was verified, and it is now being used, applied to that plan. That's pretty cool. So that is the row goal demo for this feature, for basically how CE feedback works in a way that changes that uniformity assumption a little bit. All right, are there any more questions, Rhea? Are we good?
Oops, hold on, something just popped up. Is query store feedback adding hints part of the auto tuning option that you enabled earlier?
I don't. Oh, you mean when I set up the query store?
That's the extent of the question, but that sounds like a probably.
No, I think it's, you just get this when you have query store enabled and you're running your queries under the right compatibility level. You will just get those the hints, and you will just get. Was the question about the hints or the feedback? Sorry, it was about the hints.
Is the query store feedback adding hints? Is that part of the auto tuning option?
No, I believe that the adding the hints is just part of how CE feedback works. That's the mechanism by which it affects change on your workload.
Okay, perfect. That was the only question, so you're good to go.
Cool. All right. So let's talk about the independence assumption. So, all right. Remember back when you were in college and you took a basic statistics course and you talked about probability and statistics, right? When you've got predicates that are independent, you multiply their probabilities, or the word that we use a lot in cardinality estimation is selectivity. You multiply the probabilities by one another to get the probability of a conjunctive clause. So the probability of P1 and P2, when P1 and P2 are truly independent, is equal to the probability of P1 times the probability of P2. So imagine that you have a database with, and this is obviously a very contrived example, but first coin flip is heads, second coin flip is heads. And the selectivity of both predicates, let's assume it's a fair coin, is the same, 1/2. So the selectivity of that conjunctive clause is 1/2 times 1/2, or 1/4. Quick refresher on independence. All right, similarly, correlation. Take, for example, a data set that has the city of Seattle and the state is Washington. Now, let's assume that there are no data points with the city Seattle and any other state, okay? Let's just, that doesn't exist in our data set. Even if it exists in the real world, it's not in our data set. So the selectivity of P1 is 1/10. The selectivity of P2 is 1/3. In the case of complete correlation, where everything that is in Seattle is also in Washington, you would take that most selective predicate, or min selectivity, and have it be 1/10. So to sort of tie the concepts together, I'm going to contrast that with what independence would give you, which is a probability of 1/30, or a selectivity of 1/30. So we're not done, because now we talk about partial correlation, or a concept you may have heard or read about as exponential backoff. Here we've got city equals Redmond and state equals Washington, but in our data set, there's also a Redmond, Oregon. So the probability of Redmond might be 1/20, and of Washington might be 1/3. So with correlation, okay, we know that they're not correlated and they're not independent. So there's something in between here, right? So correlation would give us a probability of 0.05. That's 1/20, but I translated it to decimal representation so that we could place that more easily when we talk about the partial correlation number. Independence would give us this, 0.1612 number, and then partial correlation, or exponential backoff, ranks the predicates in selectivity order. All right, so start with the most selective times the next most selective, but we raise it to the power of 1/2, okay, to weaken the weight of that predicate. If there's a third, we would then weight it to the power of 1/4. It's exponentially backing off the weight of those sequential predicates in that clause. And you can see that this approach gives us a number that's somewhere between 1/20 and 1/60, and might be a little bit more accurate for the data as it actually appears in this case. So what does CE feedback do? Well, it actually allows us to move in between. We still start at sort of this partial correlation assumption, but we can actually look at the data from the conjunctive clause in reality and say, oh, we overestimated, we underestimated. Let's adjust our independence model for this query appropriately, and so we can move in either direction to sort of adjust to the actual data and the query as it's operating against that data in real time. It's pretty cool. So I'm going to move to a demo, but I'll check in. Rhea, are there any questions?
Not right now. You're good.
Okay, sounds good. Okay, row goal is done. All right, so this is correlation. So I'm gonna use AdventureWorks for this database. I know you have to watch me set it up every time just because I gotta make sure that it's all good to go. We create an X event session to track what's happening. And then we'll go ahead and start our X event session. Select watch live data so we can see what's happening in real time. And then we're going to execute a query. So again, here we are. We're just selecting address information from person.address. That state province ID actually corresponds to Washington State, and city is Redmond. So we can go ahead and run this a number of times. And then we'll flush that data to the query store. And let's have a look at the plan. Oh, good, I have 2 plans here. That's what we wanted. And so you can see here that our actual number of rows was 121, but we estimated 44. So we underestimated. Underestimate would mean that we're assuming it's more selective than it is in reality. So what's the right assumption to make? If we started in partial correlation, would we move to the full correlation or move to full independence? I'll answer that for you. Actually, I wanted that still open, I think, but the answer is we would move to full correlation. So I know that the example I just talked about in my slides shows that well, we'll see. That is not what I meant to do. I am pushing the wrong buttons here. I'm sorry. I know. All right. Okay, here we are. All right. So here we have, we're going to execute one more time, and CE feedback should wake up and kick in. And you can see over here that we did, in fact, get an X event. And the hint that we think might work is this. It says assume minimum selectivity. And what that means is assume that the selectivity of the predicate is the minimum selectivity, is the selectivity of the minimally selective predicate. So if you remember, that corresponds to that completely correlated assumption, right? So let's assume that it's completely correlated and try that. So we go back and we'll execute one more time, and that should validate whether or not this adjustment made any difference. So if we look at the execution plan that we got here, you can see that our actual number of rows was 121, and we estimated 121. So our estimate was exactly right. So that's perfect. The data is completely correlated in this data set. However, if we come over here to the validation X event, you can see that the plan hashes, sorry, these are the plan hashes. I didn't expand the column, but these are the plan hashes. The validation plan hash and the original plan hash are the exact same plan. As a result, we didn't actually change the plan. So that original CPU time of 0 basically means the plan hashes are the same. It doesn't matter if this feedback is applied or not. And so even though that's our new CPU time, it still doesn't actually turn out to be better than the old CPU time because the plans didn't change. So in this reality, we don't get any change to the plan. We go back to this one. With the difference between 121 and 44, but remember it's the same plan. And so you can even see here in Query Store hints, no hint was applied. Okay, the feedback ran. It was validated as not being enough of an improvement over what we had before, so it's not worth, you know, basically we aren't going to apply that hint. But you can see in Query Store plan feedback that we did try this hint. We don't have a hint that's currently being applied, and verification regressed. So you can see how CE feedback works in a do no harm way. to make your workload run better without without harming how it's actually working. Are there
So I have
questions?
a couple of, yes. So first of all, every time that pops up when you close it and it asks if you want to save, I think it's popping up on my screen and I panic. Like, what did I just do? Like it pops up. No, it's me. I'm an idiot.
Okay, I won't do that.
It's funny because every single time, it's not even after the first time I went, oh, hey, no. Okay, so since the 44.x row estimate comes from between histogram entries, does CE feedback adjust stats to replace a histogram to match the value equality for that specific query's value? Or is the histogram left alone and CE feedback handles this elsewhere internally?
So it's the latter. CE feedback does not change the underlying on-disk structure of the histogram. And it is because it's also worth noting that this data, I mean, maybe there's a multiple column histogram underlying. I didn't actually look at the underlying statistics objects, although that's a very reasonable question. But it's that conjunctive predicate, right? It's the two. So you can't, unless you're looking at a multi-column histogram, you would still have this question of predicate equals constant and predicate equals other constant. And then that's harder to like look directly into the histogram, if that makes any sense.
Okay,
maybe I confused you more.
I think you did great. Because you ultimately answered his question, right? Yeah. So let's see, can you use that hint in your query to tell SQL of known correlations ahead of time?
I don't know. That's a very good question. I know that query store hints is a new feature that you can use to apply hints to your query. Can you do it manually? I will find out, and I will follow up on the Slack channel. If that does that work? Is that the right place?
That works perfect. Thank you. I'll grab the question. You're good to keep going. So what makes SQL Server decide that it needs to improve a plan?
So it looks like CE feedback. Okay, there's a couple of things. One, it has to be a commonly executed query, right? So it has to be not an ad hoc, but a commonly executed query. Two, we need to see a difference between sort of the estimated and actual performance at various points in the plan that we think we can change. So we obviously have implemented some changes that apply to certain situations, but we have not done it all, right? So we look at, in this scenario, do we think we can improve it? And that's basically what we're out to do. So we look at a plan and we say, you know what? We had a conjunctive predicate of two or more predicates, and our estimate was not correct. So we might as well try, and we make that an adjustment in a smart way, right? As I sort of talked you through in the demo.
Okay, then last one for this section. Mm-hmm. How does this affect low cardinality estimations from UDFs? Will this allow more accurate rows returned from UDFs to affect a plan's operator choices?
So we do not currently have a UDF specific, I don't know what I want to say, model variant for CE feedback. Not at this time.
Okay, perfect. Okay, you're good to go.
Okay. All right, so let's talk about containment. This is the one that I think is kind of the most confusing. I've seen it presented a couple of times. I had to go back and do some research, but I found a way I think I can explain it so that it makes a little bit more sense. So containment as an assumption, we just use that word broadly, but it means more than one thing. Now, the basic idea, and this is why we use it broadly, is if you query it, it's there, right? So when we look at joins, we assume that things join. When you look at equality predicates, as I showed with the histograms example, you assume that things are there. If it's in a histogram bucket, we assume it's there. In fact, if it falls outside the range of the histogram, we assume it's there because we have to do something. And then when you're probing, so that's that first value. When we're probing histograms with the quality predicates, if you're querying for it, we assume it's there. So that's one meaning of containment. Another one is containment as regarding joins. And there are two different approaches. The names for them, which are not particularly intuitive to me, are base containment and simple containment. So I'm going to spend some time drilling into those two concepts. Cool. So base containment. All right, great. I busted out the relational algebra. All right. So here we've got a join between a sales and a returns table on receipt number. There are two filters on the tables. There's a filter on sales and there's a filter on returns. Now, what base containment does, it doesn't assume there's any correlation between those, that receipt number join predicate and any of the downstream filters. So, but it is reasonable, of course, to assume that every receipt number in the returns table exists in the sales table. That makes sense. You can't return something that you didn't sell in the first place. So, that makes a lot of sense. And that's how base containment works. It assumes that there's a correlation or containment of all returns are contained in sales tables. And then you would calculate that join and then pare down the number of rows based on the filters that are there. So it applies the selectivity of those non-join filters after calculating the join on those base tables. That's base containment. I hope you're not confused yet, because we got more. Oh, sorry, we'll stick with this example real quick. You can see in this example, that makes a lot of sense. But there are other types of things you might be joining that wouldn't make any sense at all, right? Store sales and, I don't know, store locations. That there's no reason to assume some sort of correlation. I mean, the join would be different, but you would assume there's no like intuitive containment or correlation, underlying connection between those tables that would make this assumption particularly meaningful a priori, right? So in this scenario, it makes sense, but it doesn't always. So now let's look at simple containment. This assumes that the joins are fully correlated after the filters, okay? So for example, okay, what that means is we're assuming that every that every item that was returned on January 1st, 2013 was a toy. There's like this simple, we do the filter and then we assume that everything, that containment, that sort of matching exists at the join level after doing the filters. And that doesn't really make a lot of sense, but you could think of some examples where it might make sense. Users do know their data pretty well and they understand what they're doing a lot of times. And so those filters could, in some situations, actually filter out the data so that that containment assumption does hold. But, in this example, it doesn't make sense, but you could potentially think of examples where it would be pretty intuitive. All right, so what does CE feedback do? It makes that adjustment. Basically, it's got two containment models to choose from. We start with a baseline of base containment. And then we see if it works, right? So we apply the adjustments only to joins. Again, that containment we talked about with histograms is not touched by this modification that's used in CE feedback. If the estimates coming into the join, right, those rows coming into the join are pretty good, but the estimates coming out are not very good, then it's likely the containment model is wrong. Now, we really have only one option. So if we think that it might be worth trying a different containment model to see if it helps, we try it. Again, you've seen already how CE feedback will try something. And if it doesn't see enough improvement or the type of improvement it's looking for, it will go ahead and turn off its own feedback and say, I'm not actually going to do that anymore because it didn't help the way I was hoping. So I'm going to move to a demo, but I do have a chance if there's any questions. Good. Okay.
There are no questions at this time. Sorry. It's
No,
the mute button is in the little speaker is in a completely different space than Teams. So I keep
is very, I know. I'm familiar with what you're talking about there, Ree. I'm like, what is this new software? I'm clicking all the wrong things. That's what it feels like. I'm going to go ahead and start. I'm going to close that. I'm using a database, TPCH. I'm using TPCH, the plan cache, etc. Create our X event session. Give it a start there. I'll go ahead and click Watch Live Data. All right, so here we have a query. We're joining customer to orders, where the customer, the market segment is building, and the order date is some date, specific date in 1992, and the customer key is less than a particular value. And then the equality predicate is on that customer key. All right, so we have to run this query a certain number of times for it to be valid for CE feedback. And then let's go ahead and flush that information to the query store. And then let's look at our plan here. So here you see we're doing a seek on each of these tables with a sort there. And our actual number of rows was 7, but we estimated 107. So we estimated that there would be a lot more rows than there were. So it's possible, but sorry, let me go here. Our actual and estimated number of rows for the incoming relationship, that's for the top one, 2,000 versus that 4,000. That's not, I mean, it seems like it's double, but it's not too bad. And on the bottom one, it was 41 versus 160. So let's see, we'll execute the query another time. That should trigger CE feedback thinking, maybe I should try something. So we can come over here and have a look. All right, I'll zoom in here. All right. So this option, this assume full independence for filter estimates, that is basically, we're trying to say, let's use simple containment instead of base containment for this query. So we go ahead, execute it another time. And what you can see is that the CPU time was originally, 5,500, 5,600, and now it's like half, less than half of what it was. So we definitely speeded up the query. I'm going to make this a little bit bigger so we can look at the plan. And that estimate, the estimate going in, that got better. And this estimate going in also got better. And the estimate coming out is a lot closer. I think it was 107 to 7, and now it's 12 to 7. Much, much closer. When you're looking at this as a, planning a query, this might be just a subset of a larger query. It makes a huge difference to see that kind of a small change. Well, it's sort of a big change, but that improvement in accuracy really makes a difference. So we can stop our X event session. And if we look at query store hints, yes, indeed, that option is there. And I'll move this over so that we can look, and you can see that the source was indeed CE feedback. And then you can also see that it is here in the query store plan feedback table. We have using this since it just says independence, but that's what it means, and the verification passed. So yes, it does appear that that adjustment to the query made a difference. Anyway, so that's the demo. I'll pause again for questions in case there are any.
We are good. Let me peek at chat at Slack really quickly, but I think you're caught up.
Okay.
You're good. Okay, yeah, you're good to go.
Awesome. So I'm going to just summarize what I talked about here. CE used to have this one-size-fits-all approach called the model. There really wasn't another way. You had to have one way of trying to approach these estimates. There wasn't an easy mechanism. There wasn't a built-in mechanism to say, well, for this query, let's do it this way, or for this query, let's do it this way, right? We've tried a number of variations over time to try and get that sweet spot where it's pretty good for most everybody, but we know that it's not going to be perfect for everyone. That's sort of, in my opinion, the beauty of working in the query optimizer, because you almost never win across the board. There's always this sort of, you make incremental improvement in one area and you try not to do too much harm in the other area, and you've got to find that right balance. And that makes it an interesting problem space to work in. But with CE feedback, we can now dynamically adjust. We've got, for this query, this model works well, and for this query, this other model works well. We do that in such a way that it's for your individual queries based on what we're experiencing in your workload. And we do it in a do no harm way. As you saw, when we didn't really help, we disabled. We said, no, we actually aren't going to apply feedback to this because it's not helping enough. And by using query store hints, this feedback is going to persist. There's no code change required by you. It happens automatically, and the feedback will persist. So if you, clear your plan cache or your server restarts or anything, that feedback should still be there in query store hints. Other questions now, Free?
Yes. Can we turn off CE feedback for some queries?
I don't think so. I don't think so. I think you can disable it on a database level, but I believe I will double check on that. Ree, can you? I'll post it.
Yes. Nope. I'll put it over in Slack, and you can follow up later. Okay. Are we able to manually add query hints in Query Store? For example, we test with CE feedback in dev and find some queries are consistently improved. So we want those to have these hints in production without turning CE feedback on.
So there is a way to apply query hints manually using Query Store hints. Yes. Can you apply the CE feedback hints? I don't know. I think you can. I think that was the other question too, Rhea, if that was one of the first questions. But I know that you can manually apply the hints. Yes, absolutely. And my intuition says that you should be able to apply the hint from any source. You saw in my example that we record the source of where the feedback came from, but that I think that's helpful for users to know. But if you apply it manually, that hint should still apply. But I will double check on that. I think that was also the other question I needed to follow up on from before. So
okay, so he has a follow-up question. Can I still force query plan with the plan guide mechanism?
If it's working for you now, I see no reason why it wouldn't. Is the question, when you force a plan, are the hints applied?
We can wait until he pops in.
Sorry.
To add clarity there.
It's hard to have a dialogue. I'm sorry.
I know. No, it's okay. So yeah, that's all he says is, can I still force query plan with the plan guide mechanism? So
okay. Yes,
you can circle back if you want to move forward. That's all the questions that we have right now.
Okay, sounds good. But that's basically all I have. I hope I didn't. Let's see. I guess I left some extra time. But I hope that was insightful and instructive, and that you all got something out of it. Thank you.
I think you broke us, Kate. I mean, in the best way, right? Look, Anthony. Look, Anthony's like, I thought, yeah. Look at Anthony.
I was So you about your brains specifically. I wanted to build intuition.
So it's be careful what you wish for, I guess.
Yeah, no, that was great. That was great. I went ahead and updated the website so that your level is an 8192 instead of a 400.
We have to have a little chat about the levels, I guess.
So no, here's the thing. Here's what's important to know. To Kate, like this, all the algebra the algebra rabbit hole that she took me down, which I did not sign up for the record. So she's just like, oh yeah, this is just easy. This is all that means. And we're all like, what? Oh, hold on.
No, it was good.
Like,
it was fantastic.
No, it was
this is
fantastic.
Yeah, this is what
this is exactly
right?
that type of session is exactly what EightKB is all about. So thank you so much for coming in and delivering that.
Kate, you do have to go into Slack and like read the comments. And save that link for like when you have a bad day. Just go in there, and people are like, "Wow, this is what?"
Yep. We've already had feedback coming in on the forums as well, and one of the comments is this is the best session ever. So
I'm already being read. It's not fair. You guys stop.
Feedback was good enough that I've actually already sent a note to Ajay.
Oh, well,
I already sent a note to Ajay. So just so you're
Yeah, it's so valuable. I love when you started with the historical context of how we got where we are, and then like the behind the scenes perspective of like building this thing, and it's so valuable to the community, like what you delivered. So thank you.
Good. Well, yes, I actually have been around working in this space in a way that makes it's a perspective that is unique. Not everyone has that. So yeah, I'm happy to share it because it's really cool. It's really cool. I really like this stuff.
So Erin Stellato messaged me, by the way, and she says you can still use plan guides when you have QDS enabled, but you should not try to do plan guides and plan forcing on the same query. Just, okay. I think that was in reference to an earlier question.
Okay. And I think if you're forcing a plan, I don't know that you get your pre-strip, but I think that was I will double check, but I don't think you will. I think you'll just get what's in plan.
Okay, so that is the end of EightKB August. Oh, sorry. We are gonna wrap up, I think. Yeah, unless there's more. Is there any more questions? Any more comments? Anything?
No, we're good.
We all good?
I don't see any. Yeah, I mean, I can dig through.
Yeah, we will. The Slack channel is always there. We keep that up. That's just constantly there during the year. So if you do have any questions, we do monitor it. So if you have questions for the speakers, please post them there, and we will forward them on. Now, the link again. Just repeating it. Please do leave feedback for the speakers and the overall event. We want to know what you liked, what you didn't like. Please let us know. The link is there. Go on there. It's only 4 questions and a comment box. Let us know. Thank you so much. And thank you so much for all attending. I want to say thank you all to our amazing speakers. We've had 5 amazing sessions. It's been absolutely fantastic. And I want to say thank you to all our moderators as well, some of which have been here all day, helping out, making sure your questions get answered, monitoring the Slack channel, monitoring the Q&A in Zoom as well. They do a fantastic job allowing me, Anthony, and Mark to sort of make sure everything in the background is running smoothly, which is code for sitting here and basically just watching sessions. But thank you, and we will be back. We will see you all again. Thank you very much. Goodbye now.
Thanks, everybody.
Oh, wait, what button do I press? Oh. We're a professional operation here. We are a professional operation.
You're gonna edit that out though, right? I mean, what
we leave it all in.
It's live.
Here, I'll
Mark,
take over hosting.
You go, Mark. You know what you're doing.
Yep.
Fantastic job, gentlemen.